they can be opportunities that are environmental performance. Network, CRIN for short, is a Canadian initiative founded with a purpose. The Clean Resource Innovation Network, CRIN for short, is a Canadian initiative founded with the purpose of enabling cleaner energy development by commercializing and adopting technologies for the oil and gas industry that reduce environmental impact across The Clean Resource Innovation Network, CRIN for short, is a Canadian initiative founded with the purpose of enabling cleaner energy development by commercializing and adopting technologies for the oil and gas industry that reduce environmental impact across the energy sector. To achieve this goal, CRIN is focused on 7 theme areas. By sharing expertise and knowledge across a range of sectors and focusing on the theme areas that will have the largest impact on the environment, CRIN is committed to making progress on many environmental challenges, including one of the most pressing, climate change. Industry that reduce environmental impact across the energy sector. To achieve this goal, CRIN is focused on 7 theme areas. By sharing expertise and knowledge across a range of sectors and focusing on the theme areas that will have the largest impact on the environment, CRIN is committed to making progress on many environmental challenges, including one of the most pressing, climate change. Industry that reduce environmental impact across the energy sector. To achieve this goal, CRIN is focused on expertise and knowledge across a range of sectors and focusing on the theme areas that will have the largest impact on the environment, CRIN is committed to making progress on many environmental challenges, including one of the most pressing, The Clean Resource Innovation Network, CRIN for short, is a Canadian initiative founded with the purpose of enabling cleaner energy development by commercializing and The Clean Resource Innovation Network, CRIN for short,
My name is Jeffrey Cann, and I'm an author, speaker, and trainer on digital for the oil and gas industry. You can find my book, Bits, Bytes, and Barrels, at any online book retailer such as Amazon. Or you can follow me on Twitter at Jeffrey Cann, subscribe to my weekly newsletter through my website, or listen to my weekly podcast called Digital Oil and Gas, which is available everywhere. Did you know that 2 long-running debates in oil and gas have finally come to an end? It's true. There is now a general consensus that climate change is somehow linked to the burning of fossil fuels. And 2, the resources industries can really benefit from digital innovation to lower their costs and boost their productivity. Now, these 2 evident truths are linked to a third phenomenon. Capital markets now decisively favor digital companies over energy companies. I know, it's hard to take in. But for oil and gas to win back capital's love, and oil and gas needs a lot of capital, it must convert its business as quickly as possible to zero emissions, and it has to really accelerate its adoption of digital innovation. And we as a society, we need a strong, well-run oil and gas industry because after all, we need fertilizers, plastics, paints, pantyhose, toothpaste, and hundreds of other products. And we still need gas for heat and power. And we need the people today working in oil and gas to want to stick with this industry, and we need young people to want to take their places. But how? How are we going to do this? Who does this well? And what does good even look like? Well, that's the subject of my next book, which is due out in February of 2022. And today I'm going to provide you with a sneak peek into its key messages. Now, to be very clear, this does not absolve you from the obligation to buy the book. My remarks today just number 3,000 words compared to over 115,000 in the book itself. And by the way, the best way to buy the book is in very large quantities. Now, the book is extensively researched with over 180 sources, but most importantly, I garnered the cooperation of 9 case companies to participate as case studies. These companies include McCoy Global, a maker of torque tools for drilling; 3 upstream companies, the upstream group of an integrated company, which is part of Exxon, a gas producer, and an oil producer; a midstream company spun out of a large pipeline operator; and finally, a European downstream operator, Varo from Zurich. Also, a global integrated producer, Repsol from Spain, and 2 global EPC firms, Wood from Aberdeen and Worley from Melbourne. Now, here's a typical story. In 2018, I met with the CFO and VP Finance with NAL Resources, and I interviewed them for my podcast. They had some rather pointed observations to make about the industry and its challenges. Here's just one of them. We have to do things we never planned to do, and we don't have the skills to do it, and we have to do it faster. And this was back in 2018. If you remember to 2015, the price of oil had collapsed because of the rise of shale oil in the US. For almost a decade, all of the growth in the global oil industry went to America, who had successfully unlocked the riches from its tight oil. Russian sales were basically flat, and OPEC had grown only modestly. Now, if you're OPEC, this is appalling. The low-cost producers, Russia and OPEC, who are backed by their national governments, are losing ground to the American free market, the fracking revolution, and Wall Street's cheap capital. But then after a time, the Saudis snapped, and they stopped supporting the market, and the price promptly fell. NAL wasn't into fracking, but it didn't matter. The price fell for everyone. NAL tried everything to right the ship, but it was of no use. And in almost desperation, they finally turned to digital. And the CFO decided to run a little trial of something called robotic process automation to see if some of the manual work in finance in oil and gas could benefit. And boy, did it benefit. Their first robot took weeks to tune, but eventually it cut royalty calculation by 95%. A fluke, said the employees. Do it again. So they built a bot to do battery balancing, a much harder process. Got the same outcome, 95% productivity improvement. Now, RPA is an old technology for online gamers that automates dull and routine tasks in games like picking up armor, putting on uniforms, and collecting coins. RPA tools are so powerful, they're actually banned on social media platforms like LinkedIn. If you get caught using a bot on LinkedIn, you're booted off, like I was. Oil and gas? We ignore these tools because you know what? They're not built by our industry. Leading companies working in oil and gas, especially those involved in helping the design and build of new assets or debottleneck older assets, have picked up on these 2 megatrends: energy transition, digital transformation. The past year has provided plenty of evidence about the pressures looming on our climate. Did you know that 2020 turns out to be the second hottest year on record? Temperatures in the Middle East, they broke records in June. It hit 124 degrees in Abu Dhabi, Iran, and Kuwait, and 122 in Oman. At that temperature, your country becomes uninhabitable. Or how about the Atlantic Meridional Overturning Circulation, also called the Gulf Stream? It's at its weakest level in 1,000 years. The Pacific Northwest, where I live, got a heat dome in June, a once-in-a-thousand-year event, and it broke temperature records and killed hundreds of people. Or how about cherry blossoms in Kyoto? They bloom 3 weeks ahead of schedule, and the earliest since the year 812. And lastly, Summit Station on the Greenland ice sheet gets rain for the first time in recorded history. I make a living in the oil and gas industry. This feels totally unfair. And I blame coal. It's coal's fault. They did it. But our reality is that big parts of the world are now moving on. In July, the EU announced that only zero-emissions vehicles could be sold there in 2035. European automakers are now on notice to electrify or go out of business. No hybrids, and no hydrogen. General Motors has announced that it will end the production of gasoline cars and light trucks by 2035. Ford will only sell electric vehicles in the EU by 2030. And Volvo will convert entirely to electric by 2030, and then it'll only sell online. Or how about Shell losing a lawsuit in the Netherlands, and they now have to reduce their emissions by 45% in just 10 years. Exxon now has 2 climate activists on the board. And Total Energy just withdrew completely from the American Petroleum Institute. Young people have gotten the message. Calgary has had to shut down its petroleum engineering school due to a lack of enrollments. And 2 years ago, of 180 geology grads, just 3 scored jobs. This does not leave our industry in a healthy place. And with it, our livelihoods, our homes, and our pensions. We've also been farting around far too long on digital. In 2019, a conference organizer contacted me to discuss his plans to bring a digital oil and gas event to Calgary. He was baffled. He had pitched the idea to several large oil companies who all told him there was no need for such a conference as the Canadian oil industry was already digital. In 2019. Now, there are many possible explanations for their lack of enthusiasm. Perhaps digital was indeed a done deal and it was already complete. Perhaps these oil companies didn't want to bother encouraging yet another conference in a city pummeled by low oil prices. Ain't no one got budget for that. Perhaps they all wanted to deflect attention away from their own secretly successful plans. And perhaps he managed to speak to the 10 least informed people in a city of 1 million. Whatever the reason, he called to get my opinion. Well, in my view, they honestly believed that with their Excel spreadsheets, their SAP systems, and their SCADA environments, they were indeed as digital as they needed to be. And then, along came that malignant little bastard COVID-19, and it took a complete wrecking ball to the narrative in the industry that digital was already done. In the space of just 2 weeks, Petrobras lifted its entire office-based workforce to work from home. Imperial Oil had long been planning to move one of its control rooms from the Kearl Oil facility to Calgary, which is a project which started after the fires in Fort Mac. This project bumped along for 3 years, and then they moved it in 2 weeks. Almost all of the tech companies I interviewed for my book and for my weekly podcast have announced they're full speed ahead in digital adoption. In fact, one executive has said to me, the industry has achieved 20 years of change in just 18 months. And in all of this, there were no interruptions of fuel and energy supply. Now, in part, this was due to a reduction in economic activity, which led to a surplus of standby capacity, but it was also due to the fact that the industry had invested extensively in digital capability that was latent and standby. Microsoft Teams, for just one example. It was there, it just wasn't used. Teams has helped the industry avoid a ton of unnecessary travel, which is part of our emissions problem. And now, capital market pressures are making it painfully difficult to raise money for fossil fuel projects. Apple is now valued at $2.5 trillion and had a 2020 EBITDA margin of just $111 billion, or only 4%. Sinopec is valued at $800 billion, a quarter of that, but has an EBITDA of $184 billion, or 30%. Royal Dutch Shell, market cap of $154 billion, EBITDA of 53 billion, or 34%. Markets are clearly ignoring these immediate financial outcomes like revenue and EBITDA. And this isn't just an energy market issue. Tesla is now worth more than the next 5 auto companies combined. Capital again. I believe that there is a digital sweet spot, an optimal use of new technology from digital transformation that simultaneously helps the industry improve its capital markets attractiveness and assists with energy transition. Let me show you where you can find it. To find the digital sweet spot, you first have to come to grips with the 2 governing laws in the digital world. So the first one is called Moore's Law. Now, many of you are thinking already about Roger Moore, vodka martinis and misogyny. Well, you'd be wrong. Moore's Law was coined by Gordon Moore, who is the CEO of Intel. Moore's Law holds that over time, some things show an exponential rate of change. Now, that can be capability going up, or productivity rising, or maybe costs going down. We've all been schooled recently on Moore's Law because of COVID's exponential growth rate. In business terms, Moore's Law equates to a compound annual growth rate of 40%. Think about that. Now, consider if you've ever heard of Metcalfe's Law. Robert Metcalfe, Bob, studied the value of networks as part of the UK's privatization of British Telecom. His law states that the value of a network is n squared, where n is the number of nodes on the network. Large networks become natural monopolies, and the speed to scale drives that value. People working in digital actively plan their businesses around these 2 laws. What they're trying to do is grow n at the pace of Moore's Law because it's worth n squared. Can you think of a company that has grown by Moore's Law for the past 15 years? Amazon. Here's a framework for finding the sweet spot and, more importantly, capitalizing on it. It has 3 layers: the digital core, digital foundations, and digital capacity. The digital core includes 4 elements, the first of which is data. Data is the lifeblood of digital and critically important. Every business has data, produces data, and consumes data, and digital is all about data. But where does this data come from? The Internet of Things. Sensor technologies generate vast quantities of this very, very valuable data. Artificial intelligence and machine learning read and interpret all that data and give it value. And then finally, robots apply the data to do real work, take on the drudgery in the office as well as the supply chain, but also doing costly, dangerous, and repetitive work. These 4 key elements are where every company, every team, every unit create their signature way of working by combining and reconfiguring around these 4 elements. This is where the opportunity to capitalize on Moore and Metcalfe sits. This is the digital sweet spot. Now, the digital core rests on a second layer. It's called the digital foundations. The foundations are kind of like digital table stakes. If you don't have them, you're not even in the game. First amongst these is cloud computing. Cloud computing stores the data, hosts all the artificial intelligence and machine learning engines and robots, and it enables new disruptive business models, which is a way in how you exploit Metcalfe's Law. Below the cloud is blockchain. Blockchain is what gives us trust over the data, the sensors, and the bots. And then finally, our enterprise systems become digital, and they provide things like cyber protection and network access and platforms. With the digital core in place and the digital foundations underneath, you can do digital. You can even buy digital. But you need to be digital, and that means working differently. Being digital is the hard part. The third layer at the top is the digital capacity layer. It means adopting agile methods to augment and in many cases replace waterfall business practices common to oil and gas. It means embedding into work the kinds of game techniques that make work irresistible and even mildly addictive. And finally, digital capacity is about people, new skills, change management, talent models, and different governance. This is the model: digital core, digital foundations, and digital capacity. Let me tell you a story about finding the sweet spot. McCoy Global sells torque tools for drilling applications. The tools are pretty high tech already. They generate lots of data, but the data isn't captured, and if it is, it was only captured by the customer. Selling expensive tools to a capital-constrained industry these days is, well, a tough sell. And the tools take a long time to learn, which is a real problem in an industry struggling to attract young people, and with us old guys retiring. McCoy started a 2-year program to transform the tool to a subscription asset that feeds data directly back to McCoy to help the client use the tool. They harvest the data from the tools to a specially designed cloud environment for operations, and customers subscribe to get access to the data. The tools are becoming nodes on a network that generate data. They have found their own digital sweet spot, and they're converting themselves from metal bashers to bit merchants, from hardware to services. When I was a kid, I used to love watching Bugs Bunny cartoons. One of my favorite bits involved a comically large keg of gunpowder jammed into the trousers of Elmer Fudd or Yosemite Sam, and behind it trailed this ridiculous length of gunpowder on the ground. Bugs Bunny drops a match on the powder, and the spark races off to ignite the keg in this epic but typically not terminal explosion. So think of that gunpowder trail as the fuse, which is how much time do you have till digital makes an impact, and the keg is the bang. The bigger the keg, the bigger the impact. Some parts of our industry are on a short fuse. Others are on a long fuse. Here's what drives the fuse. First, how mature is the technology? More mature, short fuse. Can the new technology integrate with existing businesses? Does it fit easily? Short fuse. Are there lots of people who know how to deploy this technology? Short fuse. Is the technology easy to adapt? Short fuse. The bang varies too. If the balance sheet is impacted, the bang is really big. But if it is the income statement, the bang can often be just quite a bit smaller. Does the technology create a new business model? McCoy is changing the business model for assets in the industry. Could this new business model take over the world? Could it strand some assets? Well, here's what we know about the fuse and the bang for different parts of the industry. The bang is big and the fuse is short, where the industry turns its capital over quickly. First, technology suppliers and services, specifically in overhead departments like finance and HR. Next, turnarounds and capital execution. McCoy was a technology company and are now turning themselves into a services company. Next, surprisingly, is retailing. Now, you wouldn't think fuel retailing would change quickly, but this is being caused by new battery vehicles. I was an advisor to the International Energy Agency on their landmark study on digital and energy. And back in 2017, one oil company was already signaling that the retail business model was permanently broken. If you can deliver fuel to the car, you don't need a retail station. And if your car is a battery, you don't even need fuel. And if you use Uber, you don't even need a car. And if your car is a robot, the robot is going to decide where to get fuel. Now, the fuse is a lot longer when we get down into these heavy assets that run 24/7, that have very, very tight outage windows and are expensive to change. Frankly, the big isn't really that big. Now, remember from the framework that if you want to be digital, you need to help people embrace change. Here's a quote from the EVP of one of the case companies. 20% of your people are enthusiasts, 60% are compliers, 10 will dig in and resist, but 10 will actively obstruct change. The case companies are devoting an enormous amount of energy to helping their people embrace change. They are actively moving their people through 7 stages of digital adoption. The first stage is unaware. The majority of people working in oil and gas are simply unaware of digital's impact on the industry. They don't go to conferences. Their managers don't discuss it. It's not a show on Netflix. Ignorance is a kind of bliss. The first action, therefore, is education, and not just to a handful of professionals at HQ, everyone. The key is to do this cost effectively for what is effectively hundreds of thousands of people. After unaware comes doubt. As one digital program director told me, everyone is at first a doubter, regardless of how much they've been educated. They still need to be convinced. This takes show and tells, lunch and learns, field trips, and lots of communication. 20% of your employees will never get beyond doubt. You're going to need to think about how you're going to deal with your doubters. The next stage is curious. The curious will seek out additional information, examples, courses, and briefings. Those most likely to become curious are either paranoid or their businesses are in trouble, where doing the same thing over and over again is not going to create a different outcome. They know they need to do something different, or at least differently. Some of the curious will turn into experimenters. They'll gather up their courage and they'll agree to run some trials. This is a tricky stage because if the experiments don't work, they might slip back to doubters. Successful experiments breed the next stage, believers. Believers no longer actively resist, and they will comply with your expectations. They may not move to the next stage, and that's probably okay, but it's not ideal. Some believers will become advocates. They'll say positive things about digital, unprovoked. They'll encourage others to experiment. They won't block your digital efforts. But advocates cannot go too far out of their lane to convince others to follow, and they're often not destined to lead. Peer pressure is going to keep them in line. And organizationally, they typically don't have enough power to drive change. This is the culture of heavy industry. The next stage, though, the final stage, is the champion. The champion leads initiatives and change efforts, actively mobilizes resources, goes out of the way to engage the organization. The key to a successful digital journey, therefore, going through these stages: boost awareness, manage your doubters, nurture the curious, support the experimenters, find the advocates among the believers, and turn them into your local champions. This, of course, brings us to the playbook, the set of moves that seem to work over and over, that work at speed. Some are what companies have to do, others are what change champions have to do. Here are the 5 key steps that companies have to do. Number 1, lead from the top. This is not a bottom-up game. All of the case companies set up some kind of steering group reporting directly to the CEO to drive their agenda. Number 2, state the vision. People need something to believe in. Our industry is at a tricky stage. Number 3, create accountability. A fast way to move doubters to curious is to make them accountable for some digital effort. Number 4, fuel it with people and money. Digital is not a hobby and it's not tourism. It needs resourcing. And then finally, stay the course. Digital is going to be a long game thanks to Moore and Metcalfe. And what about those who are tasked with leading change? Let's say you're the change champion. What should you do? Well, number 1, lock in your sponsorship and your support. You're going to need it. Number 2, frame the narrative. You got to make this vision real for people. Tell them a story about it. Number 3, boost education. All your effort to bring change is going to fail if it falls on unplowed or stale ground. Number 4, build your advocates. The advocates are going to be your change team. Number 5, tune up the performance metrics. Make it very real for people. And number 6, communicate the results. You're going to spend hours and hours just talking about the results, so you move people from doubt to curious. You cannot over-communicate. Let me share with you the North River story. In 2020, North River Midstream came into being as a carve-out from Enbridge, and it consisted of a number of fairly ancient gas plants, gathering lines, and other similar assets. The new digital leader, Jay, arrived at the new office, opened the door, looked around. No routers, no cabling, no computers. He had to use his own phone as a hotspot so his small team could get any kind of computer service. The deal, as it turned out, didn't include any computer systems. That included the SCADA systems that ran the plants. No telecom towers, no telecom services, nothing. North River Midstream decided to build a complete cloud-based business, including all the plant SCADA systems. During the pandemic, their vision? To become the platform of growth for their new owner, Brookfield. By fundamentally reimagining the midstream business, they could then attract investment from Brookfield. As just one example, they needed a permitting application that respected the rules around social distancing. The old model required everyone to get into a room to hash out the permit, which obviously wouldn't work. But through some programming, they built an app that accelerated their permitting from half a day to half an hour. Today, the managers can run their plants from anywhere in the world with just a phone. The debate about climate impacts from fossil fuels is over, and the debate about digital and its value to resources companies is also over. In capital markets, they've lost interest in our industry, but we can win them back through a zero emissions model and digital transformation. There is a sweet spot where digital investments help improve cost, productivity, and emissions. Companies everywhere, in every aspect of this industry, are figuring this out, and they're accelerating their ability to do so. You can do it too. If you would like your team or your company to hear this message, please contact me. The QR code takes you directly to my calendar to arrange a short call to discuss. Or alternatively, you can just email me at jeff@jeffreycan.com or phone me at 587-830-6900. Thanks very much for taking this in today. All right, welcome back. This interview segment is with Michael Chatlani, who is with L3 Harris. Michael, welcome to Energy 4.0.
Thank you, Jeffrey. It's good to see you again.
Again. Now, you're dialing in from Montreal, as I recall.
That's absolutely right.
Simulated assisted engineering. I wonder if you could elaborate a little bit as to what exactly that is, because it's a mouthful of a term, and yet it's a really powerful idea.
Yeah. So first of all, before I get to simulated assisted engineering, the background to that is that we have been developing simulators to train operators for almost 5 decades now. Those simulators use software. We call our software the Orchid Simulation Suite. And that software is used to develop those simulators, to run those simulators, and so forth. What's happened over time is that the fidelity, the detail in the software, in the modeling of the power plant has become so robust and detailed that it has lent itself to now that we can easily go into the space of where plant is being designed or plant is being modified, and we can put the information into the simulation so that we can actually see what is that plant going to do, whether it's an existing plant or whether it's a new design that's still to come. And that is what we call simulation assisted engineering, or SAE for short.
This implies that you can, at the same time as engineers may be working on a greenfield design for some facility, you can also be simulating the emerging dimensions of that facility at the same time as the design is underway, so that you can then inform the design. Is that a fair characterization here?
Kind of, yeah. So we're really talking about two things, and we haven't spoken about everything yet. But in simulation assisted engineering, what we're really looking at is the process simulation. How are the fluids moving? How is current moving through wires and so forth, right? So that the whole sort of how does the thing work? That's what we're doing with simulation assisted engineering. Now there is a natural extension to that, which is the mechanical or the physical structures and all that stuff. But for the purposes of right now, SAE is not really that. It's looking at how does it work.
The process side reminds me of when I spent time in Australia in the LNG trade. The process engineering work was considerable before any hard engineering works got underway, because you needed to understand the characteristics of the reservoir and how much water you're going to produce, and was there mercury present, and the like. So Makes complete sense. How do you actually build that model? I mean, the amount of data we're talking about here is could be dramatic relative to what companies are perhaps used to.
Yeah, it is dramatic actually. So for the most part, our power plant simulations are for nuclear power plants, the conventional nuclear power plants. So these are big machines, right? And we are taking in volumes and volumes of data into account in the simulation. And you know, every simulationist will say it, the more data, the better in terms for precision. And we're used to working with lots of data. We have been doing it for some 50 years now.
Yeah, and so in terms of the sourcing of that data, where does it come from? If it's a greenfield, I assume you're sourcing it directly from the engineering institution that's being commissioned to build. But if you have an existing infrastructure, where's the data from that for Feed the Simulator?
Yeah, so there's a few different ways to look at that. So if we're dealing with an operational power plant, the data largely comes from the operator, and that includes both design information and operational data that they have already. And then it also includes other studies for, scenarios that may never have occurred. We take all of that into account for the operating units. For a greenfield, as you call it, or a new design plant, which we do also work on, they are more often than not, the data is coming from the plant designer, and sometimes multiple other parties. But for the most part, it's coming from the plant design.
As some of the sources of that data, though, if you imagine the range of platform choices that engineering companies will have made, how do you plug in all of these different sources? Is there some sort of ingestion engine that is actually, if you like, it's like the funnel that kind of takes the information in and allows you to actually work with it in context of simulation?
Yeah, there's two different things there. In process simulation, when data is electronically available, in some cases, not all, it can be ingested into our software tools. And the key software tool here that we're talking about is called ORCID Modeling Environment, which is the tool that we use to model almost the entire process of any power plant. But one thing we haven't spoken about yet, Jeffrey, is that we also do immersive simulators. That means full 3D visualizations of entire industrial facilities, like a nuclear power plant. In that case, we're very much driven to ingest data when it's available. Otherwise, the cost of deployment for a full 3D industrial facility would be way too much. So we're very focused on ingesting data of structures, of buildings, and so forth.
Now, once you have that data, I think you could probably do some really imaginative things with it. Not just visualize the process flow, but as you sort of talk through simulations, you could actually take that process and push it to the edge of its performance requirement, just to see if you can detect anomalies that might crop up at the edge. And then link that together. So, power flux, for instance, on pressurized vessels. What does that actually do? Is that how the way to think about the use of these tools?
Yeah. So, so far we've spoken about two things. One is the process simulator. One is the immersive simulator.
Yep.
So the 3D visualization of the facility. And so what we're doing is actually we're joining the two, right? So
right.
In our case, there are many sort of virtual reality content developers that are out there in the marketplace. What we're interested in is not just the surfaces and being able to walk around the facility, but we're also interested in what happens in the facility. And what I mean by that is that if we're interested in the flows through the pipes, the way the turbine is turning, what's happening in the reactor, and being able to see that, and we drive that with the process simulation. So if the process simulator is saying that the pressure is going to drop, we're going to see a pressure drop in the 3D side as well. So it's very powerful by combining these two things. And then the other thing to add to all of that is like why we're able to do this is that, you know, one of the things that we specialize, most people think of us as simulationists in this area of the business, but we're very strong integrators. We integrate 3D assets from all different parties all the time. Even if we were building a process simulator, we're going to, for example, integrate with somebody else's control system, or we're going to integrate with some other data system and so forth. So integration is just part of our DNA. And so as we moved into immersive simulators and that ability to integrate with other applications, other computers, we have it already. So it facilitated that transition.
And what do companies tell you is the main benefit that they gain when, say, the workforce are able to combine or experience both the immersive as well as the process simulation? Are they able to execute their roles better, and are they able to anticipate problems with greater finesse? Is that the prize here?
Yeah. The prize. There's a
well, I think in economic terms, like show me the money. Like it's great to build the models and show you can do it, but where's the value here? And surely part of it has to be workforce can learn the plant quicker. That has to be a prize. But is there other value at stake here that companies should be thinking about?
Yeah, so first of all, the work that we're doing now by combining process simulation with immersive simulation, it's a relatively new area, and but we're already seeing benefits from it, right? So this program that we're working on at the moment, we're actually we're at the tail end of it. What we're seeing is that it's meant for a couple of applications that the customer had, contracted us for. But we're seeing a lot more other applications that are coming out of it. So examples of that are, we were, the main goals of this combination of simulation technologies was to, one, obviously training of personnel, not people that are in the control room, because you would use your process simulator for that, or your operator training simulator, but all the rest of the personnel, the field crew and all that. So that training is obviously one, but it goes beyond that. It's the training of security forces that need to be walking down the plant.
Yep.
It's the familiarization with the plant. So when you do a walk down in a huge industrial facility like this, right, you're talking about maybe 3 hours to walk down a plant. And this, if they can get in and walk down the virtual plant first, they should be able to save time, and they're already seeing that they can save time by doing that, right?
Yeah.
Because there's so many different pathways, there's so many different ways to get from point A to point B. You can figure all this stuff out before you go and find it out the hard way. And then there's other aspects to this too. When we combine the process simulation with the 3D or immersive simulation, we're also providing radiation readings in the virtual nuclear facility. Now, getting a reduction on dose is a big thing in the nuclear industry, right? So the more you know, sounds like a commercial, the more you know about where you are in the facility, where the radiation sources are coming from, what kind of shielding is available between you and those radiation sources, the better, the smarter you are, the less dose exposure you have.
wherever you are, whatever you're doing, Dassault Systèmes is there with you.
My name is Andrei Kalenichev. I'm Director of Oil and Gas for Dassault Systems, a software company based out of France with offices in more than 100 different countries. So I'm responsible for upstream part of oil and gas in the industry group in my company. So the presentation that I'm going to show you today will be very simple. I'll try to stay as much relevant as possible to our oil and gas. I'll remain very practical, so we're not going to talk about something that cannot be done. And most importantly, I'm going to do no selling. I think we all are driven by the necessity to sell, and in many cases that really can somewhat cloud our judgment. So no selling on my part, and we'll talk about something that is based on my personal experience and experience of my colleagues for the last 30 years in many different countries that we worked on. We'll see what we can propose as, again, as a very practical step to move forward. So I'll concentrate on three different things. I'll go through a digital transformation definition. I think it's very important to understand what that thing is all about, although I think it's kind of the hype is coming down. We've been through that for the last many years, and now the whole noise about this subject is kind of coming down because it's becoming a partially commodity in many places. We'll go and take a look at the examples from other industries. Believe it or not, there are other industries apart from oil and gas and energy. And we'll look at the, again, very practical proposition, how we can move forward with something that hasn't been really done before in oil and gas. So these are three things that I'll concentrate on today. Now, let's look at the definition part of digital transformation, right? The most important part, in my opinion, is, of course, the business process that we're trying to digitalize. Business process really defines how we do things, why we do things, and defines the workflows for various activities in various domains. Of course, we have functionality. In the software world, we have applications which support this or that particular type of activity or segment of the business process. And of course, we have data, information, and knowledge. And in our business in oil and gas, we are very, very good, in fact, how we handle this information, the volumes, the diversity of data that we use, and things of that nature. Now, we've done absolutely fantastic job with respect to integrating process functionality and data information and knowledge in the segments. If you look at, for example, geology or production or any other vertical of our oil and gas, things are very well integrated. And in fact, I think last 30, 40 years, the industry was really aiming to increase that integration, that connectivity within those silos. Now, the integration between different silos of the work process still remains an issue. For example, we have connectivity issues between the databases. We have integration issues with respect to functionality. And most importantly, of course, as a result of all of that, we still have workflows issues at the business process level. Now, again, in the silos, we're doing very well. With respect to managing and integrating and digitalizing the entire horizontals, I think we still have lots of room for improvement in our industry. What I'd like to do is I'd like to, again, prioritize business process as number one entity, as number one level, as number one line to digitalize. And I think this is where we could certainly use some help from other industries, and this is how we can move forward with respect to digital transformation. So, from my perspective, I think digital transformation really starts with defining business process, with making sure that this business process is open. You can visualize that, you can optimize that, model, simulate, and so on. Now, let's see what we can do with respect to digitalizing that business process in oil and gas. I'll give you a couple of ideas that you probably may find some useful, and there's nothing really new. But I think that we certainly need to use holistic, asset-centric approach to the entire oil field. In today's world, again, we are very well connected, integrated, managed, modeled, and simulated within the silo. But holistic asset-centric approach for the entire oil field is still missing. I was talking to a VP of an oil company some time ago. He told me that they have a snapshot of the entire oil field performance anywhere between 1 and 3 years' time. Just once in 1 or 3 years' time, which is not really the best way to manage the oil field. Because imagine you're driving a car and you're looking into your floor, and only once in 3 years you put your eyes up and you say, well, I'm still on the highway or motorway, and I'm still driving. This is good. So the ability to get a snapshot of how the oil field performs at any point of time will be certainly a product of holistic asset-centric approach rather than concentrating on this vertical. Now, we certainly need to make sure that the business process is driving the entire thing rather than the technology. And certainly, when we're looking at the digital transformation, it's very important to model and simulate the value of what you're trying to do, right? You need to quantify, you need to make sure that you agree on the outcomes and the results and things of that nature. So the value assessment of the digitalization must be a very mandatory part of what we are trying to do. We certainly could reuse other industries' experience, and I'll show you a couple of examples of that. And very importantly, we spent lots of money on buying technology in the industry, right? So we need to make sure that we can certainly leverage already made technology investment. Now, we also need to have very strong ability to partner and collaboratively deliver. And again, I'll show you a couple of examples where that really works, because you're dealing with multidisciplinary, very complex world, and of course, different players in every segment. So let's look at 3 examples. Let's look at the aerospace. Let's also look at the life science, and let's look at the cities. Cities actually is a really growing business, and it's important to see how these guys are managing this holistic approach to the problem. Now, the airspace is dealing with incredibly sophisticated assets. The plane, of course, consists of multiple different things, lots of different moving parts, and so on. They were pretty much one of the first industries that implemented a holistic approach to how they model and simulate the plane. So they can design different, but they can also model the entire aircraft and say how this aircraft is going to behave up in the air when something is happening with this or that part. You change the material, how that material is going to be reacting with respect to vibration and so on. So they can look at the entire aircraft and its dependency on various parts that they can change in the digital twin of the aircraft. This is a very good example of how the industry actually approaches that, right? Another totally amazing example, guys, it's a heart. It's a human heart, which could be more in its entirety, and you can look at different parts of this heart and understand what is happening. Not only that, you can actually get the doctors of different disciplines, right, from different geographies, if that's what you want to do, and get their advice on how to feed that heart. So instead of cutting the person open and getting inside and everything else, you can actually create a digital overall model of the heart and have different specialists working on that model, proposing the ways to cure the disease. Now, this is really very critical actually project. All of that is active in some places in the world. So this is something that is happening today. Another amazing example of how and what people do with respect to holistic approach to solving there. It's a beautiful city, but not everybody knows that actually this city is completely digitally modeled, right? So there is a static and most importantly, there is a dynamic model of that city that allows you to look at different aspects of how the city evolves and what the city is doing, and basically say, if this is going to happen, for example, if fire is going to happen here, how this is going to impact my evacuation route from the city. If I have a pollution area in here caused by whatever cause, right, how this is going to impact the quality of life of people in the residential areas. So this is a very good example where the city was modeled, the digital model was created, but of course they went one step further and they said, well, we're going to provide simulation capabilities in that city, which means that you start dealing with dynamic model. And in this particular example, you're looking at simulating an emergency situation, right? And how this is going to, again, impact areas close to it. So City of Singapore is another example of where they executed kind of a holistic approach to the digitalization program and how they managed to do it. Now, this word, digital twin, is all over the place. Everybody's using that. And I think I just wanted to very quickly clarify that how that is structured and what is really involved in making sure that it is a very viable part of digitalization effort that we have in the industry. We start with the data. We build a static model. We are very good at that in oil and gas. We build dynamic model. For those folks who are involved in reservoir business, imagine this is basically, let's say, fluid flow simulation model where you come up with different production scenarios. In fact, based on that dynamic model, whatever your application area is, you build multiple scenarios. Then you analyze those scenarios, you pick the scenario that you like, and of course you take it to a real life. And in our examples, you can take it to building an aircraft, you can take it to curing the heart, you can take it to city management, and of course in our upstream and downstream businesses, the kind of overall approach is exactly the same. Now, you would think that based on your experience in these different models and how they run, you would think that you want to accumulate the knowledge. And obviously, the further you know, the more knowledge you get, and you arrive at the point where this knowledge can actually be reused in the further models and so on. Now, this is not something that we do very well, in my opinion, right? Instead of having this constant improvement, in many cases, we're still trying to redo the same thing and kind of reinvent the wheel, especially if you're looking at, again, holistic management of the oil fields, of the asset and what we do. So the knowledge management is an incredibly important element of the entire digitalization. It allows you to reuse previous experience and to get the improvement every cycle, right? And every time you do something, you start with a more solid base than before, and you do by far better. This is absolutely an opportunity for improvement for the industry. Now, having said all of that, we went through quite a few different topics within this very short period of time. Digital transformation, right? We looked at sort of digital twin. I gave you 3 quick examples of what we could, what other industries are doing. Let's look at what we can do in oil and gas, and let's keep it very, very simple. Imagine this is a surface, and of course, we have a variety of different facilities, right? We also have operations. There are people driving trucks. You go to my favorite state of Texas in the west, and there are trucks all over the place around Midland, Odessa, and that area, right? And you have the reservoir. Reservoir is, by the way, something that we probably invest the most when we are developing the oil field. You need to build a model, you need to drill wells, and so on. Now, there are 3 distinct parts to this kind of oil field. There's probably more. But you're looking at the surface facilities, you're looking at reservoir, and you're looking at operations that you actually produce, that you conduct on this oil field. The idea is that we define some very fundamental workflows that impact the overall oil field management. And those workflows would include the 3 segments. For example, you could say that if I'm going to start injecting water in my wells, how is that going to impact my requirements for production equipment? And how is that going to impact my requirements for changing maintenance schedules and things of that nature? And you start building a unified oil field management system that would address the holistic approach to the oil field from model, simulate, and optimize perspective. So you apply 3 elements of action on this. You create a static model of the entire field, and it doesn't have to be really deep and complex. You have that complexity in the silos, but you really integrate that at the business process level. You start simulating from the business perspective on the oil field level, and you come up with opportunities for optimizing and improving overall performance of the oil field. Now, sounds like nirvana, right? It's like, the world is going to be better tomorrow. It actually will. But the important part is that this approach has been executed in quite a few industries, right? So I think there's a fantastic opportunity for us to not to be too scientific here, but really approach that from the business angle and say, this is what I want. I want to have a snapshot of my oil field performance. I want to see how my exploration is going to impact production in an automated model and simulation mode and things of that nature, and really deploy the platform for making that happen. In manufacturing world, these guys use what they call PLM, product lifecycle management approach, and many companies are very well aware of that. In EPC world, they use very similar approaches to integrate their incredibly sophisticated, complicated, and large projects. We really could use this opportunity to do the same in the oil field. So this is basically consider that as an invitation to open up the discussion of what we could do, and most importantly, how we could use other industries' experience to improve our oil field, right? And the purpose of this presentation, of course, was not to educate anybody on anything. You guys know by far more than me on many subjects. The purpose of this presentation was to say, look, we have an opportunity to use the platform that was used in other industries in the oil field. This is just one of the examples how we can do it, link these three different domains. Let's have a conversation and let's discuss that further and see what we could do together. Now, just to summarize, thank you very much for your attention, ladies and gentlemen. So the name is Andrei Kalinichev. So again, I'm responsible for steam oil and gas sector in the industry group of Dassault Systems. By the way, just to make sure that you don't forget, it's one of the largest world software companies. The important part about Dassault Systems is that we are incredibly diversified in multiple industries. And of course, that's why I got exposed to what other people are doing and really believe that there is an opportunity to reuse that in our oil and gas. So give me a shout, send me an email, see if we can really start building something together. Thank you very much, and thank you for your attention and your time. Goodbye.
Hi. Do you know simulation? I am the simulation. Do you know who I am? I am smart, but together we are smarter. I am digital. I am hardware. I am visible, and I'm not visible. I can be one, and I can be many. I can be the task or the solution. I can fly, drive, swim, and dive. I have a great network. I am virtual, constructive, live, or a process. Together we can learn the basics and try out your tactics. We can achieve a goal together and start over again. Together we see the future, live the present, and analyze the past. I can be any person you want me to be, but I am always your partner. I am flexible. I am mobile. I can assist your coach or be your guide. I can be your team player or your opponent. I can work for you or we work in groups, but you find me wherever you are. I am the simulation. I am a part of Rheinmetall.
Hello everyone. Business value has already resulted from many digital technology implementation, but there are still many opportunities to be captured and many lessons to learn. Today, I have the honor to share with you some of the lessons learned from my journey in the digital world. I will share with you some important principles, concepts, and actual business stories, mostly in the upstream of oil and gas, yet very applicable to any industry. Nowadays, it is hard to attend a technical event without hearing a talk or having a discussion about digital transformation, artificial intelligence, machine learning, edge computing, digital twin, and others. It's due to the fact that they have great capabilities they introduce to create business improvement opportunities in the various domains, including but not limited to efficiency, safety, reliability, and productivity. I am Saeed Al Mubarak, the chairman of the Digital Energy Technical Section and a consultant in petroleum engineering and intelligent fields. Well, during my journey in the digital world, I've learned that same ingredients do not usually yield similar results. Now, when it comes to technology, there is no one size fits all. And when someone is looking for a technology, it has to be a fit for purpose technology. So we need to know exactly where this technology is going to be applied. And we need to know their capabilities and their limitations and the uncertainties associated with them and with the environment that they will be deployed in. And definitely, we need to know not only the short-term application of it and even the long-term and their impact on the whole strategy of the implementation. Well, it's worth mentioning here that the human race, our societies have gone through different stages, and we call them evolution. So from hunting to agriculture to industrial to knowledge-based. And when it comes to the first evolutions, basically from hunting and agriculture, they were more of located in certain places on Earth where even the innovation cannot be really transferred to a different location because they were limited geographically and with the communication capabilities. But with the introduction of technologies, communication, the speed of it, people have capabilities different from the previous basically evolutions where people can communicate between cultures and even borders beyond their locations. And now when it used to be individual results and innovation limited by borders, now with technologies, it's a collective innovation where people can work together, where they're not even in one location. So technologies have made the world more of a borderless world when it comes to knowledge. Now, when it comes to the industries, they passed through three evolutions, and this is what you will be hearing about: an industrial revolution, the first industrial revolution, the second, and the third, be it from the steam engine to electricity to automation. And people now talk about more of digital transformation or the fourth industrial revolution, which is known more of IR 4.0. And what's in it? It's a fusion of technologies and integration of the physical and virtual world to maximize productivity, enhance efficiency, and improve quality and reliability. And when it comes to real examples that we are witnessing today, I mean, we hear lots about smart cities, the e-commerce and e-government, and smart factories. And when it comes to the upstream of oil and gas, we hear about digital oil fields or intelligent oil fields. In a poll that I run lately on basically what industries that are more advanced in the digital transformation, is it really energy, healthcare and education, manufacturing or automotive? And in fact, the poll came up with 47% staying or seeing the evidence of the advancement and the digital transformation in retail, finance, and logistics. It doesn't really, I mean, many of these companies are born digital, and this is why you've seen the advancements, and they're more of a process-based with less uncertainty when it comes to it. Now, when we talk about smart X, this is a smart city, a smart factory, or e-commerce or e-government. They don't only produce products. What they produce also data. And this data can be a product in itself if it is used to make decisions, and these decisions are used to make actions that add value. So in reality, or if you look at it, data by itself has inert energy. It's just like oil that's not really processed, it's underground. But if someone goes into this data, transfer it to knowledge, wisdom, and then use it to make accurate decisions for accurate and timely implementation, then this is where data can produce value. When it comes to the digital oil fields, I mean, we start with an intelligent well. And this well is equipped with sensors, controlling devices, and others. And it used to be that we look at wells, oil wells, as producers of oil. And nowadays, they're not only producers of oil, which is the product that we mentioned in the previous slide. It is basically a production of also data. And if you look at the infrastructure that's required to process the oil, you send the oil through the facilities, through the plants to process the oil. But when it comes to data, it takes another route, which is a bit similar, but through a communication means, be it wireless or wired, through the field, through the facilities, into the IT infrastructure of the company, and then it goes into solutions to make sure that these data are used after filtration and basically extracting the reliable data out of it to make visualization, to make decisions for subsequent implementation. And definitely on that route, you will hear lots of talks about cybersecurity, machine learning, artificial intelligence, and other aspects of the digital transformation. Now, let me illustrate to you or share with you a video that I created to illustrate what the digital oil field is.
A smart well is just like a root of a tree. If the tree has more roots, it has more chances to get more water. So we go and create our own roots, and these are the multilateral wells that goes and branches 2 kilometers below the ground, and we give every branch a sensing capability plus a control capability, so we know where the fluids are coming and what kind of fluid from each branch. When we connect these smart wells together using fiber optics, we then have access to vast amount of real-time data to make faster and smarter decisions and maximize oil and gas recovery. These interconnected smart wells are known as intelligent fields.
This is a very simplified definition or description of digital oil fields, and definitely there is no one size fits all. They are different in technologies implementation and even in the processes and workflows and the business models. Now, when it comes to it, and to go a little bit further into one real example, but before I start with the actual example, let me share with you at least some description of how this these wells look like. I mean, in the video, you've seen a multilateral well, and this is basically the picture that you see in the top left side, and it has 3 legs with the infrastructure at surface. In the right top side, you see the infrastructure subsurface, and that's the 2 kilometer or even more below the ground. And that infrastructure has more of sensing capabilities, and it has control capabilities. Now, what's associated with that infrastructure that is subsurface is basically our technologies at surface to make sure that we control the subsurface. We measure the production of the well by, let's say, surface hydraulic system that controls the subsurface valves, multi-phase flow meters to measure what the production of the well is, RTUs, SCADA, this is more of the IT infrastructure. And this is more of the ICV, the one on the left, the right, basically, of bottom right, the ICV and BDHMS. And the ICV is the inflow control valve. This is subsurface valve with different choke settings. And the BDHMS is a permanent downhole measurement system, which measures basically pressure, temperature, and in certain places, they have subsurface, even multi-phase flow meters. Now, let me share with you how this environment looks like. And if you look at the circle there, I'm basically identifying the places that I'll be talking about. These are the trilateral wells, basically laterals. And every single lateral, if you look at it, it's the box there, and every one of them has its own attributes that are different. So it has its own capacity, it could produce more, it maybe have different fluids, and the objective of the well, the total system, and consider it as a plant, is to produce an amount that determined by the manager of that well. And definitely there is not only one well, and there are different type of these wells, and the optimization has to go through these boxes to produce whatever your target is from that well or from that lateral. And for a better illustration, for those who don't know how this system works, this is a simplified description of how the system is. It's just like you're having a highway with three basically entries, three highways going into one. And you have different fluids. You have oil, gas, and water. And over there you have trucks, cars, and motorcycles. And you have traffic lights. And these are basically the valves. And what you would want basically is to control the traffic to meet your target, be it in the main highway. And that's basically it. So in subsurface, we have three legs going into one highway. And what we want to produce is basically is to control first every single lateral, what kind of traffic that is desired by the operator. Now, this is an actual example that you may even read about in literature. And this is a well, and as you see, it has three laterals, A, B, and C. And every single lateral has a valve and has a measurement device. And now, if you look at the circle here, the orange circle, if it is fully colored, then it's a closed valve. And if it is just a circle, then it's open. And now we wanted to test this well, because without the completion, without downhole valves, the well could not even produce because of the low reservoir pressure in that area. Now, we wanted to see where the water is coming from, where oil is coming from, and the objective was to produce this well only oil. We wanted to produce only oil. So what we tested first, lateral A, as you see, it's a red circle, but half open. And it was producing only blue. And the blue, basically, column there is water. So the lateral A is producing, at that choke settings, water. Now, the rest of the laterals were closed. Now, we closed lateral A, we opened lateral B, partially open, and we closed lateral C, and it was producing only oil. And this is what we wanted. And now, we closed A and B, we opened C, it was producing oil and water, but at a different choke settings. It was so sensitive to the structure of the formation. There was a fracture, it was so sensitive to it. If you introduce a drawdown, a higher drawdown, you produce both fluids, you invite water to it. But if you restrict it, produce only oil. Now, we've done our analysis after testing several basically settings in the field. And we came up with the conclusion that we wanted to produce this well while lateral A is closed, lateral B is partially open, lateral C is a little bit restricted, and it was producing 6,000 barrels for 1 year and a half. And the well is still producing, it's more than a decade old. Definitely, we went through different cycles of optimization similar to this one. Now, if you look at what we've done basically in that well, and what I've shared with you is in a minute or two, this took us maybe 2 weeks. 2 weeks to calculate the data, to test the environment, test every single lateral, have these basically laterals and test tested accurately and reliably, and do our analysis. And this well is a system among many other systems, many other wells, and is associated with the strategy of the whole field. So we look at all the aspects for the lateral, the well itself as a system, and for the adjacent wells, and for the whole area, and for the target of the well and the area as well. Now, why digital oil fields? And there are multiple objectives, and there are overriding even objectives within the company itself with digital oil field implementation or without. Companies want to optimize cost, be it CapEx and OpEx. And this is, mostly pronounced in any company. And national oil companies might be different from international oil companies, but definitely they want to maximize also recovery or enable sustainability, and that's the confidence of the market on them. So the digital infrastructure is supposed to be fit for purpose, just like we stated in the tips at the beginning, and they need to use the technologies that basically bring value to the field. Now, there were studies on where the value is obtained or where the maximum value comes from. And as you can see here, this is one of the studies that benchmarks 14 companies. And it seems to be that the predictive operations brings the highest value out of the data. And now when it comes to it, that doesn't mean it is the only one, and you will go directly to predictive operation. You will not be able to go to it unless you have the infrastructure that is reliable, and you will have to have data that is managed, stored, and again, is reliable to be able to use these data to come up with informed operation and predictive operation, utilizing the capabilities, the domain experts, and maybe the data science capabilities within the company, or even outsourcing it. Now, all of these processes and all of these analysis go through the fundamentals. I mean, and this is exactly what any business is doing, is they go through the data acquisition and learning from that data, going through the analysis, decisions, and action. And that's just the normal flow of decision making and action implementations. And now, what technology has brought to us, other than going through the cycle, which is the fundamental, it reduces the time required to close that cycles from information to action, to implementation. And definitely there is a value of time there, be it in safety issues or critical issues, operational issues in the field. And technologies definitely have shown value when it comes to their successful implementation. Now, but we need to make sure that at least we understand and what real time basically means to us, and definitely these technologies would help us close the loop faster. But we need to understand what loop we are talking about, because knowing what the requirements are to close a certain loop would basically is directly connected to the capex and opex of these environments. So when it comes to operation, just like geosteering or optimizing artificial lift system, they're more of they're done as a fast loop. You can describe them as a fast loop where decisions can be taken in a quicker base, while the optimization of a production of a well, just like the well that we described earlier, and the actual example, took us 2 weeks. And that's really the time that is required to make that optimization and to get all the information that is related to the well and the surrounding wells and to the whole field. And definitely there will be more value if one can come up with processes to expedite closing that loop. And definitely when it comes to history match and simulation modeling and conducting prediction analysis, it takes a little bit more time because things have to be considered other than the actual environment of the field or the well. It's more, you look at strategies, oil price, and other things as well. But definitely quicker decisions that are really accurate may provide a better value for certain loops. Now, reality check, and we have to set our expectation right, and we have to know exactly what the business needs are. Now, when it comes to the oil and gas, just like any other industry, the assets get maturer, they get older, and when they get older, when it comes to oil, you lose production capacities and capabilities. Maturing fields, then you need more maintenance. And now with the implementation of technologies, when you have more technology implementation, one would expect that you would need more of these technologies to be reliable. And for their continuous reliability, you have to have a maintenance program that's really robust to make sure that they're reliable. And you have to have a strategy for implementation of new technologies, because technologies get obsolete, new technologies get introduced. But definitely, any of them has to be, again, we go back to the tip, they have to be fit for purpose. Now, when it comes to the environment, you see many discussions about sustainability, CO2 emission, and others. And definitely, these are concerns that the whole system needs to take care of these concerns and make sure they're considered. Now, in another poll that we conducted, and why many digital transformation projects fail, and these are more 4 items or 4 causes of that failure. And when you look at the feedback from most of the experts, and this is a 33% out of the voters, indicated that most of these projects don't really yield the value, that the expected value, and this is why they fail. Well, definitely these basically causes of failure are all real, but the emphasis on real value, and this is why we need to focus on the objectives of these implementation, be it a short term and a long term, and make sure that they bring value at the end. And definitely, certain entities within an organization, just like R&D, are allowed to fail because they are more of research and development and trial testing. But the key there is when you implement with the big vision, and when you are successful, you create the greatest momentum to scale up. And definitely the value comes from scale up, not from piloting. Now, what are the enablers of successful digital transformation? And this is more of a list, and they're not the only ones, but they're more of the prime ones based on my research and based on my experience. It's basically the infrastructure has to be really robust, support from all directions, top down, bottom up, sideways, from management, from data scientists, from domain experts. And there has to be some sort of incentive program to all those associated in the mission, and that has to be a clear vision to all, and that's transparent and shared with all the stakeholders, and that will bring more of the innovation cycle to become even quicker. People are incentivized, people are supported, and definitely they'll come up with ideas to improve their environment. Education is a necessity. Now, if we spill out what these, 6 ingredients have, or enablers, they're more of summed up into 4. I mean, they're the technologies, and that's the infrastructure and support. The business environment, that take care basically of the communication, transparency, and support. Processes, and if you have a clear vision, then you know where you're going. And if you have uncertainties, this uncertainty gets less with time. People are really important. You have to educate them. They're the ones who are picking what technologies, improving what technologies you'll be using, and where they fit, and what value they can bring. So if we sum them up into the 4 enablers, they're enabling technologies, business environment, optimization processes, and people. And if you look at the right side, and these are the spheres, they're representation of the value of these, the investment value of these enablers. But if you look at it, so the bigger the sphere, the bigger the investment size. But if you look at it from a different perspective, you will see that the greatest value as per the x-axis comes out of people. So the focus on people, they're the ones who are picking technologies, they're the ones making up the environment, and they're the ones creating or coming up or improving the existing processes. Now, when it comes to 3 elements that are really important to expedite the success, to make sure at least everything is coherent, and this is more of a subject by itself, needs to a presentation by itself to discuss it further. But organizational structure alignment for the digital oil fields, be it in the oil and gas or any other industry. So the organizational structure has to be considered, and there has to be a comprehension of all the objectives, be it the short term, the long term, and how they're connected, interconnected with each other. Competencies, again, and this is directed to people. And when we talk about people, they're not only the employees, they're the employees, I mean, the technical ones, the support, and even leadership. Now, there is no replacement for fundamentals, and I'm bringing this video and ending up my presentation with this video because it is really, really important that we get people who are aware and knowledgeable about the whole environment. Data scientists will support them, but the domain experts who make sure that this system is, all the systems are basically targeting applications, real applications to improve the value of the whole environment is really a necessity. So do focus and do improve on the competencies of those domain experts to get the maximum value of the total mission. And now I leave you with the last basically slide of the presentation, which is basically a video, and I wish you a very successful session afterwards.
Whoa, that's not good.
Oh, I don't need this. I'm already late.
Somebody will come. Anybody out there?
Do you have a phone?
No. Sorry. Somebody! Hello? There are two people stuck on an escalator and we need help. Now, would somebody please do something?
Help! Help! Help!
I don't believe this. You gotta be kidding me.
I'm gonna cry.
Well, there's not enough left to do, is there?
Hello? Hey, don't worry about it. I'll fix it in a second.
He said he can fix it. All right. All right. That's more like it. He says he can fix it.
Walking down the sidewalk, kicking my feet as I'm moving to the music. Step to the beat. I woke up today, canceled all my plans, and I stepped right outside with my guitar in my hands, and the notes became alive as the sound caressed the air, and I kicked it up a notch as I strolled without a care.
This is the end of it, and I'm sure you got the message out of this interesting video. Thank you very much.
And welcome back to another recording interview this morning or this evening. I think it's in Germany with Alexander Munkel, who is the program manager for the digital twin offering called PlantSight from Siemens. And Alexander, welcome to the Energy 4.0 series taking place this year all around the world.
Yeah. Thank you, Geoffrey. It's a big pleasure for me to take part of this interview here, and looking forward to your questions, and I'm really happy to join you.
So let's begin, though, with the first question. You know, what is, in your capacity and work, what do you see as driving the adoption of digital technologies such as digital twin in the energy industry today?
Yeah, well, I mean, there are, from my point of view, many drivers. I mean, out of my experience, out of the discussions, the meetings we are running, let's say panel discussions, we are having interviews like these, I can say that, well, if let's say data is the new oil for our industry, that is driving people to talk about how can we utilize our data in a better way, how can we contextualize and get more out of the, let's say, new resource data, if you like to say. And that's driving people, and all of them are aiming for implementing digital technologies, not for its own sake, but for, let's say, really gain insights and gain deep insights of their process plants, but also how can we, let's say, improve the data handover, as already mentioned, between EPCs and owner operators. How can digitalization help us to run new business models? How can we really make more out of this treasure data? And it's all about making this, we call it dark data. How can we utilize it, and how can we bring dark data in actionable information? And that is one big driver at the moment, what we are talking about with our customers and prospects.
Yeah, it's a very interesting turn of phrase, actually, dark data. It sort of reminds me of dark fiber, which was fiber cabling laid, say, adjacent to pipelines that was otherwise unused or was used in a manner that was not in the public carrier world. So dark data, it's a fascinating way to think about it, especially with oil being a dark product in many cases. Now, you've mentioned data as being critically important here. Can you just elaborate where, what do you see as the data conundrum that is facing the energy industry?
Yeah, well, I mean, we all know that we have real valuable data available, and the terminology of dark data is not that they are of poor quality or of non-value nowadays, but the challenge is how can we bring these data, which I know they are there, we know we have them in our company somewhere, but where can I get them? Do I have the access rights? How do we contextualize these data into this valuable and actionable information? And that is, from my point of view at the moment, the key question. How can we really lift the value and lift the treasure to really gain more benefits out of where we invest in every data silo, our daily time, our investments in IT, in software. But the question is not how can I improve the double click in each software package. From my point of view, the question is how can we contextualize these data sets? How can we bring them together? And how can we make them on each hierarchy level in the industry and in the companies, in the enterprises, let's say, accessible? And using this contextualization it's all about, well, how can a CEO participate from the digital twin or gain insights from the twin, as well as the blue-collar workers, the mechanics in the plant itself? And as we say, everybody is looking to the same plant because it's only one time there, obviously. But his level or her level of interest in this digital twin of the plant can be totally different. A CEO has got his interest in how can I maximize the output? How can I minimize my costs? Where against the mechanic is interested in, okay, please show me right now at my position the right P&ID, my job or work order, and by the way, I have to sign the safety certificate that I really can ensure I've done everything to follow the safety regulations before I start work. And the different views to the same plant can be organized or offered by these twin solutions. And that is my strong belief. If we offer everybody the right access to data whenever it is needed, it is, let's say, used, or also place this information back from my field work as an example, then I think we really enable everybody to get benefits out of it, and not only being caught in one single solution or in one competitor in mobile data management in regards to the twin is still the clipboard, right? So we're not talking about a globally deployed mobile data management in the twin areas. The best and maybe the market leader, from my perspective, is still the clipboard. As a matter of fact, from my view, at least.
Yeah, no, I think that's probably fair. I know in the oil industry in North America, the sheer numbers of individuals who have to drive from facility to facility to record data on clipboards is still staggeringly high, and is not sustainable in our more constrained world. I wonder if you could just elaborate a little bit more. Are there certain quite specific problems that you see the industry as really driving to try and solve these days, or is it still depending on what sector you're in, does it vary all over the map?
Yeah, well, to be honest, it depends on the industry we are talking about. So the oil and gas has for sure different drivers than the pharmaceutical business, for example. So I can give you just an example out of the pharma business where I'm in as well, next to the oil and gas. At the moment, the industry, so the pharma industry is let's say asking for, let's say, a specific kind of a twin, bringing together the building information modeling with the process digital twin. So they have got, from my point of view, a different view to the digitalization and the digital twin of a plant than, for example, the oil majors. So within one major project in the States, one of our customers is, let's say, asking us, well, can you help me in, let's say, monitoring my critical assets? So doing the health monitoring of large drives. So because this large drive, and it's then one equipment, one large, of course, complex equipment, carrying a risk per day by about $1 million. Can you, Siemens, help me to monitor the health index, to predict, let's say, when I have to, let's say, maintain this equipment, to really manage the safety, manage the availability, and let's say, minimize the risk of failure. So totally different business drivers at the moment, and every industry, but also every own company or single company has its own drivers for going into this field of activities. And that's the interesting, let's say, view, or also my job role to discuss with these people, and especially at the moment with the oil and gas industry. Well, how can we help them? And you know the challenge maybe better than I do, of optimizing the carbon footprint. I mean, that's at the moment a big driver. One is risk, the other one is safety, but carbon footprint, from my point of view, at the moment is dominating. And every single functionality or software solution setup that can help to monitor, improve, or let's say, improve the carbon footprint is highly welcomed at the moment.
Yeah, I think that's a universal challenge around the industry is the carbon footprint. But of course, we are right in the middle of the ongoing wave of pandemic catastrophe in the planet. Has the pandemic altered at all the either the urgency or the scale or the approach to the adoption of digital twin technology? Are you seeing companies or industries grappling with the use of this innovative technology just to cope with the pandemic?
Yeah, if there is, let's say, out of our view, to be honest, if there is a positive thing with this pandemic, and I mean, it's hard to talk about positive things in this regards, but I mean, for us, it's really, let's say, a compelling event to talk about cloud services, to not only say, well, it's a high risk for our data sets, we don't allow to put data into the cloud. I mean, with the pandemic, with the need of, let's say, remote access to data, home office work setups, teams around the globe working all in a sudden, not any longer together, flying around the globe, but being at the home office, caught in that one, let's say. But all in a sudden, we have to use one common data set, one software solution, technologies that bring us together. And I think that was somehow a door opener, and let's say, to talk about these new technologies, and not to say, well, the cloud is dangerous, or well, it's all about cybersecurity, and we don't trust these digital solutions. I mean, that was for all of us, I guess, let's say, a really compelling event and a door opener to talk about, to really involve ourselves with these technologies. And maybe out of my view, the biggest example, and one fascinating example, is Siemens itself. So how fast Siemens has adopted new technologies, like these conference platforms. It was amazing. So they did a phenomenal job in, let's say, adapting these technologies. Also in our production facilities, in our power plants we are operating with Siemens Energy, for example. It's amazing how fast they ramped up new technologies. So it was really a door opener, like an accelerator. For these technologies, absolutely yes.
Yeah, there's certainly there was some latent capability. Many companies, Siemens I know as well as my own life, I had Microsoft Teams as part of my Microsoft suite, but without the compelling event, there was no reason to use the video facilities. But suddenly, here we are. Let's turn to the broader other use questions related to this data richness that comes from the energy infrastructure, the potential to apply machine tools, machine learning, artificial intelligence, and other capabilities. What is the convergence or the connection between these tools and the digital twin platforms, such as those that you're familiar with?
Well, good question, and let's try to separate it in two areas. So I see artificial intelligence, machine learning, pattern recognition, and all these technologies which we normally combine under the umbrella of artificial intelligence nowadays. From my point of view, in our area, it's important for two sets. One is how can we enable companies to build up the twin faster? In the brownfield areas, of course, the biggest problem, let's say it this way, the biggest problem is to get the data sets together. And if you ask your customers and companies, well, let's do it the manual way. So upload them, design big Excel sheets, and then go with every line item with human beings through and test it and check it, and then upload it to the twin solution. That will never, ever happen. So from our area, and where we at the moment invest really a lot of money with our technology and corporate technology, call it as AI, to use AI as an enabler for building up the digital twin. And that is one big area where I can see the impact of AI helping us to really build the twin and get these information sets together, contextualize them. Then the second thing is, okay, in this area of engineering and this more static data setup of a twin, 1D, 2D, and 3D data, let's say, is how do I maintain it? So how do I maintain it every day, 24 hours, 7 days a week, 365 days a year? How do I maintain my digital twin? Because for sure it's not okay only to build it up once and then the next day it's outdated already. So the key question for me is how do we get this twin updated and how to keep it evergreen? And here we see AI as well as an enabler, supporting us in business processes, matching data in the background, helping us really to maintain it. And then the second big field, of course, is in the operational area. So how can we use AI to predict events? Or finally avoid shutdowns. Also, let's say to forecast events in my plant for my assets. And so it's, from my point of view, from Siemens' point of view, two main areas. It's really enabling brownfield environments to be also part of the twin or to benefit from the twin. Mm-hmm. And the other thing is really to use AI in the operational areas for operational intelligence as an umbrella, let's say, headline. My strong belief.
Alex, thank you very much for taking time out of your evening to join me in this discussion about digital twin solutions and where the world is headed. Appreciate it.
Jeffrey, thank you very much for giving me the opportunity. It was a pleasure talking to you, and I hope it was valuable input I can give you.
I'm sure it's those who are watching will take away many nuggets of value. So thank you again. That brings this interview to a close, and please join me again in a subsequent interview where we'll be meeting with other professionals who are attending the Energy 4.0 conference, and we will see you on the next video.
Hello, everybody, and wish you having a great day so far. My name is Paul Alovich, and I will be discussing digital twin of cost. It's a point of view we have developed on developing a holistic view on the economics and finance of the nuclear power and the hydrogen cogeneration. So a little bit about me. I'm a lifelong management consultant, spent a better part of my career working in emerging markets. Most recently, I have been working with the large enterprise startups here in the Middle East. Spent quite a few years of working in the high reliability industry, energy sector, predominantly a petrochemical, as well as the nuclear sector and the healthcare sector. So essentially, organizations that have a very, very minimal room for error. And for the past 3 years, I've been working with a nuclear program in the Middle East, in Abu Dhabi, and I have spent time working as an advisor as well as a contract consultant on a myriad of different topics. But the greatest focus was on organizational effectiveness. So just a bit of a background where my practice comes from. So typically as advisory in organizational effectiveness and strategy execution, we spend quite a bit of time with the clients working on the business transformation, as I suggested, organizational effectiveness, establishing agile project management office, and change management. And ultimately what this is all about, it's about sensible approach to business. And this is going to be the topic we'll discuss today. So what happens with organizations in the cutting edge technology space? They more often than not have an uphill battle when it comes to their financial viability. And this is why we work very closely with our clients to make sure that everything from the operating model, the key elements that will be required to translate your strategy into reality are put together with a well thought through process. Then we challenge the hypothesis and all the forecasts through our applied financial modeling, making sure that numbers add up at the end of the day. And then translating your operating model into the organizational structure and all the other elements of the operating model, processes, people, and technologies. So essentially, this whole journey has to come with some sort of design in mind. And that's why we like to refer to this approach business by design. So we worked with a myriad of different organizations across Asia and the Middle East. But one thing that's very unique in terms of our expertise, we work with the large enterprise startups, which is sort of an oxymoron, but it's very, very symptomatic here in the growth markets. Essentially, the government is backing up large organizational startups where you put tens of billions of dollars into a success of the organization. And the predicament and challenges are, very, very unique. So that's what puts us in a very solid position to deal with these kind of challenges. So let's take a look at the topic of the day, which is nuclear power and hydrogen cogeneration. Essentially, we look at this perspective from a viewpoint where this is an opportunity to really get back on track when it comes to financial viability of the nuclear programs. Again, we're not trying to isolate anybody, but this is a snapshot of what's happening currently in the United States of America. Out of 99 reactors that are currently active, there is a significant number of these operations that are financially struggling, and they're on the ropes for a myriad of different reasons. But more often than not, it has to do with the operational challenges and the operating cost of running sound and safe nuclear power generation. So what can be done? Essentially, it all comes down to basics. So here is a very, very simplistic perspective on the economics of the nuclear power generation. So essentially, it comes down to these multiple dimensions. And what you have is your revenue. So your revenue is typically going to be limited by the prescribed, power generation. So is it going to be, 1,000 megawatt plant or, 4,000 megawatt plant? But ultimately, that's a finite number. This is how much electricity can be produced over a period of time. The other opportunity is going to be, the gross margin. So that's where the elasticity actually happens, because there you can actually identify a number of opportunities when it comes to effective management of your operating costs to generate opportunity for the improvement. And ultimately, the ultimate dimension is the safety. Everything that we do has to be done in a safe manner, and ultimately we need to ensure, that that the power generation is conducted in the safest possible fashion in alignment with the full compliance. That said, what's really critical to differentiate here is that the core business in the nuclear power generation is power generation. It's not safety. So what I'm trying to say here, although the safety is extremely important, it's also very, very important to make sure that you have a profitable operation. Why? Because at the end of the day, there is an empirical correlation between the safety incidents, the number of safety incidents, and financial viability of the operation. In other words, plants that are struggling financially tend to have a higher rate of incidents. So that's something to really keep in mind, because the way we look at things is that profitable operations will also be the safe operations. So that's, the math at a very high level. So what can be done in order to ensure that safe operation? So everything starts at a fairly high level of stratification, understanding your operating model that in a typical nuclear power plant generation scenario is fairly simple. That said, as always, the devil is in the detail. So making sure that you lay out your value chain and you clearly understand the opportunities for effective operating cost management is really going to be critical. So operating cost is clearly going to be the one side of the equation. The other side of the equation is going to be generation of additional revenue. So as I said, most of the elasticity is on the OPEX side, and the other opportunity is going to be about driving the revenue up. Typically, this was capped by the production capacity of the plant, but the hydrogen cogeneration is introducing additional opportunity for energy storing as well as driving additional revenue for the nuclear power plants. So this is, the punchline that we would like to highlight. As nuclear energy is becoming an option for many countries around the world, this is definitely something to consider. And self-financing out of the cost savings that can be created and generated over a period of time is definitely an option to consider. So how does this all start? So essentially, since this is a high reliability industry, it's really important to have a very, very solid approach when it comes to building scenarios, business scenarios, that said, as well as the models. So one of the things that we would definitely recommend for consideration is development of the digital twin of cost. So how does this start? Essentially, it's a digital twin of your operations that's going to help you develop the point of view that's going to be so precise and so granular that goes to the activity level. Essentially, in a very simplistic way to describe this, I think that the best would be to say that this is activity-based costing that really pinpoints the true costs of running safe operations of the nuclear energy production. Because ultimately, the writing is on the wall. The single greatest barrier to profitability and cost management is lack of the understanding of the true costs. So how do we manage these costs? Clearly by looking at the big ticket items. So if you look at the breakdown of the nuclear power generation operating costs, the lion's share, the big ticket item, is going to be the total cost of the workforce. And as you can see here, there is a sliding scale of different scenarios. So when you look at the share of the operating cost associated with the workforce, The lowest on the one side of the extreme is in the retail sector, and the highest is in the nuclear sector. So again, these numbers can vary from operation to operation, from region to region, technology to technology, but it is a fairly significant, and upwards of 50% is going to be the likely scenario for the nuclear energy. So since this is such a big line item in your operating cost, clearly there has to be a very, very well thought through approach in how do you manage it. So just to give you a bit of a visual on the impact of this cost. So if you look at the typical nuclear power plant with the 60 years lifespan, and the typical load for the power plant that has something like 2,000 megawatts, you're looking at roughly just under 700 FTEs for a full load. And over the period of 60 years, the amount of money that's going to be invested in this workforce is going to be staggering. It's going to be in excess of $20 billion. So what this really tells us is that, we really need to make sure that we pay close attention to effective management around investments in the total cost of the workforce, from a get-go. So as soon as the plant becomes operational, we really need to make sure that, this compounded factor is working, in our favor rather than against us, because you can only imagine, the outlook is going to be significantly different if we start high at the beginning, so the trajectory is just going to be significantly steeper. So what can be done? Essentially, it really comes down to effective management of the costs. And to be frank with you, I think this is a really, really good insight when it comes to effective management of the cost, because most of the people look at the cost management as a reactive, intervention, something, that's a corrective action rather than a strategic initiative that is built and designed around gaining a competitive advantage. So what we have here is a recent survey done by Deloitte looking at different drivers of the cost optimization. As you can see here, the vast majority of the respondents actually are using cost management to gain the competitive advantage in the industry. And this is, across the board, not precisely looking at a nuclear sector. But what I find very, very insightful and very interesting and thought-provoking, that this same mindset can be very, very relevant to nuclear energy space. Why? Because effective management of your costs is really going to drive the opportunities for investment, generating new revenue streams, and most importantly, gaining the competitive advantage in the market. And this whole thing starts by charting a very clear picture of what the success looks like, So with the approach that we're suggesting, so building your digital twin cost model is really going to help you, have a firm grip on the true costs and develop your optimization targets that will drive the overall performance and the success of the business over a period of time. And this is one of the critical steps, because without this line of sight and understanding how the costs are going to be managed, the organization might be falling into a political trap where different agendas are going to lead to a loss of focus and ultimately lead to a poor decision-making process that might impact, a fairly successful operating model in a very, very negative way. So let's look into a greater detail what the digital twin of cost is all about. So ultimately, it's a dynamic financial model that's looking at different elements and ultimately answering these three critical questions. What is driving my costs? Can I link activities to outputs and services? And are my processes cost effective? It's a really music to any one CFO's ears. And ultimately, what's really going to make one organization successful versus the other one organization in this space is their ability to manage these questions very well, and most importantly, to drive the level of financial acumen among their leaders across the board. And not only the leaders at the highest level of the organization, but also business unit leaders and preferably, operational management, because that financial acumen is really going to drive the difference of being a standout performer versus being a mediocre or a laggard in your peer group. So where do you start? Essentially, the approach is not that different from a traditional activity-based costing. And ultimately, you need to kind of start developing your portfolio by looking at the cost objects. So you have to determine, what are your, critical elements that you will define as your cost objects. You need to bring them all together, and then you need to start developing a point of view on your critical processes across the organization, and how do you translate those processes into the value chain. Make sure that you have as rigorous as possible exercise to really map out this in a fine detail as accurately as possible. We all know that manuals and standard operating procedures and process maps can really reflect a different picture from what's happening on the ground. So we got to make sure that this is continuously perfected in a way that's really going to be the real-time information that reflects what's happening on the shop floor. And then we move into the identification of the cost elements. So we got to make sure that we review all the financial statements and break them down into a finest level of granularity in order to identify the cost elements. And then mapping the general ledger, so making sure, that we attach the costs to the activities as well as the elements or the resources driving those costs. And ultimately, what's going to happen at the end of the journey, you need to validate the whole logic. You got to make sure that this is sound and really, really, reflective of the realities on the ground. So ultimately, I'm really, really not going to dwell too long on the details of this, but I'm just going to give you kind of like a high-level overview when it comes to nuclear sector. So the exercise is fairly straightforward. The name of the game is to produce electricity in the safest possible manner. And ultimately, the sophistication of other business operating models that typically require evaluation of geographies, markets, and types of customers, as well as the products, is really not going to happen here. But what's really going to be important is to understand the breakdown between the primary and secondary activities. And this is, on the face value, quite straightforward. But again, as I suggested, the devil is in the detail, and making sure that you have not only a strong point of view on this particular topic, but most importantly, you have internal alignment. Because as you can imagine, a lot of cost drivers happen in the secondary activities, and this is where the elasticity is actually the most prominent, as well as some of the elements of the primary activities. This is where the innovation as well as the digital transformation can kick in and really drive some transformative and game-changing opportunities for the operations. But ultimately, what's really going to drive the results in building your digital twin of cost is your ability to translate, your operating model elements with a fine level of granularity into the policies, org structures, as well as the processes to job and activity level. That's really going to be critical. So as long as you have the ability as well as the necessary resources and tools to break it down into a fine detail, to build it as a truly digital model that is capable of necessary flexibility is going to be the game changer. And then ultimately, having a consensus on the processes is going to be a bit of an iterative process, because at the end of the day, we do understand, that processes are not static. They change with time. They change, with a bit different business scenarios, circumstances. The technology is driving the change as well. And, as any living being, any organization is going to evolve with time. So making sure that you're building this model on the realities is absolutely critical. And then identifying your cost elements. One of the critical steps here is going to be understanding of your resource drivers. So how do you manage effective resource management, and how do you understand the correlation between the flexibility of those drivers moving in one or the other direction, and that impact on the costs is really going to require a subject matter expertise, deep vertical understanding of how the operations effectively drives results in your organization. And then what's going to be a very, very helpful in building this overarching model is understanding of the typical cost drivers, starting with what's going to drive the scale, the interrelationships, discretionary policies, all the way to linkages, as well as the integration and capacity utilization. Most of the action when it comes to the nuclear sector, you're going to find in the capacity utilization, as well as looking into the cost associated with a location, because those are the two elements beside the scale that have a greatest impact on the total cost of the workforce. And ultimately, what's going to happen with this allocation model, you will be able to have this bird view perspective of what's happening in the organization. You will really become the master of the cost management in your organization, having the ability to build multiple scenarios and creating these what-if storylines and narratives puts you in the driver's seat when it comes to your future investment, but most importantly, capitalizing on the opportunities when it comes to driving, alternative revenue sources. So, just to kind of sum it up, the storyline, it's ultimately going to be the first step in the hydrogen cogeneration. This is the most viable opportunity for the nuclear sector to create opportunity for alternative revenue streams, as well as the energy preservation. And most importantly, it all starts with your ability to effectively manage the costs and to create a self-financing models that will ultimately get you over the top. So I would just like to use this opportunity and thank everyone. It brings us to a conclusion. Happy to stay in touch. Feel free to drop me a line for any questions or suggestions. Looking forward to catching up with you in person.
Welcome, everybody. The transition of energy is upon us, and there's a great need for people with the digital skills to become interested in understanding and enabling the energy transition that is currently picking up speed. There are orders of magnitude more complexity to decarbonized energy systems than there is to today's carbonized one. without effective digital systems in place to instantly match that high degree of supply variability with the demand variation in real time, we're going to struggle. So my intention in these next 20 minutes is to give you a grounding in the global energy transition, the whys and the wherefores, and what it might look like in 2050 if we get it right. I will explain it through the lens of clean hydrogen, and I'm going to read this speech to make sure that I get it all the info in on time and you get what you need. So all energy transitions are messy. Lots of people think that all we need to do is put up enough windmills and solar panels and all will be well. And that is just not so. Solar panels don't work at night, nor work well in winter latitudes and in higher latitudes at winter. And they can suffer from long spells of cloudy weather and fire smoke, and wind might not blow for weeks in a row. And add to that, our weather patterns are shifting. They're not as reliable as they used to be. So low carbon hydrogen will actually help us to maintain energy on demand. And that means that when we flip the light switch on, the light comes on. And that helps us, hydrogen helps us to keep from devolving into energy as available. So what does energy available look like? Well, I have a Polish friend, and one day we were chatting on the phone, and suddenly she got all excited because the power had just come on, and she didn't know how long it was going to be on for. So she hung up and rushed home to have a quick shower and then fill the bathtub with water for the family to use, hoping that it will last until the next time the power comes on. So you see, the water only came on when there was power to drive the pumps. That's an example of what energy as available looks like. And as we electrify more and more of our lives, hydrogen is absolutely critical to make our renewable energy systems more dependable, more reliable, resilient, robust, and less messy, and preserve energy on demand that we're used to. So we're going to start with hydrogen basics, and we're going to build from there. As you know, hydrogen is the smallest element we have. The red arrow points to its location on the periodic table. We generally write the chemical formula for hydrogen as H2. And that's because it always shows up with two hydrogen atoms bonded together into one molecule of hydrogen. The energy in a hydrogen molecule is actually stored on the hydrogen bond right between the two atoms. It's marked by the purple arrow here. When we break that bond, energy is released. This is what hydrogen looks like in the universe through a telescope. This is actually a nebula. About 73% of the mass of the visible universe is in the form of hydrogen. And about helium makes about 25%, and everything else we know and love is only about 2%. However, there's no free hydrogen on Earth. Most of the hydrogen we have is tied up in ocean water. So we have to make it. And hydrogen is therefore not an energy source, it's an energy carrier. So our challenge today is that 95% of the world's energy system is based on hydrocarbons, coal, oil, and gas, which are made of, you guessed it, hydrogens and carbons, hence the word hydrocarbons. Here are some hydrocarbon chemical structures. The first three molecules represent in order coal, oil, and natural gas. And you can see that there's a lot of carbon atoms in there. When we burn these for energy, we poop that CO2 off into the atmosphere. But where does the energy actually come from? Mostly, again, from the hydrogen bond itself. When we break that hydrogen bond by burning hydrocarbons, we release heat for our use. So why hydrogen? It's shown in the red arrow because there are no carbons at all in hydrogen. So when we break that hydrogen bond for energy, no CO2 results, only water, H2O, and that is why hydrogen. So why is the world moving away from hydrocarbons then? Well, because of the unintended consequences of climate change and weather weirding that results from that. This pie chart actually shows you the percentages of warming caused by the various greenhouse gases currently overheating our atmosphere. And the lion's share of excess greenhouse gas effects, it's from CO2, that's from burning fossil fuels. 62% of the total. That's the biggest blue pie slice on the right. And we have learned two things, really, that affect everything in our lives. And one is energy and one is climate. And the two are absolutely intimately related. So here's the kicker, though. Only 20% of that big blue pie slice is CO2 released by oil companies making fuels for us. And 80% is actually released by us when we burn that fuel to use it through our tailpipes, our home chimneys, and our industrial stacks. So, how does CO2 work in the atmosphere anyway? Well, here it is in a nutshell. Our planet has a natural blanket of heat-trapping gases in the atmosphere, which is dominantly CO2. This natural blanket keeps the Earth at about 30 degrees Celsius warmer than it would be otherwise. It's natural. Normally, sunlight comes down through the atmosphere and goes through the atmosphere like a window, and then it hits the Earth, and that changes it from light to heat. That is a change from shortwave to long-wave radiation, which is then reflected back up into space, but some of the heat gets trapped in the atmosphere by heat-trapping gases like CO2 or methane and others. It works just like a blanket that traps your body heat in on a cold night. So what's the problem? Well, the problem is by digging up and burning oil and coal and natural gas, which release large quantities of CO2, we are wrapping an extra blanket of heat-trapping gases around the planet. And just like you would if your grandma snuck into your room at night and put an extra down comforter over you, you would wake up sweating too. So in the same way, our Earth is extra hot because of this extra blanket we've wrapped around it. And we're trying to keep our planet under 2 degrees Celsius of extra atmospheric heating, which doesn't sound like much, does it? Some of us might think, well, what's the big deal with that? You know, if the air temperature goes up by 2 degrees around me anyway, so what? But it doesn't work that way. That is weather. Climate, however, is the average of all weather everywhere over the past 20 to 30 years. Climate change acts more like a chronic fever in your body. If your body ran a 2-degree chronic fever of, say, 39 degrees Celsius, you wouldn't be operating very well either. So, what can we do about our changing world climate? Well, we can decarbonize our energy use individually and collectively by making different choices. Fossil fuel vehicles are going away. What will replace them? Well, my rule of thumb is if a vehicle currently runs on gasoline, it's better off going battery electric. And if a vehicle runs on diesel, it's better off going hydrogen fuel cell electric. And electric cars are more fun and cheaper to drive anyway. And I know because this is my 2013 Tesla S85, which I bought used, sitting beside our garage with its solar panels on it. And those solar panels partially power the car in my house. So what's the problem giving up oil then? Why is it just so dang hard? And so here's a question I want you to come up with an answer to. How many human work hours do you think are in a single barrel of oil? Go ahead, take the next 5 seconds and pick a number in your head. 3, 2, 1. It's 4,053 human work hours. That's 2 years of 40-hour work weeks. At $15 an hour, a single barrel of oil is worth $61,000. And we pay what for that? You know, $80 a barrel. This is a hard thing to replace. It is critical for skilled digital workers to understand this complexity of what we have to do. So what might the clean future for global energy mix look like? Well, here is our palette of renewable low carbon energy choices that we have to work with. And we have to put them all together to replace hydrocarbons. These are real, like they're happening today. These are real pictures of real projects. Here's what they look like. And starting in the top left corner, moving right, we have hydro dams, wind farms on land, wind farms in the ocean, solar farms on land, and also floating solar on lakes and irrigation canals. Geothermal, biomass that makes either fuel or power, wave energy, tidal energy, waste to fuel or power, blue hydrogen from natural gas with carbon sequestration, capture and sequestration, which is CCS, and then green hydrogen, this one from a solar farm. And we'll talk about nuclear, which is key, a little bit later. So to reiterate, we're going from 95% fossil carbon-based energy on this planet in red to a low carbon energy sources and carriers, which we have just reviewed in blue. And now we're adding another level of complexity, which is energy storage in green. Our problem is electricity does not store at all well, especially at large scale and over seasons or years, which is what we need it to do. We just can't make batteries big enough. So as an example, this is Elon Musk's 40 million bucks worth of batteries, 100 megawatts in South Australia. And it is used to balance the grid by keeping the frequency content steady so the grid doesn't crash, right? Which it does remarkably well. But if it were to actually power the grid, it would last about 7 minutes. That's it. So other methods of electricity storage are absolutely vital. These include pumped hydro and flywheels and compressed air or liquefied air too, supercapacitors, grid-to-vehicle storage, and gravity, which is one of the weirdest in my view. This is what one version of a gravity electricity storage system looks like. So when there's more power supply than demand, we can use that excess power to lift a heavy weight into the air to store the electricity as potential energy. And then when we need that power back, we just lower the weight and harvest the kinetic energy as electricity. So electricity can also be stored as heat. Molten salts, hot rocks, and storage in ground heat storage are just some of the options. Best of all, electricity can be stored as hydrogen. And so how the heck do we actually make hydrogen on this planet? Well, this bar chart shows all the ways we have for making hydrogen, each of which is referred to as a color in the industry. The life cycle carbon intensity range on each bar expresses the number of kilograms of CO2 that's involved in making 1 kilogram of hydrogen. But what does life cycle carbon intensity really mean, really? For example, let's use solar panels. The solar panel carbon intensity numbers include mining of the elements that are in it, concentrating those elements, purification of them, then transportation to manufacturer, then the manufacturing of the panels, packaging and transportation to market. The CO2 released in all of that per kilogram of hydrogen made over the lifetime of the project is what life cycle carbon intensity means. And that is actually what matters. So today, 95% of all hydrogen we make is gray and brown, shown by the last 2 bars on the far right. The gray bar, second from the right, is gray hydrogen made from methane and water, while pooping the CO2 off into the atmosphere. It releases somewhere between 9 and 13 kilograms of CO2 per kilogram of hydrogen. On the farthest right, in brown hydrogen is made from coal, which poofs off about 15 to 25 kilograms of CO2. These are both very high. So notice the orange line now. At the 5 kilogram mark, anything below that line meets the European Union definition of low carbon hydrogen, which is where you want to be, below that line. So we will talk about the lowest 3 of the hydrogen production types on the left. The lowest carbon intensity is pink hydrogen, made from nuclear used to split water. By electrolysis, it's 1 to 2. Next over is green from wind and solar. I've added them together here. Wind is about the same as nuclear, a little higher, but about 1 to 2. And solar is higher though, at 3 to 4. Next over is blue hydrogen from methane and water and using 90% carbon capture and sequestration. And it comes out at 2 to 3. But if we include the fugitive methane emissions that escape from the natural gas supply chain, then it's about 2 to 4. So notice all of these first 3 bars are less than the orange line and therefore are all defined as low carbon hydrogen. So now that we know how to make clean hydrogen, what are we going to use it for? Well, today most of hydrogen is used for 4 things: oil refining, ammonia for fertilizers, methanol, and as a feedstock for petrochemical products like plastics. And all of these can be done with low carbon hydrogen just as well. So what else are we going to do with it? Well, on this slide, highlighted in yellow, are the other uses best done with hydrogen and not electricity. These include powering fuel cells to provide heat and power or backup power to commercial and public buildings. Energy system management means storing hydrogen as seasonal energy backup. Industrial processes includes, for example, using hydrogen for steel and cement making. Heavy long distance transportation of all sorts, plus agricultural machinery. So what might the world's energy mix look like by 2050? And if we get it right, and this is just my best guess as of today, and all of it has to work seamlessly, connected to the Internet of Things, and have robust digital management protocols. By 2050, we will be electrifying everything that we can and powering it with renewable, clean electricity, somewhere in the range of 55 to 70% of our world energy needs. And we must double or triple the size of our current electric grids, while at the very same time changing over from high carbon power sources to low carbon power sources. And nuclear capacity is absolutely key. We will need to at least triple our current 11% of grid capacity that is provided by nuclear to about 25 to 40% in this larger grid. Low carbon hydrogen will actually be key stabilizer of the whole thing. And backup as a backup and storage medium, in addition to running heavy vehicles and industrial heat. But it will be the second most used form of clean energy at about 35 to 45%. Biomass will be much smaller, with fuels derived from plant wastes and garbage dumps and poop, totaling 4 to 8%. Now, my guess is that hydrocarbons will form less than 25% by 2050, and over half of those will likely be combined with carbon capture and storage, so their emissions won't be significant. On top of that, we absolutely must eliminate 30% energy waste, which is what we've got. We waste a lot of energy in developed countries. Everybody's house wastes an average of 30% of the energy that comes into it. By eliminating that waste and other wastes, we will have enough energy to both serve the additional population that will be here on the planet by 2050 and lift most of the people out of energy poverty. And lastly, we need to put effort into ongoing atmospheric carbon dioxide removal. And that means continuously pulling CO2 out of the air and storing it permanently in the ground. And we can also sequester carbon dioxide and carbon black as biochar and other things in soils and forests and managed tree farms. So every country and region in the world will have a different combination of the solutions that I've put forward that all need to be knit together in different ways. The analogy it's like painting a picture. So every country will paint their own clean energy picture according to their own resource endowments, their needs, their financial strength, and their social adoption. My job as a technology scout is to make sure that the technology is there, that all the colors are there. So the palette of colors are affordable, and every country has a full suite to choose from, depending on their own circumstances. Your job as skilled digital knowledge workers is going to be the paintbrushes here, to mix those colors, to apply them in a way that connects everything together and cover the entire canvas. Every country will envision and paint its own picture, and they will all be different. So lastly, I want to tell you about my pet project. There is so much good stuff going on in the world today to actually address climate change, and we never hear about it. No wonder people, especially kids, are feeling hopeless. And if you want to know about it, consider signing up to my Patreon, to be a patron on my Patreon blog page, which is called How the Future Can Go Really, Really Well. Get 2 positive articles by email in English every morning, 3 on the weekends. I aim for a grade 10 level of understanding. I don't always hit that, but I do that so your kids might find hope in it too. So now you've had an overview of the energy transition, and so you can ask yourself if this lights you up or not. And if it does, I hope you will consider applying your digital skills to help make it happen. In the future, if we get this right, the light will still come on when you flip the switch, but what is behind the scenes will look very different. Feel free, as you choose, to connect with me on LinkedIn or follow me on Twitter and become a patron of my blog, or email with any further questions or ideas you may have. I am also happy to have my brain picked anytime. Happy to help. Thank you for your kind attention, and I would love to answer your questions anytime.
We believe in the power of dreams.
We believe in humanity.
We believe in technology.
We believe that together, we can change the world.
We care for sustainability.
We care for innovation.
We care about trust.
We care about moving society forward.
We push the boundaries of virtual reality.
We accelerate its adoption, and we help companies and institutions create a better future.
We believe, we care, we do.
We are Virtual Aware.
All right, so yeah, good afternoon, everyone. Welcome. My name is Andreas Garder. I'm the Vice President of Future On for the EMEA region. And I have the pleasure of being here today to discuss some interesting, relevant topics around digitalization, the energy and asset-intensive industries. We are going to have a good talk about different topics around digital asset lifecycle management, transformation of operations, decision-making, different operating models, and how digital platforms can have an impact on our operations. And also, of course, the role of digital twins, which has been the buzz of the last 3-4 years in the industry. So with me today, in no particular order, I will introduce our participants. So we have Dr. Tuula Ruukkonen, who is here with us. She is working at the VTT, and you are working in the sustainability science space, looking at co-creation and co-innovation of joint development projects, and also future customer solutions related to sustainability and carbon neutrality, as far as I understand. Then we have Alistair Caithness. He is the CEO at Energy Tokens, and he is working based out of San Diego and a recognized leader in the development of asset-backed blockchain tokens. And I'll be very curious to hear your views, Alastair. And last but not least, from Technotom, we have Mateo Ramos. He is the Director of Operation and Control Rooms at Technotom, focusing on the energy production sector with a lot of work around nuclear and also other interesting energy generation methods. So with that, I think I would like to start by addressing some of the, in your view, perhaps we can start with Matteo. In your view, what are the main, in your sector where you're working, what do you see as the main biggest potential for digitalization, and how can your customers leverage that, as you have seen it over the last couple of years?
Yeah. So hello, Andreas, and thank you for your introduction. Yeah, that's a very interesting thing. I think that the most important driver for digital transformation at the end of the day is reducing the costs or increasing production. Normally on the energy sector, increasing production is dependent on the availability of the assets. So finally, we can be doing projects, we're doing digitalization projects if we are going to reduce the costs or if we are going to increase the availability of the assets. I think those are the two drivers for moving into digital transformation projects.
Yeah, this is Alistair from Energy Tokens. I think what we're working on is the tokenization of the energy assets and the energy production itself. So what I see the blockchain is a device that provides this ability to reduce costs, which is obviously key. But then what we are operating and what we are developing is the liquidity aspect, is that if you've got this capability to tokenize energy assets, therefore the money's not locked into the life cycle of the project. And, you know, we've been tokenizing this in a small scale, but really now we've done proof of concept and able to do this, you know, the model can be scaled out to the major operators. And it's not just about tokenization of energy assets in terms of, you know, we talk about democratization of ownership. You know, the general public will be able to buy into energy assets, which are essentially asset-backed tokens, similar to like a cryptocurrency, except it's backed against assets rather than backed against nothing. And it will give you distributions based on the production, whether that's oil and gas or renewable energy going forward. But I think what we are thinking would be key is that once the model works, it's how the major operators are going to be able to utilize this. And if you think of, you know, major production, you know, I'm from originally Scotland, so, you know, a lot of the production we spoke about was in the North Sea, and then how the North Sea was essentially, you know, passing from one operator to another. So what's been key in terms of development, what we are doing in terms of blockchain and tokenization, is this ability for operators to start to utilize this technology to work with other operators. And I think that's key in terms of what we're operating on.
So you're using blockchain technology to drive collaboration across and information sharing, I presume, between the operators, Alistair.
Yeah, it's information sharing that they're able to do for the first time. So essentially, up until now, it's been very difficult for operators. You know, if you start looking at seismic data, it's like, yeah, we can, you know, if you think big operators are going to share seismic data, but they can't actually share it, like who actually owns it. But now you can go to a permission blockchain, and therefore, because it's held on a permission blockchain, and the only people getting access to that are the major operators. So you could say ExxonMobil, Shell, and BP all have access to one blockchain. They are now able to share seismic data and information through the blockchain in a way they've never been able to do in the past, because essentially it's one underlying if you think about in terms of like databases, it's one underlying database shared between the three of them. And that's what the blockchain's starting to do. So what the blockchain's going to do is it's going to allow all these operators, it's going to do a twist on the market space. So it's going to allow these operators to work with each other in a way they've never been able to work with before in terms of sharing information. The piece that we're focusing on is the tokenization of the asset and the distribution. So it's unlocking liquidity in assets. But this is now allowing them to operate in a way they've never worked before as well. And that piece of digitization through the blockchain, it's going to change everything. It sounds like sort of, you're looking to the future in terms of, this access to the technology. But what it's really going to do is just allow collaboration in a way where they can trust their partners, because essentially they're both going on to a central database where they can share information together, if that makes sense.
I think it makes a lot of sense. And what are the main challenges that you come across when you go out to the prospects and start discussing blockchain with them? How do you find the general perception of blockchain as a potential information carrier and facilitator, if you want to call it that?
It's so early days with it that ultimately it's just starting to come into the market space right now. So, and when the oil price is high, there's no need for them to be using this. When the oil price is low, because it's a cost-cutting device as well, it's something that's key with them, And I just think the adoption is going to be slow, but once they start using it, it's going to be mass adoption.
Super interesting to follow the blockchain space, actually. I mean, normally hear about it, obviously, in the financial world, but it's just interesting to follow it also in the industrial sector.
Yeah, the blockchain energy, they're operating out of Houston, and now they're running a couple of projects, just to give examples. But one of the ones they're using is obviously sharing of seismic data. But now they're going to start looking to run projects on it. So therefore, you'll be able to execute contracts on the blockchain. So if you think of the major operators and why they're wanting to do this is because they're going to save money and fixed costs. So if you think of, goods getting delivered on site in an oil project or an oil and gas project, right now that would get goods delivered. Once they've been inspected, you'll have 90 days to pay it, and then you'll have to wait for this payment period. Because everything's going to be done in smart contracts, essentially once the goods are delivered on site and you've delivered everything agreed in the smart contract, it automatically executes, and then the people will be paid. So what's key about that is that suddenly for the major operators, they're looking at saving, long-term 7 to 10% of their fixed costs from a financial perspective, just by using smart contracts, which is just one part of the blockchain. So, but if you're turning over $500 billion like the big guys are, and they're looking at ways in terms of, from a financial perspective going forward, this technology is going to be able to remove back-end admin and finance costs. And, I've heard guys from Saudi Aramco, guys from Shell Ventures talk about, this is the sort of, once this technology is implemented in the next 10 years, 7 to 10% of their fixed costs, which is like a massive amount of money for these companies. So they're just starting to run these projects on the blockchain. And, they're just saving so many different ways with the technology. And they're just, every day they're learning new applications of it. I'm just, operating in one area of it. But it fits in with digitization as well. So it's going to sort of fast track everything. And once they start to understand it, they're going to start to utilize it in every aspect of their business. That's what's so exciting about what's about to happen in the next 5 to 10 years.
That's really interesting. So thanks for that, Alistair. So I think, Tula, I wanted to ask you, in your opinion, from the projects you have been working on over the last couple of years, is there a common denominator or recurring theme that repeats itself for successful operations when businesses transform themselves going digital? And if so, what does that look like in your experience?
That was very interesting question, because I think that all these different technologies which are now appearing and being enablers to do things what we actually already 20 or 30 years ago wanted to do for modeling and simulation and optimization. Now all that is possible, and okay, blockchain is one very key thing for sure, but there are a lot of other things like different kind of cloud-based solutions. And I fully agree with Matteo that the key is that there is always a business case to it. But what is nice about this digitalization is that actually all those business cases which are related to performance or availability, they actually are also very key from the sustainability point of view. So we are at the same time reducing the emissions and also making things more efficient. So meaning that we are actually at the same time doing both things. And when you are saying that what has been the key during the couple of years, I think that it's really about being able to calculate more efficiently using modeling techniques which were not before possible, AI, machine learning, and all that. And that has been applied now already in quite many places. I think the extensive use is still to become, and I think that we all agree that digital twins, I think we still see them very differently, but digital twin as a wide perspective, including everything from the design phase to the life cycle of the plant, that is something which will be coming. And that will actually, what I want to point out here when having the chance to kind of say the main things, it's also changing the work of people at site. So that will be a very big change, and that has to be taken into account. So maybe this didn't answer your question, but at least wanted to point out these things.
No, that's very good answer. Thank you, Tula.
If you let me,
yes,
Andreas,
please.
yeah,
Yes.
I completely agree with you, Tula, and I think that in many markets, profitability and sustainability comes together, because sometimes you have, for instance, the carbon markets, or you have some restrictions from your regulator and things like that. And at the end of the day, a lot of times, if you are more sustainable, you are going to be more profitable. For instance, we are doing some projects using artificial intelligence in order to reduce the fuel consumption. And that affects in both ways, because you are going to increase the sustainability of the asset, but also you are reducing the cost, because the fuel, you need to pay for that. You need to give the electricity, the output of the electricity to the market when it is demanded. And also you are reducing the cost in carbon emissions. So I think that most of the times it comes together, fortunately.
I just want to say, I always harp on about the blockchain because that's basically all I know about, No, but it's just, but one of the things that's interesting now is in terms of tracking carbon emissions through the blockchain. So if you think of it from a database perspective, the CO2 emissions in terms of oil and gas from a tracking perspective, they're already tracking it on central blockchains now already. So they're starting to run that in projects, which is going to mean that companies going forward is, everything's going to be transparent and it's going to be centrally done. And I think this is going to lead to, anything that leads to transparency with sustainability is going to help. And it's just going to drive to, the drop in CO2 emissions. So it's just like what everyone else is saying there. It's just all part of a process, and this is just one part of the cog in the key,
Mm-hmm.
Good, yeah. And Matteo, in the nuclear sector, are there any talk of deploying blockchain in your sector that you are familiar with?
Yeah, well, as you said at the beginning, most of our background is in nuclear, but we work on the different electricity production technologies. I am not familiar right now with any project involving blockchain in nuclear, except some pilot projects for applying that for the chain of buying some devices. Like for instance, there are some cases in some countries where there has been some fraud on the buying some components, and it was not the right component with the right specifications. Probably if you needed a replacement for an equipment that is very old and it is very complicated to get it. So I heard some projects that are being used for that, for keeping the track on those kind of components. But for other use cases that, as we were discussing before we started with the panel, the use cases are sometimes the key thing in a digital transformation project. I am not familiar with.
Right.
Maybe
Yeah,
they
we
are,
talked
but I'm not familiar with.
Yeah, we were talking a bit before this session about how important it is to break things down into, to be successful, to break things down into sizable bite-sized chunks of manageable use cases, and pin down where exactly are the pain points and what are the use cases that can solve those specific pain points, and it makes life easier for everyone. And I think that's one of the approaches we have seen working quite well in Futuron, when we embark on this journey with our customers to try to help them collaborate smarter, faster than they did before, because now we are under pressure to deliver faster in the new commodities environment. And definitely breaking it down into bite-sized chunks, working out meaningful use cases, and then scoping them and attacking them one by one is one approach that we have had success with. So definitely something, I think it's maybe all the panelists are familiar. I've seen something familiar in their work. I don't know.
Yeah, I fully agree with you. And I think that what is interesting is that when we think about the whole value chain, or actually value network of energy, for example, there are a lot of things which are happening in different parts. And maybe Mateo and me, we have the background of production, and then there is, of course, the transmission and the end customer preferences, and nowadays even end customers being the producers. So I think that all this will be making a major change in the whole value network. And then it comes to be the question that what are the things, how do you optimize that, and how do you actually utilize the technologies we have available at the moment the right way. But yes, I fully agree with you on these use cases, that there has to be always some value added when you are making a new application, and how you build that.
Yeah, sure, because finally the
Yes.
technology is just a tool to get a target that you have. So you have a user, you have a client that has some pain points. You need to identify them and to try to define which is the best technology in order to solve the problem, to validate, to pilot the technology if that is possible, to do it as fast as you can and as cheap as you can, especially if you are confused, if you don't have success. The sooner you do that, the better. And then if in case you have success, then you can start to scale up, to validate and to scale up and to build a solid business case in order to have some investments in that. Unless there are some disrupt changes, as Alistair was discussing with the blockchain, that I'm sure it is going to be something that is going to change a lot of things in different sectors. Probably it is going to take a few years in some of the sectors. In others, probably it is coming pretty soon. Otherwise, you need to be doing that use case by use case. And I think that also something that is very important is to understand that a digital transformation project is not only about doing what you do in analog into digital, is that you need to transform also the process that you have. Otherwise, it is not going to add a value.
Process and the work of the people. So I fully agree. One thing which came to my mind when you were explaining exactly that approach is that if you think about the traditional businesses where we I would say everything in energy still is pretty traditional. We used to do everything with this kind of waterfall development way, and now think about lean startup or minimum viable products and all that new kind of stuff. It also needs a lot of changes in the way how we do things, and with new technologies, where there are so many potentials and very fast development, it is very demanding, but it has a lot of possibilities too. So I have seen it very much different from some tens of years ago, and it's very interesting how you now approach. But scaling is pretty demanding. So like you said, it's not easy.
So Tula, from your perspective, what we have talked now a bit about digital twins and blockchain, and I guess those are quite familiar topics for all of us here, and probably most of the listeners as well. But in your view, what are the up and coming next big most promising technologies from your perspective that you think are going to become bigger for the coming period?
Yeah, I'm a technology freak. I have been in business for a long time, and I'm always excited about the new stuff. And I kind of was hoping that I get this chance to say what are the next things. And I think that different kind of now thinking from the production side, for example, all kind of autonomous systems, which are self-learning, self-healing. Even many people talk about predictive maintenance and preventive maintenance still, but I think that we are coming to the prescriptive and even autonomous operations. Robotics, real robotics, meaning cobots and a new type of way how we can maybe do remote operations at site, so that you either have an autonomous system or then operated by a remote operator. So all this kind of stuff, they are exciting and giving us a chance to do things which are totally different. Starting from the design of the equipment already, thinking what are the different possibilities. That's the key. We were talking about the life cycle, but I think the design part is the key. And I understood that is actually our chairman's view also to the digital twins. So maybe you can comment on it yourself too.
Yeah. So that's one of the things we focus on in Futuron is the value of building the digital twin from the earliest phase, and then maturing and evolving and growing that through the different more mature phases as your project evolves. And it has all kinds of values derived from that. Information gathering and retention, communication, collaboration. And once you have your digital twin from the earliest phases, you will be able to, again, find some good use cases and deploy, who knows, data science, predictive workflows, and so on down the line. So this is something that we also work a lot with our clients with. So Matteo, preventive maintenance, is that something that makes you excited, or more here we go again? Or is it, what would you like to say about, would you like to say anything about preventive maintenance? What's your take and perspective on that? I'm guessing that it could be something relevant for your sector, but
actually we are working right now in some projects regarding that. We call that ACM, Advanced Condition Monitoring, but finally that's the same thing. We are collecting the data that the asset has in real time. They have an OSIS of PI or another historian server that is collecting the data of the different systems of the asset. We are processing those data into the different algorithms that we have for each one of the different systems and the main components. We have trained those algorithms with the historical track that we have of operation of the assets. And what we are getting with that is that we are able to identify if there are some degradations on the equipment. And we are having very good very good results with that. One of the plants, one of the assets that we are doing this service right now, we have been analyzing, because it was the first year of service, and we have been analyzing the impact of the service, because each time you have an alert from the system, we analyze with our experts and we provide an alert in case it makes sense from an operational perspective. We alert the maintenance guys. If it is not a true positive, a true alert, it has a cost because you need to get involved some people of the plant. And in case it was a real alert that appears before the alerts that you have at the plant, it adds a value in terms of the potential damage that it has prevented. And the benefit for that is 3 times the cost of the service. So it makes sense. Of course, moving completely from the traditional maintenance programs that we have into this kind of programs, I think at this moment it doesn't make sense. It needs to be done in a graded approach, but it adds value, it gives more availability of the asset, and it reduces some maintenance costs of some systems. So I think that's one reality that we have right now.
I'm very interesting, Matteo. So I'm curious to know if there are currently, that you're familiar with, any pilots where there are asset owners who are actually trying out going away from risk-based inspection or planned inspection programs and really just going predictive, if that's happening at all, or is it still years down the line?
Yeah, there are plants and there are some sectors that are very active in risk-based inspections. In other sectors, like for instance in nuclear, it is more complicated to move into this kind of programs because you have some regulatory requirements that is more complicated to change. So probably you cannot do that for some systems, for the core systems that are the safety ones, but you can do it for the balance of plant and other systems. So yeah, there are some experiences with that, and I think that's really fascinating, and that is giving us opportunities to reduce the cost and to optimize the operations.
I could maybe add on that one, because I think it's both, and you need to have, of course, reliability-based maintenance program on your background. But the thing is that to collect exactly, like Matteo said, the data and learning from that, it's very important for especially for equipment manufacturers, that they would all understand their own equipment and that both reliability and then the predictive maintenance programs, that they can propose right things and they will be updated. But at the same time, it's very absolutely important to understand the whole plant. So in that sense, I think that it will be always a combined effort, but then it's much easier if you do have the data also and the present condition of the equipment, and you can react to that one, both from owners and also the contractor's point of view or the supplier's point of view.
Thank you, Tula. So, Alistair, I'm a bit curious to understand if there are any links that you can see or that you might be working about on between blockchain and data science and AI, and what does that look like at the moment, if there's anything?
Yeah, I would say one of the big things that they're looking to do is just, so everything's sort of running on APIs speaking to each other. So essentially, we're running the Energy Tokens platform, and we've built it on an AWS front-end blockchain. So essentially, we can plug in any third-party data into it now. So what you're finding and going forward for people to understand is that everyone's systems were in the past running sort of, the way they were having to run together, You were having to get the, sort of these APIs, have to speak to systems. Now everything's just plugging into each other. I think one that's interesting that IBM's doing for the shipping industry that's going to get applied to a lot of other industries is, 80% of the world's shipping is now tracked on a blockchain essentially operated by IBM. So, in going forward, if they're doing it for the shipping industry, what they'll start to do is in terms of, well data analysis, things like that. So what we can do is we can just plug in well data analysis and then up to the minute well data. So you can actually just track up to the minute in terms of production. But in the past, this was actually quite difficult for, you'd having to get third-party software, would have to plug in, they'd have to give you reports, and all this is now just through APIs. And then the advantage of the blockchain is because it's one central database, then all the systems are getting connected to each other. So what you're going to find with digitization, the blockchain is going to be an underlying pin to connect a lot of these things together, which I think is going to be interesting for a lot of companies out there.
That's interesting. And in the renewable space, Alistair, we talked a bit about was it emissions tracking? What other big application areas do you see for blockchain in the renewable space?
The area we're looking at is in terms of tokenization and allowing fractional ownership into renewable energy assets. So what that'll do is it's going to allow, essentially right now, because my knowledge is really from land drilling in America and small to medium-sized projects, where a lot of these people have non-op interest into the project. But what the blockchain and tokenization is going to allow them to do is it's going to allow essentially people out there to acquire interest into renewable energy projects. And as it starts to produce electricity, people will start to get distributions from that as well. So that's like the area we're working with in terms of tokenization. But when you start looking at in terms of emissions and CO2 emissions and then what renewable energy is actually generating, it's just going to make everything a lot more granular. So everything's going to be up to the minute. And, the data sharing is just going to become easier and easier and going forward. And I just think like the blockchain is going to speed up the transition in energy because of this. Because suddenly we were talking originally about dropping in CO2 emissions from oil and gas, and then this database system is going to track everything. But then you're going to have this ability to basically track everything you're coming in from in terms of renewable energy as well. And then you'll be able to start feeding renewable energy into powering oil and gas infrastructure in the land drilling. They're already looking at that. They're doing it in Abu Dhabi, stuff like that. So that's dropping CO2 emissions, whereby you've got massive solar farms now powering the huge pump jacks. They're doing it in small levels as well. You're capturing flaring of gas, feeding that back into the system, reducing electricity costs, reducing emissions from there. And the blockchain is just an underlying pin of connecting these technologies, which I think is really interesting.
That's fine. And I think I want to say that the data and the data quality and density is the classic Achilles heel, right, of any data science project. And I'm becoming a bit hopeful in terms of what Alistair is saying in sense of increasing the granularity, and I'm guessing also the precision and quality. So it might make all our lives easier. Maybe data will become higher quality, more dense because of blockchain.
Yeah, I think that's exactly what's going to start to happen going forward. And people, it's one of these technologies that's just going to be when people start to understand it, they're going to be able to apply it to everything. And it's not going to like revolutionize something like we've got the television or the telephone. It's just going to allow this ability to share information at a granular level that we've never been able to do before. And it'll just start to create more and more and more collaboration. And then I'm only doing it from my knowledge, but when more and more companies get involved in it, they'll just start to collaborate in a way like they've never done before in terms of sharing information. And as we pointed out, the more granular you make it, the more data you can share, the efficiencies will just improve off the back of this. And then, the whole technology is looking, this is like its total infancy. It's like the internet back in 1989. That's the way I look at it right now. What's this technology going to do by 2050? And it's just like one of these things. So it's at its beginning, and I've been involved in it for about 4 years now. So it's exciting to see more and more people get involved in it, and bigger companies investing in it, and all the major operators are now creating divisions for it as well. So this is how, serious they're taking the technology and how they're going to apply it. And then obviously they'll be doing stuff they're not even making aware to people, So it's interesting from that. And then, you go to any of the blockchain events. Having gone to like multiple oil and gas events, I was involved in oil and gas information stuff since like 2005, project information, stuff like that. And then, but then again, everyone's sort of working in silos, but it seems to be when you're working with this technology through blockchain events, everyone's collaborating a lot more because they see the benefits of collaboration, which I think that's what's the key behind the whole technology itself.
I have to agree that data is very key in this, but seeing the applications, you are measuring nowadays much more, and you can analyze that much better, and so on. But still, I see that process knowledge, modeling behind it, meaning that you understand what the process is all about, and then making deductions out of that to the real use cases. It's not going to be only machine to machine. So there is still the role for people and expertise, and you have to have that connected to the different applications. You can do it for machine learning, but I still see this kind of hybrid models much better, where you have the machine learning connected actually with the model-based analytics. So and these are tools what we just heard. So now we can do it. We can actually realize it, but we need to have also people involved with this whole thing. So Matteo, sorry, I was
no,
interrupting you.
I'm really happy that you mentioned that, because I completely agree with you. Actually, the experiences that we have had of trying to apply artificial intelligence at the very beginning, because it was what we needed to do, it was completely a disaster, to be honest. Right now, what is working for us is having the knowledge of the process, understanding what we want to do, understanding in what parts of the process we want to apply artificial intelligence, because it is going to add some value, because it is unpredictable, because there are a lot of variations, because it depends on a lot of external things, because we have historical records that have quality enough. And finally, you apply that, and you have a system that helps you to make decisions. That is what you normally want to have. And what I wanted also to say regarding the different things that we have been mentioning, because we have been discussing about some technologies, some IT technologies that are really promising, and that we feel really passionate when we are very techies on that. But we always need to see that we always have some emerging technologies that are very promising, that probably they are going to change everything, all the market rules in a few years. That can be 5 years, that can be 30 years. To be honest, I don't know. But also we need to manage some projects in the short term that we don't have those technologies. And there are some technologies that are right now mature enough. So we need to do some projects trying to add value to the plants, to the assets, to the market, to the society, applying those technologies. And of course, we should be doing R&D and some pilot projects with those promising technologies that can bring us some values in the future, but we need always to balance those two things. And that is sometimes very complicated, to not be loose on the technology side, but also to have very clear what are the targets that we have.
I'm very glad you were saying that, because I think it's very important to know when the technologies are ready enough to be taken into use. And we have had some examples like about HoloLenses and other AR, VR applications. And everyone has been asking that when it will be really true, when everyone is using it. So there are many things what you have to have ready before you will able to utilize that in the wider scope. But there is a big potential there. And for those who understand how to use it and how to benefit from that, they will be the winners in that one.
And I think, Tula, that it's two sides. It's the technology should be mature and the sector should be mature, because, for instance, blockchain, in some sectors, it is mature enough. In the financial sector, it is changing a lot of things, and that is going to be a big game changer in the following a couple of years probably, but energy, as you said before, is more traditional in some things.
Yeah, but they want to have proven technology,
No,
which is
I
very
100%
good.
agree.
Which is good.
Yeah. Yeah, but I 100% agree with that. It's just like it's absolute infancy with the energy industry right now. So everything's pilot projects, you know. So for people out there thinking they're doing that, you know, you've got the Blockchain Association out of Houston that's probably leading the way in the US with it. You've got every major operator involved in it in the US now. You know, it's ExxonMobil, Chevron, BP, Shell, Saudi Aramco. So all these guys are now starting to collaborate. But they're even standing and saying this technology is just at its infancy. It's going to be, you know, 5-10 years before people start to see it across the industry. But what's interesting about it is that they're all getting involved in it. And then the people that are employing in it as well, they're, you know, a lot of them, you've still got the traditional oil and gas guys, but then you got all these sort of Silicon Valley super geeks as well, you know. So it's like these guys are merging, coming into it as well, which is interesting, you know. So it's a real mix of people when you start going to these events. So it's interesting for that. But no, I agree with you guys 100%. You know, it's just how does it get applied to the oil and gas sector? Because it's a traditional sector that's always been successful. It's just like it'll start to come in very small ways before it starts to get, you know, full implementation. Probably, you know, it could be 10 years before a lot of people out there start to see it as well.
I'm a bit curious, Alistair, on related to data security and information security, and if there's any value added by implementing blockchain in the energy sector in terms of information security, because that's one of the topics we've quite frequently come across when we deal with the energy production companies in various parts of the world. There's a lot of focus on information security, keeping the information secure, encrypted within the country, and so on. What's your view on how can
so a lot of it's like, so people think about Bitcoin and running on blockchains and all these open source blockchains. Like all the major operators will all be encrypted, but on permission blockchain that maybe only 3 big operators are working on it, or an operator in a service company, or an operator in 2 service companies. So it's not going to be open source that like we'll all be able to go on and start seeing this information hashed on the blockchain somewhere. It'll just be all under permission blockchains. That's why they're all starting to use it more. Because now they've realized that, wait a minute, is this open source information, all this code that's out there, people can access it, you know, things like Ethereum that are running more and more sort of applications, that Cardano is starting to run a lot of applications on it as well. And, you know, we're seeing the financial sector. But when the oil and energy companies come in, it'll be permission blockchains, it'll be very secure, and it'll be a very small amount of people getting access to this. You know, it'll probably have less people getting access to it than currently they do with databases speaking to each other through APIs. So the cybersecurity is probably the number one thing for blockchain with energy companies right now, and sharing information. And that's the difference between a permission blockchain and a public blockchain, where public blockchain people can access it. Permission blockchain, we won't even know these blockchains are existing and operating. It'll just be the operators themselves, or the operators and service companies and the different manufacturing companies working together on this. So the cybersecurity is probably key with it. And I think that piece of trust in it is what they like about it as well, you know?
I have also understood actually that blockchain is actually one of the solutions to the data security. If we think about, for example, that what we have been having projects where you do, for example, 3D printing, and you are sending your own design to that printer. The blockchain is the only solution which is then possible, because you don't want to reveal those the designs to anyone else. So I have understood that is actually the way. So machine to machine data, is that too much to
it's controlled as well. It'll be so tightly controlled. People think it's going to create a new level of cybersecurity. They're going to trust, and this is how the operators will be able to start trusting, working with each other more. You know, because essentially they're the only ones using their own permission blockchains. And going forward, they'll end up running their own blockchains. You know what I mean? So it'll just be, they'll be their own blockchains, and they'll be the ones running it, and they'll be inviting people to access it. So this thing's not going to be open source. It'll all be permissioned. and that's why they'll become comfortable at using the technology. I think that's what's confusing for a lot of people, because they see about the financial stuff and Bitcoin transactions and all this stuff hashed, and you can track it even though it's happening in milliseconds. When the operators are doing this, is all permission blockchains. Like, none of us are going to be able to access it unless you're invited to access it, basically. And then it'll all be encrypted, and it'll be cybersecurity. It'll be like the #1 protocol for the whole thing. I'm actually going to have to go. My mother's basically waiting for me.
Yeah, I think we are actually coming slowly towards the end of the session here, and I would like to say thank you very much to all the panelists. It's been super interesting and great to meet you all. And are there any final comments or remarks? Please go ahead. Otherwise, I think we can slowly wrap up.
Yeah, I would just say, I'll just go first then. It's just digitization, automation, artificial intelligence. To me, all these technologies are just starting to all merge together, and it's just, the technology is advancing faster than we can use it, but it'll all still come down to human interaction, how we utilize this technology. We spoke about it earlier as well, and that'll be the key in going forward. It's like, we're not suddenly going to be automated out of the industry. It's just going to be, how do we utilize this technology going forward? And I think that's the key, and I think that's what's going to be the opportunities for so many people out there as well. It's not going to be suddenly there'll be no jobs in the industry. It'll just be, there'll be a lot of different type jobs and how we work going forward, but there'll be so many problems that we're going to start to solve in terms of not only speaking with the blockchain, but I think for CO2 emissions, stuff like that as well. The transition to renewable energy, it's just exciting times, and it's just going to happen a lot faster than we realize once we start to apply the technology in a bigger scale.
Alistair was saying so many things what I wanted to say also, but I think that it's great that we are having this kind of seminars and conferences, although it's now a bit different with this virtual way of meeting, and this cooperation is very, very key in learning from each other how to apply and what are the potentials, and very much enjoyed this discussion. So hopefully there will be a lot of cooperation between, for example, Technatom and us, as we do have already.
Yeah.
So
thank you
for this.
Yeah, from my side, I want to say that we also see a lot of movement towards collaboration. We're working a lot actively on collaboration, on improving, helping, facilitating better collaboration between our customers. Often our customers are partners with other operating companies, and we're working with them how to exchange information and really take out all the synergies between their organizations. And there's a lot of interesting stuff happening there as well. So that's my final remark, I guess. So thank you, everyone. Matteo, any last remark?
Yeah, just very quickly, I just wanted to say that I said before, that I think that technology is a tool. It is an amazing tool, but we need to understand that it is just a tool. So the key thing is to understand the process, to have key process knowledge, to understand which are the pain points that we have, which are the challenges, and to try to apply this tool that we have, which are the technologies that are right now affordable, emerging, that we can use it. We can do a lot of very interesting things that we couldn't do and we wanted to do, as Tula said. And that is the way to start piloting, to identify very good the use cases, to check if it is valuable, and then to scale up and to try to get the value from that as fast as we can, because probably a new technology is going to emerge and we are going to have other opportunities to do things and to improve. So thank you so much, Andrea.
Thank you, Matteo, Tula, Alistair, and over to you, Jay.
Hello, everyone. Thank you for coming to the conference Energy 4.0. It's a pleasure to be here to talk to you. Unfortunately, we can't be in person at the same location, but I hope that the 3D environment gives a little bit more of a feel. I look forward to interacting with you at the end of the talk and throughout the event. So I'll be talking about machine learning in the energy industry today. My name is Patrick Bungert. I'm the Vice President for Artificial Intelligence at Samsung SDS, which is the IT company in Samsung Group, where we deal with all manner of AI. And I'll be exploring how that is incorporated in the energy industry and what the benefits might be. So just a little recap. Artificial intelligence, of course, is a mathematical methods sector, so it needs to be connected to reality, the real world, which is really where the term Internet of Things comes in. This is the sector that really connects the real world to the digital world via sensors and things like that. So there's numerous things that you already have, which would be the machines, the sensors that acquire the data. You have a control system that runs either your upstream or your downstream area. You have an archive of that data. All of that is principally a physical asset. Even the data archive is essentially a physical asset. It's a data center with hard drives and so on. And unless you analyze that data archive, it remains a physical asset. The value that IoT or analysis or machine learning or artificial intelligence, any of these fancy buzzwords can provide you with is actually to optimize that process, to achieve better control, to increase the quality, to stabilize whatever process you're running, perhaps even to document it to a regulator. The primary use case, of course, that everybody has been talking about for years now is maintenance, or rather predictive maintenance, to help you schedule events before a physical failure. And how to connect these worlds that exist and the value that we hope to get from it is really via a database and analytics on that database that will drive the model that will allow you to do all of these things computationally. Now, the word model is, of course, bandied about quite a lot in the discussions around artificial intelligence. So I thought I would say a few words about what this magical model might be. You've met it many times in your education in high school, at university, and so on. This model is not an esoteric concept, but rather it is a formula. Here is an example of a model and a modeling process that human beings have done over history and arrived at a result that we use nowadays. So in the Middle Ages, in the 16th century, Tycho Brahe observed the planets every night through his telescope, and it took him 21 years to establish a table of planetary positions. Later on, John Kepler then used that data to convert it into the 3 laws that we learn in high school as Kepler's laws, which eventually were transformed by Newton into Newton's laws. And those simply tell you that planets move on ellipses, and there's a certain formula that describes how quickly they do this. And that formula, or those laws, that is the model. So in other words, a model is an equation, a mathematical language description of how the real world behaves, and as such is really a summary of empirical data that somebody has collected. In the olden days, here it was a manual collection process where Brahe actually wrote the numbers down in a notebook. Nowadays, it's an automatic data collection process with a sensor and a database. But the idea remains the same. You collect empirical data by some means, then you analyze it to find a pattern that is contained in that data, and you write that pattern down in mathematical language. And that mathematical language, that is the model. Now, the model that a human being produces is generally quite compact, like we see here on the slide. The equation is pretty short. We can write it down on a napkin. If we understand what the letters refer to, then we arrive also at some understanding in our minds on what that might mean or what the implications are of that. And that is, of course, the principal tax that you pay for artificial intelligence. The models that AI produces are in general so complicated, so long, that we can no longer write them down on a napkin and come to a human understanding, but they still work. And that is the primary benefit that we attain from AI. We develop the models very rapidly without having to invest 2 or 3 decades of human expertise into it, but we lose the understanding. And that's, of course, where many of the quibbles that people have in the energy industry and others with this process. So let's look at something that we usually call the digital oil field, which is an example of how this works in practice. So in the energy industry, of course, we deal a lot with the upstream and midstream sector by which we extract our oil or the gas, or in fact any other kind of mining asset from the ground, and then transport it to some sort of a factory where it is refined or made into goods that we can use. These are typically occurring over large geographical areas, many of which are inhospitable or difficult to reach because they might be in a very cold or a very hot or a very underpopulated area. And so usual connectivity is a challenge, getting internet out to these locations. So the first step in the digital oil field or the digital mine is really to digitize this. And the first error that the energy sector makes here is to confuse digitization with the digital transformation. Digitization, all it refers to really is to make available the information gathered at that place digitally in some method that is accessible to people who are not physically resident in that location, right? I hesitate to use the word cloud because it doesn't necessarily have to go via the internet to a server that's accessible to other people outside your organization. It could be a server that you own and run, and that's only accessible to people who work for the same company, and it's a very secured environment. But nonetheless, the data must be available on a central server somewhere where it can be used by people in different locations. So digitization is that process by which you have sensors that produce numbers. Those numbers have to somehow be able to transport themselves to a central location. And so you see on the diagram lots of white lines which indicate either wireless or wired transport lines by which data is collected from various endpoints. Those endpoints could be cameras where the data is an image. It could be the usual sensors where the data is a number, or it eventually becomes a time series, like temperature over time, volume over time, efficiency. It could be human related, like where is the workforce, which is essential for things like sending ambulances out into the field when there is a problem. You need to know who is out in the field, where are they, so that if they are in distress, you can very easily locate and rescue them. So various types of data is collected. That needs to be integrated into a workflow. That data has to be used for some purpose. And so there needs to be a workflow that dictates what happens to that data. On that basis, we can then do the usual artificial intelligence things we talk about. We can forecast maintenance activities, we can optimize processes, and thereby we can track the profitability of all these efforts. Digitization is the entry level, but it is not the destination. Beyond that, we of course have a few differences to what is usually regarded to be IoT. So if you Google IoT, don't believe everything you see at face value. For example, a popular thing to say is that sensors have become very cheap. Well, they have if you're thinking about an RFID chip in a supermarket. But the oil and gas industry, or mining in general for the energy industry, is not that way. We need to deploy sensors in harsh environments, generally outside. Maybe it's very hot or very cold. These sensors need to survive harsh conditions. And so sensors are generally actually quite expensive, thousands of dollars typically, to purchase, install, and connect a single sensor. And so there is an investment associated with digitization. Then typically mines and oil fields are in large areas, remote areas, so that there is a data transmission issue. For example, the oil field in the Kingdom of Bahrain is 10 miles wide by 10 miles high. So you're talking about a Wi-Fi system that has to work over 100 square miles. That again is an investment issue to make sure that the data transmission works out. Inaccessible locations makes for long response times, right? So if something goes wrong, until the maintenance crew gets in a truck and drives out there, some hours will go by. And so the need for prediction forecasting events is quite different from normal IoT, where all you have to do is walk downstairs to the data center. So keeping that in mind, there are a number of requirements to this integrated workflow, which starts with measuring and transmitting that data, then recording and visualizing it to people on a diagram, then having to interpret and diagnose what is wrong, what we're going to do about this. Then you need to actionize and plan. So what exactly are we going to do? Who's going to do it? When are they going to do it? Where are they going to do it? What do they need in order to get it done? And get them out there. And then, of course, track and trace. What has been done? Was it beneficial? Did it achieve its outcome? What can we learn for next time? This entire workflow has to be integrated, digitized in such a way that the handoffs between all of the individual people that are involved here is seamless and quick. So all of that can be done. Within the oil and gas industry specifically, there are many use cases, and I will not read through every single bullet point here, but the point of the slide is to get across that artificial intelligence has been used in a huge variety of different, very specific and targeted use cases to help either make the process safer, more efficient, cheaper, or obtain more revenue from the process, and in such way has been very beneficial to the business. Some of the lessons that we learned is that, for instance, the investment in the sensors is significant. So the entry level financially is unfortunately expensive. But once you've made that investment, the rest of the process is financially very cheap. The investment in software and the investment in analysis is very cheap compared to the investment in physical assets like sensors. You do need people, and you do need to focus on change management, and I'll get back to that in a minute. Some of the effort is invested into integrating all these IT systems. So if you want to do artificial intelligence, don't ignore the pedestrian efforts in actually doing the integration of software and IT systems. You need to put in some effort into all of this. And of course, some effort has to be expended on data science and artificial intelligence, but actually, in terms of the total number of labor hours, the hours that go down for data science and AI are actually in the minority. It's all the other stuff around it that is essential to help that system thrive. So there is more to it than data science. Let's look at what this might be. So generally, you think, I have some domain experts, let me upskill them in data science, or let me hire some data scientists and put them out in the field for a couple of days, they'll figure it out. My personal experience over many projects over the last 20 years has been that these attempts have virtually always ended in failure, because you simply cannot make one expert into an expert about a completely different area in effectively no time at all. Both people, the data scientist on the one hand and the domain expert, whoever that might be, the oil and gas expert, the mining expert, they will have spent years in education in their domain. They will have spent years more gaining experience, hands-on practical experience in their area. They will know about their tools. They will have a network of other people available. They will be able to do certain things in their area. Trying to convert them to be an expert in the other area will require an investment of years, which is not efficient. So one of the fundamental statements that I'd like to impart onto you is that the data scientist and the domain expert cannot be the same person. They necessarily are two people. In real life, they typically are about 10 people, because you need different domain experts and different data scientists. You might need a domain expert for the data historian, for the process control system, for the upstream sector, for this and that type of machinery, so that they together represent the problem or the situation. And the data scientist, you might also need more than one to do, for example, data cleansing and annotation, to do the machine learning, to do the interpretation and communication of the results. So you're looking at a team effort. That's my main statement here. And these two roles need to interact with each other, communicate, so that they learn from each other, and together they're able to both define the problem and solve the problem as a team. Now, what could be the problem? In terms of applying machine learning and artificial intelligence to the industry, there are 6 major areas that, in my opinion, cover most of it. One of them is anomaly detection, where all you do is say, this doesn't look normal, and alert that fact to a human expert who will then have to check out the rest. The second is a forecast. You say, tomorrow the situation will be like so-and-so. This is akin to, of course, the weather prediction that we watch on telly every day, but this will be much more detailed in terms of a time series where you might forecast what a well does and so on. Diagnosis is where you say, this is of a certain type, right? This type of data is indicative of a certain problem or non-problem, and then you might want to alert people to that fact. Soft sensor, where you convert a laboratory measurement to a calculation. This has become very well known in recent years, because laboratory measurements, of course, are unsafe. Somebody has to collect the sample. They are expensive, and they are very infrequent. You have to collect the sample, drive it to the lab. They have to make measurements. So you might do that once a day or a couple times a week. Once you convert that to a calculation, it can be in real time. Advanced process control, of course, has been around for a long time. AI assisted allows that to be nonlinear and therefore a lot more efficient and effective in getting the process controlled. Process optimization is kind of the most advanced stage in all of this, where you actually uplift the efficiency or effectiveness of the process by a full-on digital twin modeling of whatever process you're looking at. So virtually all of the use cases that I've seen in the energy industry fall into one of these 6 buckets. So if you think about those 6 concepts as being the possibilities, and then think about what might be your use case in your plant, taking that template and applying it to your process, you'll most likely be able to hit the right papers. Obviously, at some point, the business is going to have to come into this, and we'll need to define a larger ecosystem that consists not only of data and technology, but also the processes, the experience of the people, having a look at the industry, and of course, the business model to make sure that whatever it is that you are doing is going to be not just interesting, but profitable at the end of the day. So that needs to be taken into account, which will involve a large number of more people into the whole team, which makes it necessary to look at change management. This is a popular process display of change management where people initially are skeptical whether or not this will impact them individually with their own private lives or career lives in a good or bad way. And typically people will look at the disadvantages first, and it is then up to leadership to help people interpret this correctly for themselves and put themselves into context, and then actually like this process and see the change as somehow beneficial to them, right? So not only should this whole digitization, digital transformation, AI process be beneficial for the company and the physical assets, but it needs to be beneficial to the human people involved as well, and that needs to be communicated. And that in practice, again, in my personal experience, as well as many others, takes effort and time and investment into getting this done properly. I want to tell you about a few case studies where this has yielded some good benefits. So here, first of all, is a portrayal of process optimization, where here you're looking at 2 set points in the horizontal axis and the axis into the slide. And the vertical axis here is the result of changing those 2 set points, where we like the yield to be higher. So the mountain tops are good points and the valley bottoms are bad points in terms of yield. You can see that if we start at the point on the left-hand side and provide the identical conditions to the human, who is going to choose the gray path, and the AI is just going to choose the green path, they end up at different points, where the optimal point, according to AI, is in fact 5% higher in yield than the human-chosen gray path. Not only that, during the transition, the yield was higher along the green path. So AI in this particular case has yielded a 5% greater output of the process than the human guided process. And so the benefits here are real. And of course, for real plants, 5% translates to rather a lot of money generally. And so the profitability of such becomes immediate and very transparent. You can do things like load balancing between many wells connected to a single offshore platform that drove the yield up 7%. You can model the output of NOx and SOx measurements in the field very accurately, which allows you to get rid of the actual sensor array, which is expensive to buy and expensive to maintain. And there are, in some places, like in California, in the United States, there are regulatory fines when these sensors fail. So again, the business context here is immediate, and the mathematics is actually quite ready and easy to deploy. In many cases, it is vibration that is the best indicator of what's actually wrong with a piece of equipment, because there you don't just get a number, you get a whole spectrum of values, and then there's a fingerprint of a particular issue. We're used to seeing chemical emissions spectra that tell you what piece of material, what chemical element is in a piece of material. In this case, you're looking at vibration spectra going across in the horizontal line, and vertical, they are stacked on top of each other over time. In this diagram, you're looking at 6 months worth of vibration spectra stacked on top of each other. Blue here is very low vibration, green is medium vibration, black is very high vibration, so you see the amplitude and color. Clearly, there was some state of process that is more or less constant. At some point, you see it getting blacker and blacker before it hits a period where there's an obvious outage. The entire section was offline. And then post that, again, you have a continuation of the same thick black lines here. So obviously, a problem developed weeks prior to the outage, which was perfectly visible in a diagram like this. And artificial intelligence can quickly catch on to this. And it can then do two things. It can forecast when the outage is going to happen. And at the same time, it can tell you this is the vibration fingerprint of a certain kind of problem. So I can put a name to the madness and schedule a maintenance activity that can solve the problem. So diagnostics is possible by AI, and vibration signals are perfect for this. So just to sum up, artificial intelligence has many applications in the energy industry, in forecasting things, in diagnosing things, in optimizing things. The use cases abound in the industry. And if you want to learn more, I recently published a couple of books on the topic. There's machine learning in the oil and gas industry and machine learning in the power generation industry that are available from Elsevier if you want to read either some more about how artificial intelligence is actually deployed, what it is, how it's done, as well as reading about numerous case studies written by colleagues of mine from real operating companies, real practitioners in the field that have deployed these methods. That will give you much more information. You're also perfectly welcome to contact me directly at my email, via LinkedIn, or on my YouTube channel, where I present situations like this. So thank you very much for your attention, and I hope to speak with you soon. Bye-bye.
Welcome back to the interview series for Energy 4.0. My name is Jeffrey Can, and today, this interview, I'm joined by Pablo Rey, who is the simulation director for Technotom. And let me bring you onto the screen. Welcome, Pablo. Let's begin, though, with your perspectives around the current state of digital adoption in the energy industry and in your area of specialization. How do you see the current state today?
Well, we can see the digital technology is making their way in the energy sector. Maybe somewhat slower than in our sectors. It's true that the digitalization service is going for a while. We have several examples. For example, the simulator has been digital native systems, and we have working with simulators for a long time. All the control and monitoring systems have been digitized. And now we can see how we are moving to the digital world. Okay, but energy sector is a quite conservative sector that analyzes every decision in detail. And the sector is even facing a big challenge related with the decarbonization. And that means that a large part of the investment effort is oriented to this line.
Yeah, quite right. And so
I also the fact that the energy sector has the security of the supply within one of its main priorities make it quite more conservative in the introduction of new technologies. Nuclear case is a special case, okay, because of the regulations associated with safety, and this added to all the situation makes the change more difficult and costly. And it introduced a delay in the digital technologies to the plant operation. But however, the industry has recognized the need to improve their competitiveness, okay, if they want to survive in the market. So in the medium term, it's essential to address this process, this digitalization process.
Pablo, what do you see as the role of the digital twin modeling in helping the industry improve its performance? And what do you see that comes next? Because digital twin it's been a technology that nuclear has had for years. So, so how is it advancing, do you think?
Well, I think that this is an area of great interest and with enormous potential. Well, which, as you say, we have been working for a long time. Okay, the concept of the digital twin is very broad. Okay, and includes many diverse development, combining different enabling technologies. Okay, we can find a number of the definitions, but I think, in my opinion, the most relevant features of the digital twin is that they have to be oriented to support the decision making, and we need to have a clear idea of the degree of fidelity and connectivity that we need to pursue our objectives. Okay. We are seeing the role of the digital twin in specific cases that we are addressing, like the online monitoring of the asset of the deviations, the design of hybrid facilities. Okay, but the digital twin has to evolve during the entire life cycle, okay, from the economic feasibility study and analysis of the design to the validation, the virtual commissioning, and the future operation of the assets. And in that way is why the digital twin needs to be focused on the decision making and must be a living tool that evolves through the life of the installation. But you mentioned an interesting point, a concept that is the digital triplet. Okay, I think the process, asset, and humans are the pillars of the digital transformation, and humans are a fundamental part of the equation. Okay, we have to consider that we are going to handle a huge amount of information that will be processed by the machine following the criteria defined by the humans, but we need to be very careful with the information that we present to the human to avoid the overload of information and to facilitate the decision-making process. In that sense, we have been working for years in the human factors engineering area, and well, we are incorporating all the experience acquired to improve the user experience and the communication between the human and the machine.
Now, COP26 is coming. This is the new latest iteration of climate summits taking place in Aberdeen in November. What is your forecast about that conversation and those meetings in Aberdeen? Will they result in new solutions or new ideas coming into the market, do you think?
Yes, well, we have the 3 Ds of the energy transformation, okay? Digitization, decentralization, and decarbonization, okay? And decarbonization is driving the electrification, and at the same time, all the emission-free, CO2 emission-free generation. That, as I said before, this is mostly not dispatchable, like it can happen with solar or wind. These technologies are improving, but they still need to improve a little bit their performance. And I think that to cope with this increase in the electrification and the global demand, I think that nuclear will be the base piece to ensure the dispatchability with CO2-free energy sources. Okay. Nuclear power is tackling very relevant technology improvements with a lot of new designs that are appearing in many countries. I think that there are around 60 new designs in progress. As a matter of fact, we are actively working on the design of 3 modular reactor. Okay, and this design has an important component of digital technology. They are digital native designs. Okay, the storage is a solution to make the renewable dispatchable, but there are a lot of question marks still on the renewables. Okay, the batteries they will play an important role, undoubtedly, but they have significant limitations when considered as a global storage system, and we cannot forget the polluting component of the batteries.
Can you share what you see as the future talent profile for individuals working in the industry? We know that they will need more digital skills, but what other attributes would be important in the future, do you think?
Well, it's important about to people and not only about technology, because I think people is a key point to the digital transformation of the way. But at this point, I think that we should distinguish 2 aspects. The first one related with the capacities and the talents, okay, to be able to work with the new technologies. But there is another important aspect related with the cultural change from both people and organizations. Okay. Regarding the talent, well, I think data scientific experts in IoT and cybersecurity are clearly, the demand is increasing clearly, and it's not easy to get them and to get the best. And we need them to advance in this transformation. Okay? But there is another aspect related with the people that we cannot forget, and it's our current workforce. Okay? We have a huge challenge with the upskilling and the reskilling of our current workers. And in that sense, the digital transformation is helping us and playing a relevant role with the development of new remote and collaborative training tools and training methodologies, including simulation, of course. Regarding the other point, that is the cultural change, well, it's clear. We need to move from do digital to be digital. And the companies need to see the digital transformation as a business enabler, okay? And adopt the necessary policies to promote that change. In that sense, we also need to pay special attention to the digital soft skills, okay, such as remote leadership, communication, team working, talent management, and everything in remote. The thing has changed a lot. Okay, we have moved from a model of to a leadership from the results or objectives to a leadership based on the confidence. Okay, and this is an important cultural change. Okay. And it's very important to consider also the engagement of the young people. As I said before, it's very important to make our facilities and our working environment attractive for them, with technologically attractive to allow them develop their talent.
Pablo, it's been a fascinating discussion. Appreciate you taking the time to meet with me today.
Thank you very much, Geoffrey. It has been a pleasure for me also.
And so that brings to a close this interview, and look forward to seeing and engaging with other experts in the industry, and I will return in short order. Bye for now.
Hello, good morning. Thank you so much for connecting to this presentation. I'm going to explain which is our approach for improving the power plants, power assets, operation and maintenance through artificial intelligence combined with the deep knowledge of the process. First of all, I'm going to try to explain which are some of the challenges that we are seeing on the O&M of power plants. And when I say power plants, I mean all the different technologies that we can have, like fossil plants, renewable, nuclear. All the different assets have some specific challenges, but there are some of them which are common for them. Like for instance, we can talk about some restrictions that we can have from the market. There are some different technologies that are growing up. There are some competitors. We have some restrictions due to the fuel prices. That at this moment is very critical, as we are seeing on the global markets. We have also the pressure to reduce the cost and consumptions of the power plants. So reduce O&M cost is really a must, and it is going to be even higher in the near future. Also, the flexibility that is asked to the power assets is increasing. The flexibility of adapting the electricity production according to the needs from the market, from the consumers. And also, we need to make the right decisions in our assets, in the management of our assets, in uncertain conditions. That is something that is very critical. So we need to count on some tools in order to make the best decisions. We can use some technologies. There are some emerging technologies that are promising us to help us. However, with our experience, some of those technologies, the important part is how to use them, how to combine the technologies with the deep knowledge of the process in order to solve specific problems of the plants. Otherwise, it is going to be just technology thing, and it is not going to solve the problems that we can have. So Technaton is an engineering company that is serving the utilities for more than 60 years, and we are experts on the operation and maintenance of assets of different technologies. So we have created what we call TechOS. TechOS is our suite of solutions to support, facilitate, and optimize the power plant operations. The goal is to provide the customers digital solutions to optimize the operations, to fix specific problems. We have some different solutions for digital worker, for process optimization, for monitoring of the assets, and for asset management. And something that is critical, our differential factor, is the knowledge that we have of the process, of the operation and maintenance of the different technologies. That is our expertise, and what we do, our approach, is to combine this process knowledge with all the different technologies. And in particular, I'm going to explain how we are applying these machine learning, artificial intelligence technologies, teaming with our process knowledge in order to fix specific problems of the plant. So I'm going to explain you 5 examples. The first 4 examples are going to be very briefly, and at the last one, I'm going to explain in more details. So the first one that I want to introduce is the ACM, the Advanced Condition Monitoring. We are providing this kind of services to different plants of different technologies in order to be able to detect in advance degradation of components. How we do that? With machine learning algorithms. So we are taking value from the current data in order to reduce the O&M costs. However, with our experience applying this kind of technologies is very complicated to receive value if you don't have experts in the O&M doing the analysis of the results from the algorithms. And that is what we do. We train the models, but we have our O&M experts that are analyzing the results and that are alerting the plant in case a degradation is being detected and some actions are needed. And as a result of that, we are reducing by far the false positives. That is one of the key things on this kind of solutions. And we are providing a lot of value. We measure one of the KPI that we have for this kind of projects, or key performance indicators, is the return of investment, the value that is being generated by the alerts, and it is normally doubling the cost of the service. So that is the first example that I wanted to give you. Another example of how we are applying artificial intelligence combined with the deep knowledge of the process is what we call TechOS Alert. This is a system where we are using artificial intelligence in order to filter and optimize the alarm management. So we have trained those algorithms, as always, with the expertise on the operation, in order to help the operators to solve the problems, because the system with the algorithms is going to identify which are the most important alarms in case of alarm flood in order to actuate. So this is the second example. Next one is related with the performance. So we have a software tool that is called TechOS Software. That is an online performance monitoring tool. So it is monitoring the heat rate performance of the plants, helping the monitoring center to identify and quantify deviations in the performance. We are applying artificial intelligence in order to provide to the users some help, some support tools during the identification, the diagnosis of the problems that are causing those deviations. So this is a good example of how the machine learning algorithms are supporting the users of this application in order to identify the degradation. And those degradations in performance, those deviations in performance affect the fuel costs or the production. So the return of investment of this solution is also very high. And the fourth example is how we are applying artificial intelligence in our digital worker solutions. For instance, in TechOS View, we have an interactive PNIDs layout. What we do with this solution is that we process with machine learning algorithms the different drawings of the plant, and we connect with the different sources of information, and with our experts in operation, we aggregate value with the different sources of information. So what we have is like a Google Maps of your plant. So you can search for a component and to receive all the different information. So those were the examples that I wanted to highlight of different applications of our approach of combining process knowledge and artificial intelligence. And with the fifth example, I'm going to give more details. I'm going to focus more on this one because of the momentum that we have. Right now, the gas prices are really, really high, so it is affecting a lot to the combined cycles. And one of the key elements for the combined cycles is to be able to do the startup very fast, saving the costs, and supplying the electricity at the moment that is requested by the market. So this is really a challenge for the combined cycles due to those market restrictions that we may have, to the costs that we suffer, and also that in case we are not able to provide the power at the right moment, we may receive less money from the market, and also we may need to pay some penalties, and also there are some carbon costs that need to be considered. And actually, if in some markets, if a combined cycle is not able to be competitive during the startups, they can lose the opportunity to enter in the market. And of course, it is always needed to be able to have data in order to optimize the process, to enhance the process. So with those challenges, what our experts in the operation have created is a system that we call TechOS Start. And this system is the best example of how we are combining our deep knowledge on the process, on the O&M, and those artificial intelligence technologies. What we do, how we do it in order to install and configure TechOS Start for a combined cycle. So we do that in 4 steps. In the first one, we categorize the startup type and all the different complex processes that we have. Then we use historical data to train the artificial intelligence model. Then we can store the application connected with real-time data in order to provide to the user the data that they need at the right moment. So when they are going to do a startup of the plant, they will have the estimate of how good they will be able to start up with the current conditions, and they are going to receive some warnings when they need to provide actions, and they are going to receive updates of the estimate. And to see that in more detail, process categorization, what does it mean? It means that the process of starting up a plant is complicated. So our experts take the process startup of the specific plant and categorize that during some workshops with the plant, with the staff of the plant, and we identify which are the complex process, we identify which are the fixed process, which are the critical maneuvers, the critical permissives, and we identify in which areas of the process it will be more interesting to apply some machine learning algorithms in order to enhance the predictions. Once we have done that, that is where the key value is, because that is really where the experts add value in order to have everything very clear. We start training the models with the historical data that we normally take from OSIsoft PI or similar system. We train our models, we validate with real startups, we start validating with real-time startups, and with that, we provide a very good user experience. And that user experience is covering the whole process. So before we are going to do a startup of the plant, we can have the best estimate on how the startup is going to be. So we are going to see a curve that is going to be exactly the best startup that we can have with the current conditions due to the specifics of the plant and due to the historical data that we have. We are going to see how it is going to evolve during the time. So we are going to know when we should start the process in order to provide the electricity that the market is requiring to us. We are going to optimize the consumptions of fuel and auxiliaries, and we are going to maximize the energy output with that estimate. And we are going to be able to provide to the market the best estimates, so we are going to be in a better position to enter in the market, to be selected to provide energy to the market in case we are in a competitive market. Then we start the process, we start the plant. So during the startup process that takes some hours, we are going to have some follow-up. So we have a specific front end that we are going to be viewing, which is our estimate, how it is evolving, because it is going to be recalculated in real time. In case we have some deviations, we are going to be alerted. And when we have some critical maneuvers, and when I say critical, I mean something that is going to impact on the startup process, on the cost, on the consumption, on the output energy, we are going to receive also some alerts from the application. So that is a critical application for the operators at the control room. And then after the startup, we have also an analysis tool where we are going to have some analytics where we can exploit the data of the different startups. We can have a reporting on how good really the startup was compared with the estimate that we have, and we can be comparing different startups. And even if we are a fleet and we have different plants, we can be comparing different plants if needed. I am referring all the time to combined cycles. That is an option, a combined cycle, but that can be applied also to other technologies like CSPs, different plants that are starting up often. I have also an example of the front end in order to see the user experience. It is a very clean and user-friendly application. So we just received the information that is needed. We don't need to restart the operator. And using that, our clients, the users are receiving a lot of benefits. But we can sum up this in that they are providing the best estimates. So they are not given out of the market. They are reducing the costs, and they are able to enhance the process. Actually, the first plant that implemented this system received an important award of application of artificial intelligence technologies. And in order to end my presentation, I'm going back to our approach. So this approach is to combine the expert process knowledge with the artificial intelligence technologies, putting both profiles working together. And we have seen some success stories of this approach on how we are using that to fix specific O&M problems. So for those who want to explore the potential cooperation with us in order to fix those problems or others, applying technology and the expertise, this is how we can move forward. You can contact us, we can discuss the specifics of your plant and your problem, and we can build together a business case analysis and potentially to start with a pilot project and then to scale up. So those who want to contact me, I am going to be available during those days with ENERGY, and otherwise you can contact me through email or LinkedIn. So thank you so much for your attention.
Hi, and welcome to my presentation. My name is Thomas Hubauer. I am a portfolio manager for knowledge graph and semantics at Siemens Technology. I'm also technical lead for an application field called data readiness. And in today's presentation, I would like to share with you how we at Siemens, how our path at Siemens looks like, getting from data to autonomous decisions using the technologies and processes that we have developed as part of our application field data readiness. Digital twins are everywhere. However, building a digital twin can be really expensive. Picking just one example from our business, it's a typical situation that it can take an expert 2 weeks to build a digital twin of a system. For instance, in this case, an as-maintained bill of material, which he needs, for instance, in SAP as a requirement for some business process building on that. So there's a huge barrier to actually start working with the digital twin. However, what are those digital twins and where do they reside? Typically, the digital twin doesn't exist in one single system which you could use as a source. Instead, the information required to build a digital twin is distributed across a variety of systems. We like to classify the different system and types of data they contain into 1D, 2D, and 3D data. 1D data for us is the typical structured type of data. You have entities, you have attributes. So that would be all the typical corporate IT systems you find. It's customer relationships management, but also very use case specific systems such as configurators for certain products. On top of that, we have 2D data. This is diagrams and documents. Especially in context of brownfield data, it's obvious that a lot of historic data talking about your assets is not available in digital systems. Instead, you will find this information in service reports, in drawings, maybe even in handwritten documents. So there is a challenge to make this information, the data contained in those documents, accessible for your processes by making it part of your digital twin. Last but not least, 3D data would be computer-aided design and point cloud data. So it's kind of, again, getting a bit back to structured data. However, the complexity increases significantly, and we're really talking about huge amounts of data there. So knowing those data sources, the question is still, why is it so expensive to build a digital twin? And the key observation that we have been making over time here is that typically for each and every application, people start identifying the required information, finding the data sources, finding ways to extract the information, thinking about suitable target data models, writing ETL code to convert the data, thinking about integrating data from different sources, and all this into one application-specific target data model, which then serves one single application. This, of course, hugely drives development cost, because basically for each new application, you have to go through the whole process again. So instead, what we have been introducing at Siemens is the use of knowledge graphs as a technology that enables us to build what we call a digital twin fabric, which consistently and flexibly allows us to link over those different data silos and provide one consistent data model to all applications, which can then be reused. We like to use the term of a digital twin fabric here, which provides integrated and standardized access. And there's a number of building blocks that basically comprise this semantic digital twin model. First and foremost, and that's the orange part on the slide, we need a shared terminology. We need a shared data model. This alone can be a huge challenge, as we need to align all the different stakeholders, all the different sources, but also the needs of all those different applications, and bring this together into one data model that matches the needs of all those different users and applications, and still remains consistent, even though it needs to bring together very different views. Also here, to avoid having to do this over and over again for like each collection of applications, we have been developing what we call an internal ontology library at Siemens, which comprises of a number of reusable building blocks that we use, for instance, to talk about bills of material. But really, it's not only limited to that. We also have modules coming from very different domains, for instance, to talk about buildings. Secondly, of course, what we need is the instance data. And this is kind of the middle and lower part of the graph you see. The way you can envision this is that basically for all those different sources, we first find ways to take their data and map them into a potentially intermediate model, which is already has some level of semantics attached, but might not yet be our final model. Then in a second step, the task we have to solve is basically bringing those local models together and align them with the one shared model, which is given by our shared ontology. On the one hand, this means mapping attributes, finding ways to express relations given our target data model. But there's also more to it, because typically your different data sources will not be talking about distinct entities. They will be talking about different aspects of the same entities. So one problem, one challenge we have to solve on the go is what we call the entity reconciliation problem. This means, based on the information that the different data sources give us, we need to identify when two sources are talking about the same entity, and we need to merge this information. By doing this, we need to take care of things such as consistency. So when two sources talk about the same entity, as long as they talk about different attributes, everything might be fine. If they talk about the same attribute, but give us different values, then we need strategies to cope with that. Those strategies might even be use case dependent, or dependent on the IT environment, such as a certain system being declared the lead IT system. By solving all those problems, what you get is basically one consistent representation of the information about your entity or entities coming from all those different sources. And this integrated and standardized representation is what we call the digital twin. And yeah, it's represented as what we call the so-called digital twin fabric, which gives us one standardized way to access all this data. Just as a quick note, bringing this information together doesn't always mean that we put everything together into one single data silo. That might make sense for information which is kind of static and not changing a lot. However, in other systems, you might also have highly dynamic information, or it might be complex rules which you do not want to export and be able to take care of yourself. So some of those sources might also be connected virtually. So we are talking about federation or virtual data integration in that case. And this then allows us to basically leave the data in the original systems and only pull it on demand. Now, going one step further, it's not always the case that we need a full-fledged digital twin, including all this information to start creating value. And that's really important. That's a learning we had over time. If you wait for the perfect one digital twin and only then think about creating value, then nobody's willing to pay for it, nobody can afford it, and it's really hard to convince business and management that they want to invest. Therefore, from our experience, it typically helps a lot to start with quick wins. And just to show you a few examples, one example could be what we call master tag lists. So looking primarily at the structured sources, which can typically be easier to handle, and basically consolidate different tags or attributes you get from them, bring them together in one list, and making them accessible in one consistent way. Already this can create a tremendous amount of value for a user. On top, a potential next step is including information that's contained in documents. One typical example, which I will go to in a bit more detail later, is P&I digitalization. Here, what we're doing is basically extracting semantic information from 2D drawings, so-called piping and instrumentation diagrams, and bringing this information together with the information we already get from the structured systems. And then on top, you can, of course, go beyond and bring in 3D data and maybe even other types of data, be it time series, whatnot. The important part is really start creating value early. So now I would like to show you one concrete example how bringing together structured and unstructured information from piping and instrumentation diagrams is creating value at Siemens. This example is coming from our colleagues at Siemens Energy, who've kind of been also very helpful for us and a really great partner for us to build up all the technology stack and all the processes that I'm showing here. The challenge that our colleagues at Siemens Energy were having, just like similar to the example of the statement I had on my very first slide, is they need an as-maintained bill of material in SAP. This is a requirement for some other business processes building on it. However, the information they need to do to create this as-maintained BOM is coming from at least 3 different sources. We have Teamcenter or SAP, which is structured information talking, for instance, about design BOMs. We have drawings, in this case, P&IDs. They help us understand systems we're not building ourselves, so where we do not have design information in a structured format. And last but not least, service documents. They help us to understand how the system has evolved over time. As you can see in the drawing, we need to apply a number of different technologies, transformation and mapping for structured data, image recognition, symbol detection, and so on for the drawings, but also natural language processing for service documents to extract the required information and then integrate it in one semantic model where we have to address all those challenges I mentioned already, entity resolution, consistency checking, and so on. We like to use knowledge graphs as the data structure where all this integration happens. And basically, this knowledge graph could be understood as maybe, if you want to say, the digital twin of the turbine. I'm emphasizing the "the" because for me, there's not one digital twin. There can be several, depending on the aspects you want to look at. But this is kind of the richest representation that we can have of this turbine. From here, there's different ways we can proceed. In this use case, we're basically using queries against this integrated graph to export the target structure and bring the data into SAP. What I would like to emphasize here is in this graph, we have the full history of the turbine. So in this graph, you could basically like zoom through the lifeline of the turbine and see how it developed over time. This is great. This is exciting for me as a techie. For the business case, what we're doing is we're using the last known state. We're exporting the data. We're bringing it into the operational IT system. And based on that, repair and overhaul processes can be triggered. So this is a great thing, great achievement technologically. What's in there for the business? So for the business, numbers show they have an 80% cost reduction for generation of as-maintained bill of material. Now, why maybe only 80%? As you can see here, we're striving for a very high degree of automation, yet it's not possible to have this fully automated. So there's a few specific points where we want the user to interact, where we want the user to tell us if things are correct. And so there's still some human involvement. Still, we kind of multiply the number of turbines one guy can work on by 5. So we're really creating a huge lever for business here. As a consequence of having all this information available, sales, mods and upgrades, parts sales, they are up to 90% faster, for clarifying quotes and understanding what could we offer to this customer, what should be the price, and so on. And also the quality of those quotes is improved, so we end up with a higher hit rate. The business is quite happy about this. I want to give you a bit more a technical view just to have some idea of the type of data we're looking at. Here you're seeing service reports. And the red highlights show a bit the type of information we're interested in. As you can see, it's kind of relatively meaningless strings. So very often the extraction alone doesn't help. You need to bring this information together with data you have from other systems, such as configuration management systems, to tell you how to interpret the data. Moreover, the position in the document may give a different meaning to exactly the same string. So it's not just sufficient to extract any string and be happy. No, we need to keep track of where did it occur, in which context did it occur. And this is an automated pipeline we've built, which extracts this information, brings it into a structured format, and then again shows it to a human as especially part of information where our machine learning algorithms tell us, yeah, I'm not 100% sure. Why? Because for the use case I've explained to you, it's vital that we have 100% data quality in this step. Therefore, whenever the automated processes are not fully sure, we have a human check. So we have a manual QA process which builds on top of the automated part you see below: OCR, character recognition, NLP, text extraction, some data quality logic we are applying already. And then on top, when all this is done, we have a human look at the data and give us a thumbs up, thumbs down. Another type of information we're looking at is piping and instrumentation diagrams. The challenges we have to solve here is extracting symbols, understanding all the text that those symbols are annotated with, understanding how to which symbol certain text belongs, but also extract the piping, so which things are connected. And all this in the end gives us, basically a bill of material and connectivity information of a certain subsystem of our turbine. Again, here we need extremely high quality data to be extracted. Therefore, what we've built, and you see live screenshots of the system here, we've built an interactive system that displays the extraction result to a user, again, in the current version, even with highlighting of certainty, and then allows the user to say, yeah, I'm happy with that, or no, I want to change something. And this is where active learning comes in, because if a user tells us, no, the symbol is actually not a motor, but it's a certain type of pump, then we will collect this feedback and we will retrain our models. So the more people use the system, the smarter we will in the end get. Taking a step back, what I've shown you now is what we would call a data companion. It automates the process of extracting data and bringing data into a valuable format. Obviously, this is by far not the end of the journey. For me, it's kind of the starting point. We have this great digital representation of our asset, and there's so much more we can do. One still relatively simple example would be smart search and question answering. And looking at the use case I've just explained, I'll never forget the excitement I saw in the eyes of the turbine technicians when we showed them a graph just like the one you can kind of see on this small picture, which allowed them to understand which type of equipment is deployed where, and they could flexibly slice and dice the data and really get a fleet level view of what they're doing. Yet there's more, and one quick other glimpse I want to give you is recommender systems, especially with an emphasis of also being able to explain the decisions. Jumping to a slightly different domain here, we're now in industry, we're in configuring industrial IT systems or industrial OT systems, industrial automation systems. And here what we've developed is so-called sequential recommenders. So it's a challenging task to basically, even if you have your components, to set them up in the proper way. And we are using the digital twin of basically the system. So the digital twin with all its technical features. We're using historic data of user operations to then build a graph, knowledge graph of the system. And we're using a task called link prediction to basically make proposals for the user of what he or she might in the end want to do. As a result, we can show that we get an order of magnitude reduction in configuration time, while at the same time giving the user very application-driven proposals for components, and even being able to give recommendations for hitherto unseen items. So to close, for us at Siemens, we've realized creating digital twins is highly expensive. I've shown you what we call data cleansing as one example. We have different technologies to tackle this using industrial data models, collections of ontologies, and so on. And for us, graphs are a core ingredient where we bring together all this information in what we call the digital twin fabric. As a result, we have this integrated, rich, context-enriched data, which provides huge opportunities for business, ranging from relatively simple things, such as having a bill of material available, to complex machine learning-based applications that can, for instance, be based on recommender systems. With this, I would like to close. If there's any questions, if this caught your interest, I'm happy to hear from you, also to get your feedback and to learn what you guys are doing. My name is Thomas, and as mentioned, I'm an application field lead for data readiness. Happy to hear from you. Thanks a lot.
Thank you. I have titled this presentation as Rewiring of the Real-Time Solution. As the technology has changed, we need to get aligned with that. My name is Romulo Samuel. I am a technology fellow at Halliburton, based in Houston. Before that, I just wanted to give a brief background and punctuate it with a timeline that we are in. This slide shows the time versus knowledge, how the industry has progressed. You can see, initially we drilled the vertical wells and started progressing, and we literally started punching vertical holes. Then the bifurcation happened. A lot of new tools have happened. A lot of new directional tools were introduced. That took the industry to the next level of horizontal drilling. Now we are literally punching horizontal holes. That is exactly, we are in the bifurcation point. Now the next phase is the exponential growth in lockstep with the exponential technologies. That's what we call the cyber drilling system. That also in real time. Now, when you consider the exponential growth, it has to align with the exponential technologies that I call exponential surprise factor. Either we follow that exponential growth or we fall flat as in the previous cycles. Now, the fundamental question to be asked is, when does the bifurcation happen? When does it happen? The bifurcation happens mainly when the industry goes into contraction mode. So when you look at the number of rigs, that helps us a proxy to pinpoint and peg this bifurcation point. The first bifurcation happened during the 1984, the major downturn. After that, a lot of new tools were introduced. That took to the next phase. Now we are seeing this bifurcation point in another contraction mode. It's a protracted contraction mode the industry is seeing. And also at the same time, we are seeing the exponential technologies in alignment with this bifurcation point. Now, the contrary also happens. Right? When it is expanding, we tend to produce ineffective process, ineffective tools that we don't want to see when it is in the contraction mode. Now, I would like to take you through how industry in another phase is taking place. I'd like to take you through two examples. One is the aerospace. A lot of changes are happening, removing the control structure, the physical structure, and moving to a cyber physical system. That is completely being rewired, where you can see the next one is the medical industry, where it is completely rewired. You can have remote surgery with advanced robotic systems, artificial intelligence, machine learning driven systems. So in the previous example and this example, completely it is changing the landscape. Exactly, it is also in alignment with the exponential technologies. You see the telehealth, where we can see everything in the wrist, all the measurements. Now we wanted to take this type of technologies and to see what is driving this technology. One is the sensors, devices that are advanced. The second is modern algorithms that are underneath this. Machine learning, artificial intelligence, AL, ML, all these things are deep learning or hand-holding it. Now, faster processing speed. The processes are much faster compared to the previous years. Apart from that, improved visualization. Take the results and quickly view it in different devices. Beyond that, they have advanced medical sciences engineering. That is important. That we should not forget. Now, can we take this telehealth approach to monitor the health of a well? So you can see the same approach that we can take it also. Now we have seen a lot of exponential technologies, the tools, the AR, VR, but we have to use the science and engineering also. And we have to optimize the system so that we can take it not only on the wrist, but on the palm of our hands. So the complete system has to be rewired. That's what we call the well construction 4.0. Now, what is driving it? It is the same approaches: sensor devices, modern algorithms, faster processing speed, improved visualization, and advanced well engineering. It is never offline, on the go, anywhere, on demand, that we can monitor and control the system. Now, when you look at the present real-time drilling scenarios, we have real-time centers where we can monitor using the software, real-time surface quality, data validation, or done manually as well as automatically. So you can see the operation center architects. We have different disciplines combined also. Sometimes on his own right, they can be analyzed based on the disciplines that we use. Now, we can take it to the office where people can monitor with a single screen or multiple screens, where we can see multiple screens. That's what the field and offices are brought together. And it also gives accelerated learning scenarios, where you can see multi-tenant, multiple rigs monitoring in a single place. It is becoming very complex because of the underpinning technologies and other things. So, but we have to take it to the next level, that we have to rewire it. That is the one that I am presenting. Bringing field to the office to the palm for quick decision, on the go, anywhere, anytime. So now, what is the economic value that we are bringing? Now the system is evergreen, completely updated, using the digitalization, digital technologies. So in this process, you can see the interconnected system, where the surface equipments, the downhole sensors are all ingested. Then you can pass through the cloud technology or the local appliance. Then you take it to the server or the cloud, where you can analyze. Then you can send it back. It is a bi-directional system where we can control and steer. And also you can see other managements like fluid management, and ultimately this provides an opportunity for multi-objective optimization. Now beyond that, a broader scope, which you can see here, it is a similar approach and a similar structure, but we want to analyze at a much faster pace. So you can see all the left side, rig equipment data, surface sensors, downhole sensors, tools, and we have the edge devices. Also, we want to analyze at the edge. You can now have the capacity to do edge analytics Also, then we can take it to the cloud for office use. So you can see different offerings like Decision Space, artificial intelligence platform, and the engineering platform. Then you take it to the same similar approach of real-time operating center. Now it has the option to connect edge devices, IIoT devices, so that you can be evergreen. And also you can, as I said, it's a bidirectional. It can go back and forth. Now, wanted to particularly highlight this. That is the brain behind it. You can do all the analysis, not only at the edge, but also at the cloud. So both are in sync. Sometimes you may not be in, you may have some problem in the connectivity, but you can still do it at the edge. Then take it up. So you can see here, the operating center now becomes a real-time office-related structural center, now becomes a virtual center, which can be on the cloud. You don't need the brick and mortar system, but it is all a digital system that are interconnected. And also, instead of multiple monitors monitoring several wells and several rigs, now it can be a single pane glass window that you can select on demand as we go and generate alerts. Not necessarily you have to have thousands of dials. Some some may not be useful at all. So automatically it will be guided intelligently so that the alerts are given. So you can set the threshold so that you can continuously monitor what is happening behind it. So that is a point that needs to be highlighted here. Now, what is the architectural stack? We have the digital well program, which is in short called the DWP, whereas two systems. One is the well programming, where you can program or in the planning stage. Then take it to the next level during construction platform that you are executing. And both are interconnected, and you can make the program evergreen as you get new data. So on the well program, you can see analytics engine, well construction, related things, plan, design, and also integrated with the supply chain. On the well execution time, or the execution phase, where you can see real time, that is being rewired in such a way that you can do multi-variate optimization on the go with the connection to different engineering microservices. That will take you to the next level of automation. So you can feed and give the set points what needs to be adjusted. And as I mentioned earlier, you have the edge analytics also at the same time, doing analytics and feeding and reinforcing the learning process. Now, you can see what are the engineering models. As I said, engineering models are very important, whether it is an aerospace or a medical industry. The medical science and engineering or aerospace engineering also improved or getting improved with advanced engineering models. Now we have well planning softwares, engineering software like the stress check, well plan, well engineering, calculations, and also cost analysis. And of course, the data storage related things, and the EDM is the engineering data model, over which all these engineering models sit on it. Now we can make all these things. These are made as microservices, and you can call at wish, and it becomes a system of no touch option. Now, summarizing, the same way that the aerospace is transforming, or the medical industry is transforming, we are also transforming towards the well construction 4.0 in alignment with the industrial revolution IR 4.0. So it is from the rig to the cloud and to the palm of our hand. May look very complex, but underneath a lot of things, or it may be very easy to depict, but a lot of complex things are running behind it, as same as in other industries. With that, I would like to reinforce the model that it is and pinpoint the engineering models that are driving behind it. So that is important. With that, now we can see it is an artificial engineering intelligence. It is not artificial general intelligence, or not like a regular AI we talk. It has hyper time compression, a lot of data or pipeline in real time. Then we have to have extreme convergence of multiple engineering calculations with multiple objective functions, multiple constraints, and we need to have a digital mesh that are stitched together so that we have a science, engineering, and technology coupled, rewired system. That is what I call optimized, connected, on the go. With that, I would like to conclude my presentation, and thank you for the opportunity to present what we are developing. Thank you.
Today's connected businesses have to be more efficient in order to be profitable. Could you imagine not having a cell phone? Or not being able to quickly search the internet for answers to complex problems? Or ordering anything you need with just a few mouse clicks? Where would we be without the speed of text messaging? Or how would we be able to stay in touch with mom without the convenience of social media? It can be like that for your business too. The Internet of Things, or IoT, helps connect sensor data from data anywhere in the world to state-of-the-art analytics that provide you with the information you need in order to make decisions that benefit your operation. Unlock the power of IoT for your business and manufacturing process using Sorba, the world's leading enterprise platform for IoT. Use Sorba to collect data from devices in a secure and reliable way. Integrate your devices with the enterprise. Perform real-time big data analytics and machine learning analysis. Launch new products and services. Reduce deployment time, cost, and risk. So, how can Sorba help? Integrate your devices, processes, and services using our Sorba API. Sorba SDC collects data and is fully integrated with industrial communications protocols that talk to your machines. The Sorba Big Data Platform has the power to manage and control millions of connected devices. Sorba Historian can store as much data as you need. Sorba Analytics can derive valuable information. Sorba Machine Learning can predict and prevent failures, improves efficiency, keeps people safe, protects the environment, and diagnoses your systems. It's like having your own personal doctor for your business. Make your machines smarter by running our machine learning algorithms in your PLCs. Sorba Advanced Control can help. Use Sorba Remote Access to connect your devices from anywhere in the world and save money, and avoid downtime as a result of having to do on-site troubleshooting. You will get peace of mind knowing Sorba is hard at work alerting and sending alarms when things go wrong. It's like having smart virtual operators working 24/7 who never take a coffee break. Sorba connects factory data and enterprise to improve efficiency and become more competitive, building smart connected products that talk to each other and back to you in real time. Take the knowledge you learn from one system and share it with others. Build communities of smart, intelligent machines that maximize efficiency and profit. Take a test drive today and let Sorba put your device data to work. It is the competitive advantage that will make the difference. Work with us to make your enterprise IoT ready.
Hello, everyone. Thank you for joining today's session. My name is AJ Alexander, co-founder and CRO of Sorba AI. We're an enterprise software company focused on making machines smart and helping customers through the democratization of AI and machine learning. So really empowering users that don't have a data science background or coding background to build and deploy these solutions at scale. So a little bit about us. We've been doing this for a long time. Our whole team's got over like 100 years in factory automation, control background, how Sorba was conceived, and what the problem we were also trying to help the industry solve was this, all the cutting edge technology academia is working on versus the emerging technologies and the trends and solutions versus the gap in terms of how industry is taking advantage of some of the cutting edge solutions that it's been around for a long time, but allowing it to come on the scene pretty explosively due to the increase in computing, the accessibility, due to the open source community. So now a lot of these solutions at an enterprise level, where you're power generation, manufacturing, transportation, or utility focused, it's now taking this concept of web services and deploying it in very legacy or brownfield environments, and doing this at scale. That's very important theme of today's session. Biggest problem, another one of the biggest problems in the industry has really due to the true adoption and total cost of ownership associated with AI machine learning and adopting it and implementing it to improve energy efficiencies and to be a much more sustainable producer of goods in the global economy. So understanding that we feel that if this is going to be our goal to democratize and to make this kind of technology ubiquitous, we want to put it in the hands of the subject matter expert and that domain expert, that if they only had access to this tool, they'd be the best candidate to take full ownership of these kind of solutions, and then generating some of these global and agnostic energy reduction KPIs, whether it's kilowatts or fuel related, across any of your combustion assets, and agnostic to essentially any control processor or asset, whether you're discrete, your continuous process, or your batch. There is no constraints there for Sorba AI. So there's another big emphasis, a theme around being production ready, being operational. How do we have better, more efficient, explainable AI? How do we decompose the black box to gray to white? So it all starts with the source and the machine. What does the ETL look like? Can we automate all the steps in the connecting, collection, the processing steps in your journey when it comes to using AI to reduce energy? And a lot of this being done at the edge. And that's one thing we take pride in as a company, is we are an edge, a fog, or we can be a hybrid with the edge and the cloud. How Sorba is commissioned, hosted, deployed. There is no constraints to who your cloud services provider. And then if there are, and you have a strict regulatory requirements like NERC and FERC, especially in power, we can actually commission this on a machine as small as the one you're probably watching this session on, or as small as a Raspberry Pi. So all that computing being done at the edge in real time to better control your equipment to generate whatever that optimization objective is. Going to the next step in these flows this is really just kind of walking you through some of the mechanics, right, on how the user would use Sorba AI, and then really focusing that this decision making is being done next to the equipment, whether you're on the automation side of your network or on the DMZ side. So we talk about, this is a platform, we are an operating system where you are running Windows license maybe on your computer, and you've got Excel and Word and OneNote and all these great applications. Same concept when it comes to our platform, where users are doing it for energy, or they're wanting to improve OEE, or they're trying to get much more advanced on their existing condition-based monitoring strategies. We're definitely seeing the payback, or seeing the the value and how this gets operationalized in real time is translating into significant dollars per site or per asset in terms of savings. As you guys are thinking through this logically as a decision maker, a lot of times maybe energy and fluids or anything around sustainability is usually prioritized last, where now a lot of executives are understanding the payback can be achieved much faster with a lot less overhead, generating much greater dividends over the course of three to 5 years. And where Sorbus sits uniquely is obviously it's very attractive from a no-brainer and ability to quickly validate what is the value in the data. And if we were to have this model in production, what would this look like for the business? So great returns, in addition to having what we call the franchisee handbook, the O&M manual, the McDonald's manual for organizations to take this template, how to train their teams here from the install to the application, to some of the configuration of both the edge, how to collect data, how to model the data, how to deploy your model, how to retrain your model, how to actually take these data science scores that are being automated and generated for the user, how to put it in the context and the nomenclature of your production process. And then lastly, the theme of scale. Can I, now that I have a good working energy reduction model for kilowatts and compressors, can I take this to more compressors, to more sites, right? Even if it is, of different OEM, and the understanding that there's going to be some massaging required. So turnkey solutions in a short amount of times, not requiring the overhead that you've either been exposed to or have been maybe burned on in the past. Going through the Digital Transformation University, very important. You have a partner that can expose the black box through documentation, technical workshops, tutorial videos, so exposing the schema of what, how, and why AI and machine learning can generate tremendous value to the organization. Always really important to note that you want to have good first principles. So depending on where you are in the journey or how advanced you are in the supply chain, a lot of your time scale and your decision makings when using AI to improve energy can be done on any of these levels. So whether you want to start small or you want to start at the enterprise level, it can definitely be done. Just depends on how you manage expectations and how you set success. And then focusing on the fact that we want to become more efficient with root cause analysis and being much more data driven as opposed to model driven on using these techniques made available to the industry to ultimately become and to explain our results and in terms of production and the improvement to production and energy much more efficiently. There's definitely something I feel the industry doesn't pay attention to is when you are trying to build this or you're trying to buy this, you really want to understand the importance of the edge in terms of the data source that represents your energy problem, consumption problem, versus the actual engine, the black box, that's going to generate the improvements and the process improvements that you need in real time. So the steps between the two buckets need to be reliable in terms of how the data is collected, processed, transmitted, secured. So having all your firewall rules in place, in addition to the feed forward technology, and in addition to the payloads of that data, you want to be efficient, and you definitely also want to keep into consideration the cost of your data science or data center storage cost, in addition to the bandwidth or whatever cellular WAN schemas you guys have set up. So really important that your solution gives you access to connectors and to protocols that allow you to get data from any sensor, any of your level 2, level 3 systems or your enterprise systems, automatically automating all those entire ETL functions. Grounded truth is really important in terms of what does our life look like today without AI and machine learning, and do we have that understanding of what is normal, both logically and mathematically. Very important that everyone understands the process and the problem as a team from a steering committee, and then you can you'll have a greater respect or appreciation for the insights AI can derive for you. And we always want to keep into consideration, if our focus is to empower SMEs and to empower the domain expert, we want to make sure that their constraints are also built in or else defined prior to the modeling process. And a lot of the steps that are being automated for the user are around, your principal component analysis, your dimensionality reduction, the p-value techniques, how you ensemble that, how you post-process, and be able to nicely see the interpretation of your model after it's done training on the data. And then to understand that you are generating, from an energy reduction point of view, you are able to generate optimized process parameters and thresholds, and you're actually able to reinforce a smarter dynamic set point that if you're trying to reduce energy, that's ultimately your goal, is to whatever's happening in real time with that set point, where you set your system to versus how it's behaving mechanically, the PV being read and measured. What's the difference between the two? The error, and be able to calculate that and reduce the oscillation and overshooting in your control process is essentially our goal, and how customers are using Sorba AI to reduce energy. And basically taking this information, bypassing the PID in your control layer, or making it that much more intelligent. Always want to be able to quickly identify what is our optimization goal here. Do we have enough equipment and instrumentation in place? And then what is my independent variable? So if you control, you know, these valves or these particular data points, you're actually going to cause your system to consume more energy than you originally intended. So you don't want to do that. So this is also very important steps that we go through from a framework perspective. And then lastly, what can I control, what I cannot control, and what I can control. And then going through the black box where I'll show you what this configuration process will look like. But after you logically define that, you'll go through some of these steps. And then what is a digital twin means a lot of things to a lot of people, but it's essentially for us, what it means is essentially a neuron or neural networks of these multi-regressions generating all of these predicted outputs being fed into one another to achieve a much more optimal and much smarter decision when it comes to control. And then knowing that you have access to a digital twin pipeline can actually allow you to maybe do better simulation efforts, or allow you to clean the data better, or allow you to test good models you have running in production versus different events, different step changes in your process, different data that represents different scenarios, that if you had this sensitivity or an ability to study this much more frequently, you know, who knows how much better your control, your AI control could be, with the goal of reducing energy. Lastly, we want to also take into consideration us being able to be ethical and transparent, and to know that if for whatever reason our AI APC is not behaving correctly, you know, from an author or a source code perspective, you should have the heartbeats, you know, your watchdogs in place to make sure that for whatever reason, AI is always going to be abiding within the constraints you tell it to abide in. So very, very important. And you know, as you're going down the journey, we always want to think about the less noise. You know, the more we can show value on smaller data sets with the less noise, then we can think of this as almost like a version 0.01 concept, where you are letting the algorithm learn and become, you know, you're rewarding it, and you're allowing him to mature and grow over time. And the p-value for us, you know, especially when it comes to reducing energy, is what are the data points or tags that have the highest contribution to a failure, or have the highest relationship to one another in terms of, if you're trying to get more efficient with energy, you should really focus on this subset of data points. So it's going to allow you to eliminate your noise really, really quickly. And a lot of the interpretation of Sorba, which will show you what this process will look like closed loop in real time, will always be able to tell you in the data what your room for improvement is based on how you're controlling equipment today. And that is essentially that simple, where these data science techniques and these scores that are traditionally scripted or have to be scripted by hand or manually is being generated for the industry automatically. So you can see here in the blue, Sorba is saying if you were to stay within these constraints and using this set point, we would have reduced all these events in time. And I don't know what these engineering units represent, but these are my optimal upper and lower limit bounds. And then I've got a set point in here that's my chimney set point, is always staying within these bounds, generating that 7% savings or that 7% reduction. These are all of your non-optimal states and points in time, and eliminating that is where we're going to start to see the biggest economies of scale take place. And when you look at this, your processes, which is obviously multi-dimensional, I'm showing you things non-linear, on a non-linear basis, but with life with APC enabled, as you can see, your fuel consumption is much more ideal, as opposed to it being disabled and not being ideal. Now we want to be able to map all of this decision making, all this configuration to your process in real time, and what would this look like if you were driving. We'll show you that in a little bit. And some things to keep into consideration around doing this for quite some time and seeing where customers struggle most is around the data integration, massaging the data, having enough data, maybe not having the right person for the process seated at the table, asking the right questions, and then not trusting AI and not having good validation techniques or tools and steps in place to scale these solutions. So now what I'm going to share with you guys is what this journey would look like if you were to be driving. So everything starts with the edge. Like we mentioned, we are a hybrid company where we have no constraints on computing. This is the edge where you are going to define your data pipelines, your edge that we talked about. So in your channel, you're going to come here and you're going to have access to any of the drivers, whether you're talking to your process historian, your PLC, some of your data servers, or you're wanting to get weather data, you're wanting to talk to your building automation systems. There are no constraints, and there's never been something that Sorba cannot talk to for AI, machine learning, and analytical applications to be built. And then on the edge, we're not going to talk about these other features. We're going to quickly get into how you guys would model your process. Here, your data, once you import into the platform, Sorba will automatically calculate and generate some of these techniques for you. But now it's come down to creating a project. So what we're going to do is we're going to call this ENERGY4.0. Here's what I call the app store that you guys would have access to create your model. Once your data is done being imported into the platform, so I'll come here, create an analysis. Here are all of my data points or my tags that represent my process that I'm trying to be more efficient and be more sustainable on. If I want to add constraints, I can, but I don't want to. I'm going to select next. Now this is where we have access to your pipelines that we were talking about. So these two are typically used for your asset health applications, which I'll show you in a jiffy. Regression and digital twins, you're trying to generate what is that error score within my process, and then lastly optimize. And I actually want to be able to reinforce that decision in real time. And then forecasting, you want to be able to maybe optimize different MES KPIs or anticipate different things upstream or downstream to make your actual volume and performance that much more better. And if you do, and what's cool about Sorba and what we feel is a cutting edge and really an emerging technology industry is, for us and our users, you don't need to know any of these techniques. They're done automatically for you. But if you do, you can select them. If you don't, which majority of our users do, you let auto select and Sorba will select for you based on the data, variety, volume, velocity, and there's another V I'm not remembering, but it'll do it for you. It'll select it for you. But optimization, this is specifically used for energy reduction. I would select what I want to reduce, fuel flow, minimize it, select my independent variable. We talked about how you define that, et cetera, et cetera. Select next, select next. Once this model is done training, then once you map it back to the algorithm, your optimization model will look something very similar to this. Oops, right here, boom. So now I have my boiler represented. My APC, my advanced process control algorithm is not enabled, but I want to enable him. So let's enable him. Let's see, and then you can see I'm not doing very good in terms of my fuel consumption, but let's give it a chance to optimize. Hit the refresh rate, so you kind of see here on a time scale, my process just went up a little bit. You can start to see the monies are starting to be gained and summed, and all of my those dynamic set points I was mentioning to you are staying within these optimal bounds with the goal of reducing fuel and generating enough steam and power for the rest of the facility. So this is something that can definitely be done without writing any code. That is being done by lots of our users around the world. And we're just really excited and really fortunate to share this with you and look forward to talking about how Sorba AI can help you along your energy reduction and energy digital transformation journey. Thank you.
Then let's get started. This is a panel discussion, with three exciting people to talk to. And the topic is AI and machine learning to shape the future of energy. Okay, so we're going to discuss how AI and ML will shape this field, which of course is subject to a lot of change, especially given the advent of renewables. But that's not the only thing we're going to talk about. And I'm excited to learn which applications you see are at the forefront and most important in these developments, the requirements to make it work, the caveats maybe as well, and your visions of where this is going to go. So with me is Dr. Roberto Samuel, who is Chief Technical Advisor at Halliburton. We also have Patrick Bangert from Samsung SDSA, who's there as the Vice President of AI, and Sebastian Brandt, Senior Key Expert for Knowledge Graph and Data Management at Siemens, my very own company. So nice to have you here. And I want to get right into it, actually, and talk about a very specific application of AI. Because, of course, I reached out to all of you ahead of time, asked a little bit about your ideas. And one thing that really stuck out to me was, Patrick, you saying that you actually see predictive maintenance as kind of the main and most talked about application in artificial intelligence, which even though, of course, it's a massively important application field of AI, it still kind of surprised me. So as well as telling us a little bit about where you think we are in this development, actually bringing predictive maintenance, these ideas, into applications in energy, I would also like for you to explain where you see this going and what you think the impact could be if predictive maintenance was really implemented to the extent that you see possible today.
Thank you for that good question. Every part of the energy industry, whether we're talking oil and gas or electricity generation or renewable energies, all of these sectors of the energy industry are asset heavy, in the sense that the primary financial expenditure is on equipment of some kind. And that's why predictive maintenance, when will this equipment fail? When will I have to maintain it? When will I have to put spare parts in the field and replace them? That is actually the major component of the operational cost of running any of these kinds of facilities. And so forecasting when that might be needed is something that the various C-level officers have been discussing in public forums for a number of years now. I would say almost 10 years. This has been a topic of discussion. And if you look at the scientific literature, there have been countless papers written by both university and industry researchers on those topics. However, very few companies have actually deployed any kind of real operational software that makes it happen. And so this disconnect between us technology people effectively having solved the problem, but the industry leaders talking about it but not deploying it, is a very, very interesting conundrum. There are many, many theories on why that loop doesn't close, but it is a very curious situation. From a technology point of view, predictive maintenance can deliver on the dual promise of, first of all, correctly forecasting events that are going to take place in the macroscopic future, not just 2 milliseconds from now, but several days from now, giving sufficient time to actually do something about that. And the second aspect being that this is economically relevant because you will be preventing the failure itself. You will have to repair the fault, of course, but you will be preventing entirely the collateral damage on other pieces of equipment that are fine. And what you will be preventing is all the environmental and personnel damage that might result. So if it's an oil and gas thing, you're talking about a leakage to the environment. If you're talking about a processing plant, you might get damage to people involved. All of that will be entirely prevented. So it's quite relevant. So that's the situation at the moment.
Gotcha. That's, I think, a really interesting perspective, because of course when we think of energy from maybe the perspectives that actually impact us, especially as consumers, we do not really realize that, of course, this asset heavy aspect that you described. Now, if we think this through, right, how much negative impact could actually be avoided? And this is a question to you, Robello. You think could actually be avoided if we had predictive maintenance in place? I mean, we're seeing spikes in energy prices, and I know this is, of course, especially also often due to the transitions to renewables these days, and more macro, or we only talk about the macroscopic effects on the grid and having to rely on intermittent energy sources, but could there also be something done, for example, as we see now in the UK with massive spikes in energy? Would there be a positive contribution to be expected also from predictive maintenance being applied, or is that unrelated?
Yes, indeed. I can talk very specific to upstream and more concentrated topic on drilling. Right? As we drill, we need to have some form of a predictive maintenance, right? At least, so now we get a lot of data, and in the past we have used basic assimilation of data. Now with all the digital transformation, we can get in real time what is happening, then can we stop? Now, that's what now one of the projects we are doing is leak stop. Can we predict some leakage and stop ahead of time? So it has additional ESG effects, right? So the emission, the impacts of the carbon, all these things. So now the second point is, can we quantify it? So when it comes to the quantification, we have to use all the digital levers, and more recently all the artificial intelligence, AI, ML, all these things, so that we have a better understanding rather than earlier very subjective picture. Now we are moving towards quantitatively estimating it in such a way that we can diagnostic, not only just find out the faults, but also stop ahead of time and mitigate the impacts. So definitely, yes. So it is now getting more into that space of tying the renewable energy as we transition.
And Robello, actually, beyond this, so I mean, this is what is exciting about having you on this panel, right? Because your applications that you're concerned with are really often down to the real-time aspects of employing AI. So beyond the predictive maintenance aspects, which I guess always are mixed within this, when you look at your data, maintenance events are one of the key things you want to predict or ideally prevent, even if it's possible. But what are maybe other perspectives? And I know you're also covering this in your keynote, but what are some other aspects of AI applications in the drilling domain specifically that you're excited about in terms of maybe control optimization or otherwise?
Yeah, so now exactly you said control optimization, right? So now we are moving towards automation. So for automation, we need to have prior to that optimization. So we need to have an optimization in a holistic way so that we can give the set points to the auto driller, or in another sense of automating the machines. So speaking of now, we have completely automated a rig that can take away all the people there. But at least the people are outside and watching what is going to happen. In case of emergency, they can jump and take control of the machines. So definitely artificial intelligence is just infused with the data that are being pipelined. that is more in real time. You need to have real-time optimization that can be used for controlling the machines. So now my question is, can we plagiarize a driller who is doing presently controlling the machines, right? Can we plagiarize his brain? Then once we reach a, probably we may not, right? But at least to some extent, then I can partially make him to do other jobs rather than sitting on a routine job, even though he is doing it in real time. So that's, I think we are moving slowly towards that level of artificial intelligence. Can machine be trained to do everything autonomously? Probably not, because we don't have complete details what is happening down hole. Still, the data is unknown. Our well is unknown. So we have to deal with all this uncertainty. We are not dealing with a Walmart supply chain automation. It is a completely a non-Gaussian, highly stochastic oscillatory system. So it is complex, but definitely we are moving towards that direction.
And I think now we've heard about some of the exciting prospects of what AI has to offer, right? But you also, Patrick, already gave an impression, a bit of a teaser of there's many aspects of why this is sometimes not happening as definitely not as fast, sometimes even hitting some hard roadblocks with regards to just feasibility, right? Or things just not coming into place. And of course, this all in the end usually comes down to data, right? In all its dimensions, availability, sometimes privacy aspects, data not being there in the structure that you want, not being connected in the way that you want. And this, of course, is your field of expertise, Sebastian, right? So you seeing all these, ambitions also, of course, within and even outside of Siemens, how do you apply your technologies, right, which are all about data management, data integration, and also knowledge graphs, to name up something that is, a bit more elaborate. How do you apply these in order to, really build the foundation on which smart applications like the ones you just heard about can then be built?
In the first place, I need to say I felt so at home with the statements of both other speakers, actually, what Patrick reported about the solution being out there to deal with predicting outages and problems and doing something about it, but the uptake being really difficult. So I'm so at home with this kind of situation. And we have been dealing with, for instance, with gas turbines, like expensive equipment where downtime is measured in terms of seconds, because it's really, really, really important that these devices are running. And there, a lot of data is being collected. These things have 2,500 sensors. They send this stuff at times on a microsecond grid. But even relatively straightforward questions like, what happened to the life of this one turbine blade throughout its lifetime, from it being created, being deployed in site A, then taken out, repaired to the different machine and everything. Even piecing together this kind of stuff is really difficult, because it involves getting your head around time series data, structural knowledge, and also all sorts of stuff that gets documented somewhere around the life cycle of the equipment. And so I'm totally feeling the pain there as well. And what we do in order to try to improve the situation is create these graph structures where it's really easy to bring in some new piece of the puzzle without having a master data management project that runs for 10 years before you get frustrated and do something else. So for these gas turbines, we've been able to just create these webs much more quickly that allow you to trace what is going on, what is it that we can recommend to somebody. And there's one important thing though, and I would imagine that Patrick has probably bumped into this as well. you also need somebody to take responsibility for whatever the consequence of your prediction is going to be. This is also something that I've been experiencing a lot in the life sciences domain. So you can create your system and you can make it do great predictions in your organization, in the day-to-day running of things. You need somebody who either says, we've been testing your system, it's good, we can act upon it quickly, or you need somebody to take responsibility. And this is something that sometimes makes it more difficult to get these changes implemented. I guess that's all I want to say just right now.
Yeah, so actually, Patrick, I assume, yes, you have stumbled about this, just like also Rubello has probably. So what can organizations do in order to take care of this, right? We just heard about the term, or the idea of responsibility, right? Is it really just one person who should kind of have this role, like, I don't know, chief data officer or something like this? Or is there really more to it in order to get organizations, well, fit for this new generation of data-driven applications?
Unfortunately, there's a lot more to it than that, I think. So in practice, I actually find that this aspect is the #1 cause for failure for digital projects. It actually very rarely, in my experience, has anything to do with data or technology or AI or software. 9 out of 10 projects fail because of organizational managerial issues. And I see two issues as being the primary. One is called change management, and the other one is budget, quite simply. Change management refers to the fact that the projects are typically done by a small team of experts, data science experts, as well as domain experts working together, with the exclusion of the operational people that are the usually so-called users. The users are ignored, and at the point where the project is completely finished, it's being put in front of the user group, and the tenor of the conversation is like, guess what, you guys are so lucky. We are bringing this wonderful technology to you. You should kiss our feet and thank us and implement this immediately. The response of the user group is, you guys are out of your mind. You've developed a technology that is largely irrelevant to us because it doesn't fit into our daily work schedule. And thank you for never asking what that daily work looks like. It actually needs to have a button that does this, and it needs to have a diagram that looks like that. And by the way, I know better than you anyway, and you're not going to solve the problem. That's change management gone wrong, and that's 9 out of 10 projects out there. So that's the main aspect, I think, is to have somebody in charge of the project who is able to include everyone in the conversation very early on to make sure that everybody is on board. And this is actually a very, very complex task. The second aspect has to do with budget. Many people at the decision-making level have the impression, the gut feeling, that artificial intelligence is automatic. Right? You put data into this thing, Python thing, right? That, and out comes the model. And it's more or less immediate and more or less automatic because my mobile phone books flights and I can talk to Siri. And getting the understanding across that you might be talking about a year-long project with 10 people on the team, and then you need to do change management for which you need 5 more people on the team and another 6 months. And then you need to develop interfaces and so on. And all this costs money. That's very difficult to get across. So when management says, do an AI project, and you say, I need $10 million to do it, there's a disconnect. In my experience, those two are the issues that prevent successful projects.
So you said that this applies generally to all digital projects, right? And then, however, there's, I think, of course, some added dimensions of complexity when we talk about data-driven applications, because it's, of course, still about the user, right? But the user is also, and that is sometimes actually different in other digital applications, the one who has to provide the initial resource, right, which is the data, to build this application in the first place, right? So you have to start actually this iterative process very much from the beginning. And this is also something that we running an innovation lab at Siemens have a lot of experience with, or I mean, have experienced quite a lot. So I would like to hear from Rubello, actually, you, given that, you know, you are not so much taking the perspectives that we might be taking of being a service provider, you know, catering to many different domains, but you have the luxury, for better or worse, being able to apply these technologies to your domain specifically, right, the drilling domain. So maybe you can also give some examples of how you have been able to overcome such challenges for your domain specifically, and made it possible to also then, you know, take these learnings and maybe scale them up to future projects, if you know what I mean.
Yeah, I agree with what Patrick said. We had the same problem. And digital officers, digital data science group was formed without any domain expertise. Domain experts were busy in developing engineering models. Then we had the difficulty. So it is not just using all the data as use some glorified regressional models to come up and a predictive estimate. It didn't work. So these are all academic exercise, very good for paper publications and the new approach, all these things. But it was not, they were not scalable, deployable. So ultimately, business value could not be recognized. Then it took time to realize. Then domain expertise were infused and combined with the domain experts. And now domain experts are trained to do all these data science related things. So that makes more intelligent enough to predict, because the domain experts know what it is needed and what is the use cases that can be used, and eventually we can monetize. So that was slowly now down the years, it has been learned. Now we go through some sort of a gray box model, combining the black box and the engineering models, which I call, instead of artificial intelligence, we call artificial engineering intelligence. So we have engineering models in the form of microservices that can be called on demand at any time, so that we have a global optimization that seek for the best optimal solution. So that was acceptable to our clients, and that is a unique proposition. The way that it was approached, all these models were purely, okay, give me some 100 wells, 200 wells, I will predict whether you have some problems. Now it is like, okay, I want to check the health of your body and tell, bring all your clan and your forefathers' medical report, then I will tell you. That doesn't work. Because each and every well we drill, even though the design is same, they are completely different. So we learn to live with an existing data, so the clients are happy. And now we are slowly in the path of monetizing this in the form of small apps that you can use it. So we had all these problems initially, as Patrick alluded to, but we are breaking the silos and combining engineering, physics, and uncertainty. Still, we have a lot of uncertainties, so we have to suppress them. So we provide the solution in the form of a probabilistic estimation. So that is translatable. So now we are realizing and monetizing and moving all the calculations to the edge, very close to the rig, from the office to the rig, and also cloud. So these are all combined much more in a usable manner.
Artificial engineering intelligence. Yeah, I like it, and that seems like within that domain, like quite a impressive step towards generalizing across that domain. Sebastian, now from the data management perspective, what can be done to achieve maybe these? I mean, because you're seeing very varying domains, right? Not just energy, but from mobility to healthcare. What can be done from a data management perspective? Are there any tools, anything that allows us to build a foundation to at least scale up some parts of this process, which is probably, as I understand, going to be a solution business for the foreseeable future. At least everything will have to be done specific to a given customer, to a given domain. But what can we sort of modularize still out of these processes in this process of making data available and integrated?
Big question, but I have experience working with Statoil in an EU project where their domain was also drilling oil wells, and what did make a real difference for them, at least in the area that I had insight into, was not so much even more sophisticated statistical models or something like this, but rather being able to combine more data and knowing what it meant. So in terms of, they were dealing about properties of layers of the ground under the North Sea somehow. But although the data was there previously, what we did is we created these semantically rich graphs that would actually tell you in one way that you have a structural view of the world, and sort of directly connected to this structural view, you have access to time series data that might give you more insights into what's actually happening. And the difference it made was that the heuristic process to actually combine different types of data in order to make robust predictions about something was much easier than before, because you could basically think in this terms of structural view of the world and have the numbers to back up your hypothesis. There, I guess it was more ability to come to hypothesis testing more quickly than you would have been with just long lists of tables with numbers in them. And I think in general, what is plaguing the data analytics world a little bit is that they have this kind of artisan approach to things. You bring your data, you explain this to these highly paid, highly sought after data scientists, and then they go away and hack their Python scripts until tables get replaced by other tables, and these by even different tables, until you probably still know what that was in the first place, in the best case. And then you train your models to come out here with your results, show them to someone, then everybody nods. And to some extent, like Patrick has already explained, that very little happens from there. And I find it really cool what Rubello explained in terms of building these microservices that you can call at any time, get some results out of this. This is really a move in the right direction. And my feeling is that the main one of the main ingredients into making this happen is having an infrastructure that allows me to quickly get access to different views of my world, be it time series data, structural things, anything that can be placed along the product life cycle somehow. But in terms of technologies, we need to get out of this artisan approach. Like, I'm making this model and I'm showing it to you, and you think, oh yeah, that's really cool, and then we both go home and the day-to-day drudgery starts all over again.
Yeah, it makes sense. And now that we've talked a bit about more of the structural aspects and how to make it a reality, I would like to get a little bit back to possible applications, because I think there's still a lot to be discussed there, and take a look at the regime of renewables, right? So actually, because we've not really covered this yet, Patrick, completely different domain. Do you see any applications for renewables, kind of in the same vein, of course, beyond what we talked about with predictive maintenance, also like wind or solar, right? What could be done there? Not yet considering the entire grid, right? But for these applications in and of themselves.
Oh, of course. So there are quite a few application areas. So of course, part of the problem of wind and solar is the wind doesn't always blow, the sun doesn't always shine. So having a weather forecast is absolutely crucial. And that weather forecast has to apply to the extremely specific location that your solar panel or your wind turbine is at, right? And you would want to know wind speeds, you would want to know solar irradiances. For example, the solar panel could be mounted on a rig that can be tilted and rotated so that the solar panel is always at the optimal angle relative to where the sun is at. That's a bit of a careful calculation, of course, because that in itself costs money and consumes electricity. So, is that going to be economical? Question right there. Then predictive maintenance for that is, of course, also relevant. The other thing is that for wind power plants are typically arranged in a grid, at least the offshore ones. You have several rows of wind turbines. So depending on where the wind is coming from, not only do you need to rotate the entire head, the rotor of the wind power plant into the wind, but you also need to take account of the fact that the first row into the wind is going to get the majority of the power. The second row will get less. And the third row will get less than that. Now, the rotor is actually a fairly complex piece of equipment. It doesn't just sit there and wait for some wind to blow and then you get electricity. There are set points in that process, and it was previously mentioned that there is a real-time optimization algorithm that adjusts set points to the situation. Well, the same thing applies here. You need to change the set points that govern the operation of the wind power turbine to the wind that's actually available to it at that moment, so that it can optimally produce electricity. Now, all those aspects are artificial intelligence that allow all this to function properly. And then ultimately the electricity will need to be transported from the wind turbine to some kind of an aggregation location, right? If it's offshore, it'll be many kilometers of cabling to get it onshore, and then get it transformed down to a different voltage. And again, those transformer stations are governed by some kind of control system that will have its own set points that will need to be adjusted in real time. So you're looking at a lot of technological aspects. Now you asked me not to go into the grid. The grid has a bunch more degrees of freedom beyond all that. So there's definitely a lot of application areas for artificial intelligence algorithms. In a nutshell, it's around forecasting time series, automating set points, and then of course classification problems according to which category are you in terms of either maintenance or making adjustments.
Right. And with that being said, though, let us actually think about the grid as an entirety, right? Because the idea of the smart grid, right, and all these moving parts, right? That you could think about from an innovation perspective. I do get quite excited thinking about all these moving parts, right? Having storage as well as intermittent energy sources, which are becoming more because actually all renewables kind of demand this, and additionally being able to have demand management really down to the very to the consumer stage. Also, some people speak of having actually more localized energy demand being met, right, through localized energy systems. So Sebastian, actually, can you give a bit of an outlook on where you see this going from this entire perspective of the grid, and what a vision could be maybe for the next 10 years, and where you see the biggest room for optimization?
Seeing other domains where technologies like we deal with are more often used, my feeling is that the main perspective, at least I would like to take, is not to try to solve the most clever problems first, but start by solving those problems that increase the efficiency, the dull things that get in the way of analyzing data in a more meaningful way, to form a plan of what to do. I've seen this in the healthcare domain quite a bit, but to some extent this also applies to those energy projects that I'm aware of. Is the biggest amplifiers in terms of productivity come from taking away the dull work, the loss of data, the lack of situational awareness of what's happening in my with respect to my equipment overall, which might also include something what Patrick mentioned, weather data. How does the weather affect my installations depending on where in the world they are situated? For instance, if I have a solar panel in the desert, then sunshine is a good thing, but it also heats up my solar panel. So maybe I'm not so happy about it in the first place. While if this thing is somewhere in I don't know, the north of Sweden, it's really great. I can let it run without having to worry about equipment temperature and stuff like this. So this kind of complete picture, this is something where I think in this I see a foundation to form new plans, have new ways of combining data and using the analysis to improve equipment in a way that is not possible so far. But I've seen this for long years actually in the life sciences. I would not start by trying to solve the most ambitious, interesting, mathematically challenging problems first, but rather having a uniform view of my equipment, my data, what's happening, and the goals I'm trying to solve, and then go from there.
Robello, do you agree with this? So is this how we should see it? From go with the small problems first, or do we need the bird's eye view at some point?
I think we need to have a bird's eye view now. Wind does not blow all the time, sun does not shine all the time, but the earth is always hot. So it is getting hot and hotter, right? So it's now, can we use the geothermal energy, right, as we transition? So now we are trying to use artificial intelligence. Now all the wells that are drilled around the world are very, very basic. With all the technology advancements in the horizontal drilling, shale fracking, can we migrate in such a way that we can intelligently drill geothermal wells so that we can maximize the energy production with the minimum cost? So that's one area. Then the other one is a lot of abandoned wells, dry wells. Can we retrofit using artificial intelligence and engineering intelligence to extract energy with the least amount of effort put into that. So now, back to your question, parenthetically, if I put it, that's what we are looking at, a bird's eye view, what is going to happen, because it's not going to transition from wood energy to coal energy overnight. But it may be very fast from oil-based economy to the gas-based economy, then moving to more renewables, all these things. But in that meanwhile, we need to have some soft coupling, slowly transition. So already we are seeing artificial intelligence and the data, AI, ML is spilling over to geothermal, more specifically. Geothermal drilling, that is the way that we need to take a look at it. Then probably we can focus how to maximize, infuse all of the things into that area. Now, I think it's overall, it is, everybody is looking at a bird's eye view. Right? What is the environmental pressure, cost pressure, and technological pressure? Three pressures we have to go through, especially on the oil and gas industry. So we are trying to balance all these three things and satisfy these three things so that we are not far away from the sustainability.
Right. Take you into account, and then yeah, actually, also back to you, Patrick. Also, it says in your bio that you feel that AI is supposed to serve more than solving, the mundane tasks and automating the mundane tasks of humanity, of the individual, right? But then again, we see that you said it yourself. Biggest demand is in stuff like predictive maintenance, which is quite local. It's a very local problem to that asset we're talking about. So now, having asked the other two, do you see the possibility or even the necessity of looking at a highly complex optimization problem that kind of encompasses the entire grid? And if you feel it's necessary and possible, where would the next steps have to come from, also maybe in terms of legislation, in order to make it possible to look at the grid at such a universal scale?
Are you asking me?
Yeah, Patrick, sorry, I am. Yeah.
Okay, sorry. Yeah, so the whole grid is of course a very complex system. Often it's being compared to a lake into which some rivers feed. Those are the producers of power, and some people take water out. The analogy breaks down at the point that this has to happen concurrently, right? The lake is not always filled with some stuff that you can take out. So the production of electricity and the consumption of electricity have to happen simultaneously. And if at any one point there is more electricity made than used, there's a problem, but it's not that big of a problem because you can burn it off somewhere. If, however, at any one moment in time there is more demand than there is supply in the grid, then the grid breaks down. And because of the intermittency of things like solar and wind, that has happened much more frequently in recent years than prior to that. Most consumers don't feel it because those grid instabilities are happening on a very short time scale, milliseconds, which you don't feel if you run a light bulb at home. But industrial applications do feel it and are impacted by that. And the chances are that going forward in the next years, we will see more and more grid failures happen also at more macroscopic timescales, which will impact the general population as well as the industrial users. So the critical piece here is what's called a load balancer. That is a governmental agency that looks after how much demand and how much production there is and tries to balance them together. And that means that this agency needs to have legislative power or command authority over the producers, telling them to produce less and produce more, usually on a 15-minute increment. Now, in Europe, for example, the problem is that the grid is international, and all of Europe is covered by a single grid. So in order to effectively operate the entire grid, you would need a supranational body doing that. In North America, it's different. Within the United States, there are several grids which are essentially independent. They can be locally ruled. But in the United States, you have the problem of having several states, right? So it now needs to be a super state agency, which again has these political issues. Artificial intelligence can help in the sense that it could be a load balancing algorithm instead of a load balancing team of people. The issue there is, of course, as you mentioned, legislation. You would need to have multiple governments or multiple state governments agree that this particular algorithm is going to handle the situation, and that means building of trust, which is very difficult, and then of course also legislating liability. What happens when that algorithm invariably at some point makes an error? Who will pay for the damages? Or, will there be a team to kind of back up the algorithm in case the algorithm goes in the wrong way? Will the team have the authority to stop the algorithm and reassume human control? Very difficult problem right there. Another aspect are the finances. Every contributor to the grid expects to be paid for the electricity they contribute. Now, 20 years ago, there were only very few contributors, all the power plants, essentially, which were owned by a limited number of corporations. So the government or the grid operator could negotiate with 30, 40 players, and that's it. Nowadays, I can put solar panels on the roof of my house, which make me an electricity contributor to the grid, but is the grid going to negotiate a compensation contract with me, having like 2 square meters of solar panel on my roof? Well, no, that makes it complex. And now we really have tens of thousands of producers, making the economics much, much more complicated. And I, as a person, can't, go to the spot market and negotiate 15-minute increment contracts. It's unrealistic. Which brings into topic certain constellations where many producers become an aggregate, what's called a virtual power plant. Many individuals being considered as one entity together. That means they have to agree. So there's a lot of legal work going on to make this happen financially. As we've seen in recent times, especially in the United Kingdom, where the price that consumers are prepared to pay for their electricity might in fact be lower than the production cost of that electricity, being further exacerbated by certain laws that have been passed that limit costs and charges, makes it a very complex system. And again, artificial intelligence could negotiate a lot of this. You could bring into play blockchain and other algorithm, methodologies that have nothing to do with AI, but that help in terms of intelligent contracting, that would enable you to make a contract with tens of thousands of counterparties. So I think AI has a long way to go, especially in the building of trust towards politicians and legislators and the general public, to help them negotiate this very complex landscape.
Gotcha. So maybe to summarize, the dream of having this AI control, full view of the grid is maybe not even technologically feasible, but most of all, actually, we should really break it down to focusing AI on the, smaller problems that we can focus on, both from technology, but also from actually a point of legislation, right, and availability. That makes sense. I think we are almost at the end of the time. We started a little late, so if we do have time, and all of you have time for actually one last question that I would have to Robello, I would go ahead, but only if that works.
I do have a meeting now somewhere else.
Okay. I did still want to ask one question regarding the aspect of talent.
The Clean Resource Innovation Network, CRIN for short, is a Canadian initiative founded with the purpose of enabling cleaner energy development by commercializing and adopting technologies for the oil and gas industry that reduce environmental impact across the energy sector. To achieve this goal, CRIN is focused on 7 theme areas. By sharing expertise and knowledge across a range of sectors and focusing on the theme areas that will have the largest impact on the environment, CRIN is committed to making progress on many environmental challenges, including one of the most pressing, climate change. Sharing ideas from across the network will be focused on identifying key challenges or solutions that will have the greatest impact on improving the oil and gas industry's environmental performance. And that's CRIN's foundation: diverse collaborative members, a shared passion for innovation, and the common goal of leading the global transformation to a cleaner energy future. To support CRIN's clean energy goals, the Canadian government, through innovation, science, and economic development, has invested $100 million over 4 years to enable CRIN to execute 3 large-scale technology competitions for high-impact projects with clear paths to commercialization. Innovators and clean tech companies from around the world are encouraged to bring their ideas, energy, and spirit to CRIN. Join CRIN today to stay up to date on upcoming technology competitions and events. Collaborate with diverse people in like-minded communities. Connect with other sectors and people working across the network to see how you can help each other. For more information about CRIN and to register for our no-cost membership, visit cleanresourceinnovation.com. Welcome to the network.
Canada is made up of over 5,000 communities. These communities account for 61% of energy use and more than half of all greenhouse gas emissions in Canada. Herein lies an opportunity. Let's make our communities into smart energy communities. In so doing, improve energy efficiency, cut costs, and reduce greenhouse gas emissions. So what does a smart energy community look like? First, conventional energy networks get integrated. That means that the electricity, natural gas, district energy, and transportation fuel networks in a community are better coordinated to match energy needs with the most efficient energy source. When conventional energy networks are integrated, it opens the door to innovations like alternative fuel vehicles, energy storage, waste heat capture, and combined heat and power. Second, a smart energy community considers land use, recognizing that poor land use decisions can equal a whole lot of energy waste. Third, a smart energy community harnesses local energy opportunities. These can be stock opportunities like solar, wind, and geothermal, or they can be opportunities that are tailored to a community, like water source cooling, sewage heat capture, biomass for heating, and capturing biogases for electricity and transportation fuel. Every community will have its own unique mix of local energy opportunities. Together, they can achieve significant energy efficiency improvements. Integrating conventional energy networks, making smart land use decisions, harnessing local energy opportunities. Quest, advancing smart energy communities in Canada.
I envision for the heavy oil and oil sands sector that we are going to be a key role for Alberta, for Canada, and for the globe for many decades to come.
Hi, you're watching Global Energy Show's 5x5 series. I'm Rachel Gregory. Joining us today is Carolyn Bennett, CSO and Executive Vice President of GLJ. Carolyn, thank you so much for joining us today.
Oh, thrilled to be here, Rachel. It's going to be fun.
Carolyn, you are part of the top 275 female influencers in energy and have been named Outstanding Role Model for Women in our industry. Congratulations. So with that, how did you become involved with CHOA and how does it feel to be a role model for women in the industry?
You know, the industry, we're really at a crazy pivotal time. So when I think of that, I get really excited and I get really energized and I get really determined. And I really want to make a difference for industry and really roll up my sleeves and do my part. I'm a big believer. I envision for the heavy oil and oil sands sector that we are going to be a key role for Alberta, for Canada, and for the globe for many decades to come. So to me, I'm super passionate about working to reset or morph, I think, the narratives, which are often misleading around our industry. It's also really important to me to be reaching out to that incoming generation and really attracting those young, bright minds to our industry because we're going to need them to break new trail for us. I am tremendously passionate also about our existing workforce. And as a group, we are innovative, we're resilient, and I think we're highly skilled. If Canada was to leave us behind, well, it would just be a massive loss and really, I think, make the whole energy transition just that much more difficult for us to achieve as a society.
Can you tell us more about the Canadian Heavy Oil Association? Who are your members and what is it that you do?
The CHOA, we exist to strengthen the Canadian energy sector and to accelerate the careers of our members. And we do that by providing members, industry, and the general public with technical, social, and educational programs that are all intended and designed to expand their knowledge, their relationships, and their influence in the heavy oil and the oil sands community. And our vision is for Canada to be the most responsible and the most innovative energy resource developer in the world. So when it comes to our membership, we're technical at our core, geoscientists and engineers, but it doesn't stop there. We really cut across entire organizations. So as an organization, we're doers and we create things. And we're really known for sharing successes and failures, so lesson learned to the benefit of industry.
Over the last 30 years, how have you seen the CHOA change with the energy industry?
Our problem set and our themes have progressed. They've morphed like over the last 35 years. And today, what we're focused on is our sustainability and ESG. We're focused on technology and innovation, and we're focused on digitalization and future skills for our members and for industry.
At the Global Energy Show, the CHOA Theater is hosting experts over the 3 days of the event. Can you tell us more about what visitors can expect to take away from these presentations?
Our theater is really geared to 3 takeaways. And the first one is really to elevate awareness. We want to elevate awareness with respect to Canada's energy sector, our commitment to society, and the role that heavy oil and oil sands has to play. And the second is that we want to provide examples of how we're transforming, whether that's technology development, clean tech, IoT, or sustainability pathway work. And the third one is excitement. And that's excitement about all of the opportunities to make a difference.
As Canada transitions towards net zero 2050, where does the CHOA fit within the energy transition?
Certainly, Rachel, like this is one of the grand challenges of our times. The CHOA's role will be to help industry move past aspirations and find real pathways forward. Unquestionably, there's going to be a focus on technology and innovation, and unquestionably, there's going to be a focus on carbon capture sequestration and carbon capture use and storage. But as an organization, we're going to be thinking beyond Scope 1 and Scope 2 emissions to Scope 3 as well, because our industry needs to be thinking about how we can develop new value-added products to target specific customer needs. We're also going to be thinking and looking beyond heavy oil and oil sands. Like the CHOA, we're going to find ways to help to connect, share, and learn, our tagline, with other sectors and other industries, because we want to create the opportunities to leverage the experiences of each other so that we can all get there faster. And we're going to be thinking in terms of energy systems. So that's hydrogen, geothermal, renewables, small modular reactors, and decentralized distribution.
Thank you so much, Carolyn. You are so passionate and excited about the work that you do.
Thank you so much for your time today.
Thank you for watching Global Energy Show's 5x5 series. Make sure to like this video, share it out to your networks, and subscribe to our YouTube channel so that you can stay up to date with all of our new releases. We'll see you next week.
COSIA helps innovators like you advance game-changing technologies by leveraging resources, knowledge, and expertise to go farther, faster in clean tech innovation. Getting world-changing ideas in front of Canada's largest oil sands companies, providing valuable feedback, and a hand in navigating the innovation ecosystem. And for the projects that fit our members' goals, we're here to help foster an innovative partnership. We know the sustainable development of Canada's natural resources can support a low-carbon future, and that means improving environmental performance in every aspect of operations, not just emissions. That's where COSIA comes in. Collaboration is what we're all about. COSIA is a scientific and technical organization that brings together the best minds from across Canada and around the world to find clean technology solutions for some of industry's toughest environmental challenges in the oil sands, including emissions, land, water, and tailings. Find out how your ideas can be part of the solution.
Working towards net zero is becoming critical for industry, not just to meet regulations, but also to obtain investment capital. A lot of new technology is involved, but to get there, we often need to de-risk or improve our understanding of the technology and how to put it in place. Our goal is to be a catalyst for your energy transition.
The most important issues for industry to overcome are to maintain reliable operation while reducing their overall carbon footprint. SRC can help in the energy transition because we approach the problem holistically. There's no one-size-fits-all for these systems. And as technology has emerged, we've done a lot to store renewable generation and develop smart grids and microgrids.
SRC's Centre for the Demonstration of Emissions Reductions is geared entirely at helping industry clients reduce their emissions through reduction, capture, and conversion. We're looking at optimizing processes so that we use less energy and less water. We're looking at integrating a variety of technologies together into a larger picture of emissions reductions for our clients.
Amongst all the other renewable energy options, nuclear can be an important part of that energy mix. SRC's role in the nuclear industry can be that of an enabling partner. We've worked in the nuclear industry in the province for over 60 years, and we can help from site selection, licensing, operations, waste management, and decommissioning.
The critical metals will play a very important role in the energy transition. I think these are the fuel for this transition. The rare earths themselves, they are very important to produce the magnets, which are the key ingredients for your electric vehicles.
SRC services for the oil and gas industry and beyond have changed quite significantly over the past 5 or 10 years. The focus has shifted now to a great extent into reducing environmental impact. We work with our clients by evolving the current technologies and also connecting them to technology providers, as well as helping them with forming consortiums so that we can move all together as a joint industry.
Hello and welcome to Getting to Know Alberta IoT. I'm your host, Tyler Chisholm, and I'm happy and excited to be here today with the team from Alberta IoT. I've got our Executive Director, Brenda Beckendorf. I've got members of our board, Wilson Acton, Niraj Gupta, and Kevin Crow. So with that, I'm going to quickly turn the mic over to Brenda. Brenda, we just jumped into the elevator. We got 30 floors. Tell us about Alberta IoT.
Well, thank you very much, Tyler. So Alberta IoT is a 4-year-old organization. Our focus has always been to bring together the community to have a strong voice. And so our community consists of SMEs who are scaling up. They're $1 million, $2 million. They're growing, they're expanding, they want to get out into the market and become stronger. We also work a lot with the enterprise companies in Alberta and actually across the world. And they're wanting to connect and find out what's out there in the IoT community. So our voice is helping us find what the gaps are for this community. So if it's needing support to scale their company, which we've done with our business acceleration program called Fast Track, or whether it's turning around and making sure that investors are aware of us. We've been able to turn around and bring together different initiatives and programs to support this community. And what's exciting about it is our partners have come alongside us as well. And so wherever we do need support, we're able to bring those partners in to help our community. Our community has become bigger. It's expanded past Calgary, it's past Edmonton, it's past the rural areas of Alberta, and it's expanded into Canada and into the international
It's a very exciting thing as I've learned more about your organization to really understand that this is a 6-month-old company sitting beside a 40-year company. This is a company that has been incredibly successful in their space that's pivoting in. Your ability to bring together different groups at different stages is incredibly complementary to that, truly building an ecosystem that's balanced between existing and, existing ideas and new, fresh ideas.
Well, it's been exciting, and I'll speak to the Fast Track program where we have companies that are in that $1 million range that are scaling up and wanting to see what it's like to play in the international market and to turn around and hire new employees and try new things. And then we have companies that are in oil and gas, construction, engineering that are very well established, fairly substantial in size, but they're moving into the IoT community or into the IoT solutions, and they're trying to figure out what that journey looks like. So they're coming into our business acceleration program, the Fast Track, to try to figure that out. And so we've got these large players right beside our little SMEs, and that collaboration together is amazing.
That collaboration that we experience in Alberta, and I'm a bit biased, but I think that is one of our superpowers. And when I understand and really understand what Alberta IoT is doing, you guys are truly living that. I'll turn it over to Niraj for a second. Niraj, thinking a little bit about the optics and the view that you have when you look internationally, and as well as really making Alberta that destination of startups. Tell us a little bit about your initiatives around that.
Thanks. Hi, I'm Niraj Gupta. I'm the board director at Alberta IoT, and also I'm chief strategy officer with Adabotics, and I've invested in several startups as an angel investor. So I am primarily involved with the Alberta IoT with Center of Excellence initiative, and in that Center of Excellence, we are trying to help startups through our program called Fast Track program. And Fast Track program is primarily for these startups and primarily for scale ups, when we help them, mentor them in various facets of their startup journey and try to understand their objectives so that they can grow to the next stage. And it's a continuous process. And that's why apart from a couple of weeks of program, we are continuously engaged with them. And that's what the kind of what we are trying to do at Alberta IoT is trying to make Alberta IoT as establish Alberta as IoT and deep technology capital of North America. And in that process, we are trying to create this international ecosystem network. And we are seeing continuously that a lot of companies and startups and ecosystems are looking at Canada and trying to come to Canada and then trying to grow into North America. And that in that process, we have started working with several ecosystems in India and Singapore, Germany, Sweden, Ireland, trying to sign memorandum of understanding and trying to see how we can help each other. There was a program, a federal program in Canada called Startup Visa Program. And that Startup Visa Program is primarily given a license to either incubators, angel investors, or VC funds. And by that program, it helps institutions like us to give and support those startups which are outside Canada to come to Canada, and then support them and grow them. And that's the biggest initiative right now within Alberta IoT, when we are trying to figure out how we can also bring these scale-ups which are outside Canada within Canada. And apart from that, we are also trying to bring a lot of other ecosystem constituents, like we are setting up IoT Angels in North America. We are trying to create this network of Maker Labs within Alberta, which will help our members. And building this international ecosystem will also help our members to go and tap international ecosystems and the markets.
I get very excited about the idea of importing that type of talent and that type of excitement to Alberta. Maybe I'll ask you a very simple question. When you're speaking to, a company overseas, wherever they may be, what is the why Alberta? Why should they come to our ecosystem to establish their companies?
A very good question, because if you look at last 3 years of Alberta's startup journey, if you will, you have now more than 3,500 startups in Alberta. More than 50% of these startups are technology startups. We already have very well-established process. We had Nortel, we have Garmin, we have so many other companies and oil and gas ecosystem, which has primarily been inventing in IoT, in deep technology, in data. So we already had that kind of a DNA. However, because oil and gas was doing so good, at times, a lot of startups which were in purely AI machine learning were not getting that kind of a love. But during COVID, we have started looking at this international ecosystem. We have started looking at within Alberta what's happening. Look at what has happened with Cement, what has happened with Benevity, Adabotics, there's Neo Financial. There's so many startups which are growing to scale-ups and post-scale-ups. Benevity got acquired in multi-billion-dollar valuation. And that's one of the very important marker when you want to create this good startup ecosystem. So this is one of the very important pitch. Apart from that, government of Alberta province started this initiative called Invest Alberta. And Invest Alberta's mandate is to support the international startups to come to Alberta and connect them to all possible network, be it post-secondaries, be it AMI and LTML kind of ecosystem, UFA, UFC. So that pitch itself is very attractive. But since Alberta IoT is in Alberta, that helps these deep technology and IoT startups, because IoT is not easy. Hardware is very hard. And they need not only just mentoring, they need ecosystem, they need connections, they need access to the labs, and that's what we are also trying to do. We are also trying to help these companies tap that ecosystem.
Excellent. So thanks for breaking that down and really understanding the why behind it. Natural transition. Wilson, let's talk a little bit about the funding side of the house, because when we talk about these organizations, Niraj clearly mentioned all the things that they need. Certainly funding is part of that mix. Maybe talk to us a little bit about how Alberta IoT is paving the road for maybe what might be a new avenue of investment for investors, but also a level of sophistication for companies to get ready for that investment.
Yeah, it's a great segue. It's a great part of the conversation, and the way that we like to think about it is less that we're paving the road, because that implies that the road wasn't already there. We look at it more of trying to connect some of the threads that are already existing. One of the things that I always say is Alberta is a repeat entrepreneur, and Western Canada is a repeat entrepreneur. We've been a global leading business powerhouse in agriculture. Then in energy and oil and gas, and now we're rising in technology, and a large part of that is IoT and all of the pieces that comes around it. It's the hardware components of the sensors and the actual devices themselves, but also the data analytics and the AI and all of the things that kind of build on top of IoT. And in order to become a world kind of leader in these ecosystems as we have before, also requires capital, and it requires a community of one another. And so one of the things that we've seen, even before COVID, but I think accelerated because of COVID, is capital is becoming increasingly borderless. We've got expertise, all over the world that knows IoT and knows deep technologies and software businesses and all these types of things. And it's flowing to Alberta. It's flowing to regions where there's opportunities. And at the same time, Niraj mentioned, 3,500 companies that we've formed in Alberta, and that number is only growing. And it won't be long, and we'll be talking about that number on an annual basis. Well, if you think about it, that's like 3,500 new junior oil and gas companies that are starting up in this ecosystem, and those companies grow and mature, and they'll access, traditional capital, for example, bank debt from big banks, or kind of higher risk, early stage equity capital, startup capital, growth capital from equities, all the way through to the public markets. And so, we've got a deep history of growing and scaling businesses that are on the cutting edge. Like I said, agriculture first, then energy, and we're now doing it in technology. And so our role is really to help educate that. How can we help that investor understand, maybe it's the ecosystem, maybe it's the investment opportunities that are in this region, or it may be the risks. It's a bit different than a geophysical risk around an oil well that they may be used to investing in. How can they invest in this ecosystem? And then the companies need to be investor ready. How do they need to think about de-risking their story, telling their story, the financial models, the capitalization tables, and all these types of things.
So what I'm hearing loud and clear is, although this might feel new, we've been here before, and we've been able to conquer it and move forward. And like any cycle, we're in early stages, and as we better tell the story, and as people become more comfortable, things will start to move more readily. And I really like the position of, this isn't new for Alberta. This is just a new version of it that are going to work our way through. So thank you, Wilson, for that. So Kevin, when it comes to storytelling and actually getting this out there, which for a lot of times is exactly what we need to increase that comfort level, tell us a little bit about your position at Alberta IoT and how important and critical that story is to tell.
Yeah, as Niraj said, we want to make Alberta the most exciting geography around IoT and emerging technologies in the world. And so we see there, telling the story and amplifying the story is such an important part of what Alberta IoT has to do. There's incredible things happening in Alberta. And so we kind of see three muscles to doing this. The first one is we want to talk about the active demonstratable models of research and innovation and in companies that are coming to the marketplace in Alberta. We have incredible Albertans that are doing that work and incredible Alberta companies that are bringing it to market. We want to talk about the ecosystem here, that it's built on zebras. It's not just about unicorns. And zebras are so important because they herd together, they help each other survive and thrive. And that's what's happening in the Alberta ecosystem, that there's incredible partnerships and people are helping each other ensure that they're successful in the marketplace. And the third one is we want to make sure we're drinking our own champagne and telling those stories. That research, that innovation that's happening around IoT and emerging technologies is being put in place in Alberta. That's making us highly competitive on the global marketplace and a place to be to ensure that you have great success on that global stage. And that's the stories that we want to amplify.
And from moving from 0 members to 4 years ago to 175 members, I can only imagine that those stories are starting to write themselves. And I never want to take that for granted, but there's nothing more powerful than an idea whose time has come. And IoT in Alberta, and that underpinning is the traction that it's starting to get and the energy that's creating from it. It's a fantastic story.
Carbon capture and storage is just one of the tools in the toolbox to get to our Paris commitments. We are going to need everything. But CCS is very important. In order to get to net zero by 2050, we need over 8 billion tons to be captured by that time frame. Our organization has done this before. We have the staff that have hands-on expertise available to make sure that if you're going to get to net zero, you don't start from ground zero on these projects. CCS is proven. Canada has been operating a carbon capture and storage facility at a capacity of 1 million tons a year since 2014. Taking lessons learned from this facility, we can ensure that costs come down through iterations. We are going to need CCS in many sectors, obviously not just coal. It's going to play a vital role in reducing carbon footprints of various industries that don't have renewable alternatives. Cement, for example, has the ability to reduce energy emissions through efficiency, but 2/3 of their emissions come from industrial processes, and those have to be captured. Stay tuned this fall for a feasibility study coming out of Canada with Lehigh Cement and the Knowledge Center that shows a reduction of 780,000 tons of CO2 a year from a cement plant. Global uptake for CCS is going to be important as well. We're going to need incentives and financial tools that will drive it, and especially in developing countries where we're going to see multilateral development bank involvement, technology transfers, knowledge sharing, capacity building from developed countries that have done this before. What's very important is we can reduce costs through iterations, and no one should do this alone. We need to collaborate. Thank you so much to our partners here at this exhibit. Please reach out to any of us in order to have more information about carbon capture and storage.
I will be talking today about our digital innovation and clean energy program within my organization, Alberta Innovates, here in Calgary, Alberta. My name is Chris Dong. I am the Senior Manager of our digital oil field portfolio, as well as our recovery technologies portfolio. So I just wanted to give you a quick overview of Alberta Innovates as an organization here in Alberta. Our investments was about $190 million for the last fiscal year, 2020-2021. Our main focus with this investment and our work is to be Alberta's research and innovation engine, solving problems, creating possibilities. So within that, so we have about 550 employees split across our two subsidiaries as well, CFR and Tech Alberta, which provide additional research services that you may be familiar with as well. We have about 11 locations across Alberta, wide-ranging from both Calgary and Edmonton, as well as a number of different locations with specific technology capabilities and research capabilities. Within our investment focus areas, we're really looking at 4 core emerging technologies. So this is of interest and of note today, the data-enabled innovation, as well as the digital technology for business transformation areas that you see there. Within that as well, clean tech, which includes things such as carbon capture, storage, and utilization that you might have heard of, and you know, fairly well discussed as the rest of this conference, and then innovative projection and distribution, which is also part of the data and digital side of things. Within the focus areas of investment sectorally, 3 main focuses. So one is on digital health, one is on smart agriculture, and one is on innovative hydrocarbon projects. I'll touch on this a little bit further as we go on the presentation, but overall, our focus is basically looking at improving and supporting the entrepreneurial ecosystem and using artificial intelligence as a technology or platform technology that helps us achieve our goals throughout these core technology areas. Just want to make a quick note. So you may have heard already from Emissions Reductions Alberta today. Where does Alberta Innovates fit in terms of the technology development cycle? So I know a lot of you probably have heard of the technology readiness level scale. Generally, Alberta Innovates is looking to play in the TRL 3 to 7 areas, which is basically kind of conceptual, bench scale, lab scale, to first field pilots type of scale. In terms of the areas available funding, they're certainly able to support much larger projects, which Alberta Innovates simply does not have the financial capability, but there is a partnership available there for handing off to ERA, and we do work with them quite readily. Talking about the research and innovation framework targets. So we talked a little bit about how the focus areas are split out, but what are the targets that we're looking at to gain and as outcomes from these investments? I won't go through these in details, but you can kind of see methane emissions reductions, fresh water use, GHG emissions reductions from oil and other energy production, increasing electricity from renewables, improving value adds or improving the value of our existing products. And then on the environmental benefit side, certainly water use, landscape disturbance, biodiversity, etc. I'll just make a quick note that we do want to have a focus on that digital economy, which is the bottom right-hand corner there. So that brings me to the meat of our discussion today, which is the Digital Innovation and Clean Energy Program. So I'm actually very happy and proud to announce today to the group here that there's a new round of funding available in the Digital Innovation and Clean Energy Program. So this is a relaunch of an existing program that was initially started in 2020, but this new funding is making available $2.5 million over the next year and a half, with about $350,000 available per project. Very high level, DICE is essentially funding the development of artificial intelligence, machine learning, IoT, AR, VR, UAVs, etc. For use in Canada's energy industry and energy system as a whole. So it's not limited just to oil and gas. In terms of DICE projects specifically, the idea is to work within that TRL 3 to 7 level, developing technologies and accelerating them into market. And then on the outcome side of things, again, going back to those ARF targets, improving the efficiency of energy production as a whole, reducing GHG emissions, water use, and environmental benefits, and then again, creating jobs to the economy and building up towards that $20 billion digital economy. I mentioned that this was a second round of funding that was a reinvestment to the initial first round of DICE projects that was announced and completed in 2020 and 2021. And that was supporting 17 projects with $3 million of funding, which was further leveraged by industry and private funding to create about $16 million in project value. So I don't have time to go through a ton of examples here, but a few projects that I wanted to highlight today include Entwist, an Edmonton-based company that's using proprietary artificial intelligence technologies to help industrial companies across Alberta and globally as well, potentially reduce their costs and reducing environmental impacts. This is through a complex set of process optimization, and happy to discuss that further and connect with that company as needed. Galatea Technologies is another example, and they developed a waste coordinator platform basically to improve workflow, improve cost tracking, and insights basically to the waste disposal market across Canada, which is something that obviously is a little bit outdated, and through the use of their technology, able to tap into that value proposition. The last one I want to highlight here is Validare, which is again a digital technology company that is developing a platform helping buyers and sellers, transporters of petroleum products to find each other more easily and make those transactions much more efficiently, and improving the efficiency of the system as a whole. To the current portfolio slide, as you see here. So this is a snapshot of projects that are funded through but through DICE, through a tier program, through our Alberta Innovates Base program, as well as through partnerships with ERA as well. So I won't go through this in too much detail, but you can see that there's a very broad portfolio here that's looking at everything from, again, that IoT side of data acquisition analysis, and then using some machine learning technologies to produce those insights, prediction, and then if we look at all the way to the right-hand side, obviously certain applications to automation using AI. So I think there's a healthy and broad portfolio here, and there's certainly space to add additional technologies and add additional applications and use cases. And that's what we're looking for in this DICE 2.0 round of funding. Without going into too much detail here, I just wanted to post a couple links. So one is on how to apply, which is the program and details, supporting documents, including the program guide with all the detailed criteria, as well as requirements and prereqs for organizations looking to access this funding. And that's on the Digital Innovation and Clean Energy page as posted here. We are holding a webinar on Thursday, October 28th. From 3 p.m. to 4 p.m. Mountain Time. This presentation will be recorded, so if you do miss this, webinar, don't worry. That will be recorded, and the Q&A will also be available after the event as well. In terms of accessing the online portal itself, that link to the Smart Simple portal that we use for all Alberta Innovates proposals is posted there. And at any time, if you want to discuss eligibility for the program or have specific questions, even to connect with past participants or past funded projects that you may be interested in working with and collaborating with, please let me know. I can certainly facilitate that and answer any questions that you might have. So my contact information there is there below, and I'm sure that will be shared as well as part of the presentation package after the conference. Thank you for your time, very much appreciated, and thank you for the invitation to speak. Hopefully I will be able to connect with some of you in the future, and thank you very much. Enjoy the rest of your day.
The ACCTC, the Alberta Carbon Conversion Technology Centre, started with an idea to do something with a waste stream of CO2 to make it into a valuable product. And in order to test the innovators in that space and to have real live innovation happening on the ground, they needed a test center. And so the ACCTC became that.
This CO2 capture system is designed specifically for the purpose of R&D. We have 5 independent bays, which means that we can accommodate 5 researcher and startup company at the same time at center. For each bay, we deliver a flue gas, which is directly coming from power plant. We provide them natural gas, utility water, power, as well as high concentration CO2.
It's a one of a kind in North America. Any company that wants to come in and validate and de-risk their technology as it relates to either capture or utilization can come here.
One of the unique advantage of ACCT is that we are able to get a flue gas directly from power plant and bring it and deliver it to our client. But meantime, we do have a CO2 capture system which is able to take this flue gas at higher concentration and deliver a high concentration CO2. Another advantage is our vicinity to the city of Calgary, which is a metropolitan city with tons of engineering skill and capability available for any technology developer who they come and they want to test here.
Given the need for CO2 emissions management solutions, we're quite confident that we will have clients come into the space. Some will be large industrial clients bringing in their technology that they want to innovate on and de-risk and validate, and in other cases it may be entrepreneurs that come in.
The idea is that we open the door for a client from all around the world. The idea is that we make Alberta a hub for technology development in the area of carbon capture and conversion, and to have all the expertise and skill set here to help all the innovator and technology developer from all around the world to come to the Alberta and demonstrate their technology here in Alberta.
We have unique facilities, capabilities, and capacity in our people that you don't find anywhere else. And they're meant to take things through the maturity stages of technology development before you get to the commercial scale. Our hope is 3 things. Number 1 is greenhouse gas emissions reduction. Number 2 is help diversify our economy as well and take us into some novel directions that we hadn't even imagined before. And number 3 is for the technology to be adopted by industry here in the province. We can have a much larger leveraging effect on both of those first 2 by having some of our major sectors that we've relied on for many years in the province adopt the technology and move forward.
Hello, my name is Eduardo Panzira, Managing Director of ENERGY4.0 Carbon Solutions. Climate change and the drive to net zero will dramatically change industry over the next decade. Companies that maintain the status quo will face shrinking markets and profits. Companies that implement carbon management will enjoy unprecedented growth opportunities. Ionada's carbon capture technology is the key to enable industries to make that transition. Ionada is the first to market with a patented carbon capture system for small to mid-sized carbon emitters, less than 200,000 tons per year of CO2. Ionada's containerized modular carbon capture system provides a compact and affordable solution for 85% of the industrial carbon emitters. Our target industries include the oil and gas, waste to energy, and marine sectors with no alternative path to net zero. We have successfully completed multiple pilot projects, a quality management team with deep expertise in the target markets. Our National Gas Innovation funded pilot for once-through steam generators to enhance steam-assisted gravity drainage, and a letter of intent for 18 carbon capture systems. Our team includes experienced and successful entrepreneurs, highly skilled engineers, and strong financial leadership. Carbon pricing has increased more than 300% in the past 5 years and is expected to exceed $100 per ton within the next 5 years. Large emitters, those greater than 200,000 tons per year, contribute to only 15% of these total emissions. 85% of the emitters are from small to mid-size, less than 200,000 tons per annum, the target market for Ionada. Competitive carbon capture systems require significant capital investments to build large and complex chemical plants that are only suitable for very large emitters, greater than 1 million tons per annum. Ionada provides small to mid-size emitters access to compact and affordable carbon capture systems. Ionada's sector focus is on 3 key segments: the oil and gas, waste to energy, and maritime. Ionada's key innovation is a combination of 2 proven and mature technologies. The first is the use of amine solvents with over 70 years of proven and reliable performance. And the second is the use of hollow fiber membrane contactors. Our proprietary hollow fiber membrane contactors have an extremely high surface area. In fact, if you were to take a sugar cube of that surface area, it would cover an entire football field. What this looks like physically is similar to a cross-flow heat exchanger. Exhaust gases pass over these membrane contacting tubes. The amine solvent flows through the inside of these membrane tubes, wets the pores of this very high surface area, and absorbs and strips out the CO2 from the exhaust. The benefits of the Ionada carbon capture system is that it's 30% more efficient than competitive systems, with a carbon capture cost of less than $50 per ton of CO2. The system itself is modular and containerized, utilizes regenerable absorbents that are proven and safe. The system itself is simple to operate and maintain, and it's ideal for small to mid-size emitters, and can be easily scaled up with additional units. A common question is, what do we do with the CO2 once we've captured it? Ionada has partnered with a number of CCUS partners for both carbon capture sequestration, EOR, as well as carbon capture utilization, which includes methanation to produce renewable natural gas. We are seeking financial and strategic partners to assist us with our pilot projects and to deliver the next generation carbon capture systems within the next 24 months. Let's explore how we can help you succeed in carbon management. I invite you to join us to helping build a carbon-free world.
Let's talk about maps. Maps are beautiful, informative, and they've been with us for centuries. People use maps to plan, navigate, communicate, and collaborate. Nowadays, we use maps on our mobile devices and computers. But for the vast majority of companies, these tools are either too simple or overcomplicated. Many companies choose not to map their projects, relying instead on complex spreadsheets with no context. To effectively collaborate on projects, you need to accurately coordinate and plan on maps. But how do you do that with what we've got? Without the proper tools, information is lost, deadlines missed, costs overrun, and time wasted. The solution is simple: Matador. Matador is the mapping collaboration platform that makes planning and coordinating in the real world simple. Using the Matador web or mobile app, create and visually manage projects anywhere in the world. Here's how it works. With Matador, you can search a location anywhere in the world and create a project. Use preset or custom templates to track all relevant project data. Assign tasks to your team and send them reminders. Streamline communication by tagging people and locations in comments. Upload site photos, files, and geospatial drawings. Annotate points and areas of interest with intuitive drawing tools. Connect to in-house databases to display relevant details like budgets and more. And easily export your project for reporting in your preferred format. Tired of paying per-seat licenses? At Matador, you have unlimited user accounts, which means you can collaborate with anyone from your team, clients, or vendors without worrying about additional costs. You get the power of collaboration and GIS in an intuitive web and mobile application, and you can rest easy knowing your projects are under control. With Matador, you can focus on managing your projects no matter where they are. We'll handle the rest. Visit matador.com to chat live with an expert.
Hello, I'm Ian Cunningham, CEO of Wave9 Technology Incorporated. Wave9 helps producers reduce costs and risks by automating operations workflows using a cloud and AI-enabled platform. I've spent most of my career developing software and control systems for wireless communication, with some recent experience in software solutions for asset management. In that time, I've been surrounded by friends and colleagues working in the energy industry, and as I learned about field operations, I saw a tremendous opportunity to help bring the technology I was familiar with to bear on the challenges they faced in the field. So in 2018, my team began meeting with production foremen to map the maintenance and inspection process, and we found that most producers repeated the same set of challenges. They are trying to reduce costs in response to pricing risk, and to achieve this, they wanted to reduce site visits. They also wanted to track progress on ESG metrics and objectives, but they often felt like these were opposing goals. And that has a lot to do with the traditional well site inspection process, which simply doesn't scale very well. Typically, that process looks like this. An operator will get in a truck and drive around to about 50 well sites each day. They don't know what they'll find, so they may not have the right tools or parts when they do find something. And it might take them all day to find the one site that's offline. In that time, the producer's either losing money on that site, or they may have a leak that's been spreading for a day already. Wave9 enables the operator to see up-to-date status of all of their assets and plan their workday before getting in the truck. We do this using a software platform that takes in data from cameras and sensors in the field. They can be existing sensors, or they could be a cost-effective hardware package that we offer as well. Either way, the data is analyzed, filtered, and displayed on a dashboard, which is customized to each individual operator's run. This way, they get information that's personally relevant by checking their app for just a few seconds. The result is a system which can be implemented across a wide variety of equipment to reduce response times to operational and environmental incidents by up to 90%. It vastly improves the productivity and inspection workflow, and it reduces exposure hours by up to 85% for remote or lone workers in hazardous areas. We talked with operators, area foremen, and engineers to understand how each role processes and uses information from the field. And then we developed our system to present that information in a way that best suits the needs of each role. For operations staff, we prioritize work actions so that everybody's time is spent working in complex actions that require human involvement rather than being wasted on driving from site to site. Now here's the app itself. An operator can see within seconds what the status is for every asset they are responsible for. And from there, they can open sites that the AI has flagged for further review. For area foremen, we have a view that helps with field-wide visibility using a geomatics overlay. And for production engineers, we share the data through standard queries or cloud messaging. This screen is showing a deep dive on power measurements where we're assessing a pump jack's balance and generating a surface card for production diagnostics. Our hardware can easily be installed by operators themselves in as little as 3 minutes by magnetically attaching the equipment, aiming the camera at the wellhead, snapping the power sensor on, and turning on the system. The ease of installation and overall ease of use is a key factor for our early adopters. One challenge we often hear is that other systems are siloed and require field staff to log in through many interfaces, dig up raw data, analyze it themselves, and then finally decide on a course of action. Wave 9's system is designed to keep the asset under the operator's responsibility while providing them with the right info at the right time so that they can continue in the same role with the same responsibilities. And here's an example of the kind of leak that we were able to detect using artificial intelligence. So the well that's being shown was installed, and then about 2 weeks after the installation, the packing seal started to fail. The photo at the top here is showing what it looked like prior to the packing leak. The operator had actually been to the site in advance of this photo, and then the packing leak started. About 2 hours later, we took the second photo. That photo was flagged by the artificial intelligence and resulted in the operator heading back out to that site within 2 hours of the initial leak beginning. Had the system not been in place, that leak would have progressed and got worse for another 24 hours or more, potentially leading to the packing completely failing. Now, today we're seeking pilot opportunities with producers of which to engage with us on a project of 20 to 40 sites of any type. We really want to demonstrate the potential ROI and the measurable benefits. For instance, our lead customer is achieving an ROI of above 350% annually now with the system installed on the fields that they have it in. We also want to explore power efficiency improvements and integration with other data systems. My email is ian@wave9.co, and my other contact information is listed here. I'd like to learn more about your unique challenges that you might be facing, and I look forward to connecting. Thank you very much.
My name is Jeff LaFrenz. I'm the co-founder and CEO of VizWorks. VizWorks is a software solutions company. We work with clients who have critical business needs that are not being addressed by anything available currently on the marketplace. This is being done through the appropriate application of advanced technologies like augmented and virtual reality, artificial intelligence, data visualization, geospatial visualization, and so forth. Really, ultimately, we're not a technology company. We are a solutions provider, but we have a tremendous depth of experience in the applications of technologies to create those solutions. Working at the University of Calgary, a number of people recognized that the transition process of getting technology from the proof of concept to commercial use was a bottleneck. We spun VizWorks as a company to really address that bottleneck, to have one leg in the academic world, to really understand what's going on in the development of new technologies, and the other leg in the commercial world, and understanding what the business needs are that drive the applications of those technologies. This is the reason why we created VizWorks. Construction industry, from residential to commercial, industrial, governmental, you name it. One of the endemic issues is rework costs during construction. One of the primary causes of rework is issues with the design that are not noticed until you're in construction. Trying to look at a blueprint or even at a 3D model on a screen doesn't give you the true spatial sense of what you're looking at until you actually start construction. Applying augmented and virtual reality technologies to this problem, we've created an interactive design review solution that allows people to really fully engage and understand and literally walk through a facility the same way they'd walk through the facility when it's completed, but do so while they're designing it. Right now, when you want to have information about what's going on in the world around you, you have to go through a device of some sort. So it's an app, or it's a phone, or it's your computer, or whatever it happens to be to get access to the digital world. Augmented and virtual reality are blending that into your common interaction with the digital world by overlaying information right into your field of view so that you don't have to have a separate digital experience. This enables you to engage with and understand data in a way that's timely, so it's basically the right information at the right time in the right way to allow you to make the decisions necessary for your life. I see tremendous opportunities ahead of us to do really leading edge, bleeding edge type of technology applications to really address some of the critical business needs that are out there for which there has not been the ability to create solutions till now. We're really excited about the opportunities that exist globally. Although we have a strength in supporting the local industries here in Alberta, the oil and gas industries and a variety of other ones, What we've found is that the solutions and the capabilities that we've created to support these industries have a much broader opportunity base. So we work now in a variety of industries that include everything from oil and gas to construction, manufacturing, aerospace, defense, and so forth, all based upon originally doing work for local Alberta companies. So we really see the opportunity to leverage the strength and opportunities that exist in the industrial base here, but to go after the global opportunities that exist elsewhere.
ENERGY4.0 is a company focusing on revolutionizing the industrial design process. By utilizing the technology developed by VisWorks, specifically Panoptica, we believe we can fundamentally help the design implementation process be much more efficient and precise.
ENERGY4.0 software platform is a SaaS-based model called Panoptica. It allows you to automate your BIM data process effectively, ensuring increased productivity is achieved. ENERGY4.0 has enabled for our customers, when using the Panoptica platform, the ability for team collaboration in a one-to-one scale, real-time environment, anywhere, any place, and any time, and in any environment. Panoptica was designed with true collaborative project team in mind. This increases higher productivity, allowing for much improved operational improvements and efficiencies in core areas of your engineering BIM data process.
Panoptica was developed with the engineering project manager at its focal point. We didn't just want to create a viewing platform, there are many of those, but rather wanted to create a visually immersive production experience that would allow teams to collaborate in a much more intuitive way. There are many disciplines involved in creating anything new, and we wanted a way to connect all of those individuals seamlessly. Panoptica will allow collaboration and discipline-specific task coordination, a viewable platform that can be utilized on multiple platforms, including virtual reality, augmented reality, web-based, or iPad. Rather than waiting for a design review or operations input, coordination can be done automatically and efficiently by tagging and assigning tasks to individuals as required. The system then will become a single source of truth in the design complex. Panoptica will be a full lifecycle platform. Our first module, Panoptica Review, has already proven to greatly reduce rework costs associated to projects by catching errors early in the design process. We can do this because of the one-to-one scale representation we portray in any mixed reality platform a customer wants. In addition to this, Panoptica Review is being further developed to become the management platform for engineers and owners alike. Having been in the space ourselves, we have many ideas we are planning to implement into the platform, and we're just getting started.
ENERGY4.0 is on a mission to become SaaS leader within the mixed reality for industrial design within the engineering sector using Panoptica, our award-winning software platform. Just recently, ENERGY4.0's Panoptica platform was successfully chosen by one of the largest global engineering, procurement, construction companies for global deployment. And as a result of initially using Panoptica in an immersive mixed reality real-time collaboration trial, this customer, with all their BIM data pre-build planning phase, found significant cost savings and operational efficiencies in the millions of dollars in improvements towards operational safety, as well material costs and other related costs. Only through the use of Panoptica's mixed reality workflow automation process could this customer have achieved such significant savings and findings for improved operational safety. My name is Charles Edmonds, Chief Revenue Officer at ENERGY4.0, and I bring over 25 years of senior level sales leadership experience in software and technology. I've previously been involved with some of the top global technology companies, and now have joined ENERGY4.0, where we look to expand our SaaS platform, Panoptica, critical to key global markets. One of my key business mandates is we adopt commitment to customer success, ensuring our sales operation teams are always putting our customers first.
I'm Dustin Welks, CEO of ENERGY4.0. A chemical engineer by trade, I worked on the petrochemical design of various industrial processes all over the world. After that, I transferred what I knew about engineering into its practical implementation as a construction contractor. We were very fortunate to grow during the energy boom from 2008 to 12, and ultimately divested to a large international engineering company in 2013. From that point on, I have made it my goal to immerse myself in technology in its many different disciplines, from augmented reality to robotics. At ENERGY4.0, I believe I have already come full circle, marrying my practical experience in process engineering and construction into its technological implementation in mixed reality.
To get more information on our SaaS platform, Panoptica, and how it can address your business needs, feel free to visit us at our website, ENERGY4.0. There you can even look to book a demo and experience how your project teams can truly collaborate in an immersive mixed reality way. We'll ensure it works.
Hello, my name is Paul Ritchie. I'm the COO at Ausperity. Ausperity is an intelligent visual monitoring platform for industrial operations. Ausperity assists companies to reduce their operational costs, mitigate safety and environmental risks through exception-based alerting, virtual asset inspections, and monitoring. Please keep watching to learn more about what we do. Thanks for watching.
In the face of global competition, unpredictable commodity prices, and increasing regulation, companies in oil and gas and other heavy industries need to reduce costs while also mitigating safety and environmental risks. Introducing Ausperity, the intelligent visual monitoring platform for industrial operations. Ausperity cost-effectively captures massive amounts of data from any number of visual sensors. It then analyzes this data with computer vision, a type of specialized artificial intelligence, and delivers personalized and actionable alerts for exception-based management. With the ability to connect to SCADA and other industrial systems, Ausperity also provides visual alarm validation for improved incident response. Customers are experiencing 30% productivity gains through remote site inspections. Driving to site is expensive, hazardous, and polluting. With Ausperity, operators simply log in to see images and video of their assets and create visual reports for information sharing and collaboration. These inspections are also used to validate SCADA alarms through a single dashboard. Powered by computer vision, Ausperity accurately alerts on vehicle and people activity, even under the most challenging conditions. Customers can verify the safety of workers, monitor work performance and invoicing, and protect assets in production from theft. With these proactive solutions, customers have realized a 1-year return on investment of more than 200%. Ausperity is also used to address critical environmental challenges, including remote monitoring of pipelines in environmentally sensitive areas and cost-effective detection of methane emissions at facilities. Through improved incident response and reporting, customers are protecting the environment while also mitigating financial and reputational risk. Ausperity's bandwidth-efficient technology can be cost-effectively deployed over cellular networks and can work seamlessly with legacy cameras to make them intelligent and connected. Ausperity is delivered as a complete managed service, and customers simply log in through any browser to enjoy the benefits. Find out how Ausperity can help your operations. Contact Ausperity today.
Hi, I'm Chelsea O'Connor, Business Development Manager at SFC Energy Canada. We provide clients with highly reliable off-grid energy solutions using fuel cell technology. Typically, we're helping transition the industrial marketplace away from combustion-producing methods of power generation and over to clean solutions utilizing renewable power sources with fuel cell backup. This could look like hydrogen fuel cells, or this could look like our direct methanol fuel cell. Perfect.
Hi, I'm Amardeep Sibia, founder and CEO of Drishya AI. Drishya means vision in Sanskrit. AI ML is poised to drive unprecedented operational efficiency and productivity gains in the oil and gas industry. With tons of production data accumulated over the years, AI is now interpreting, analyzing, and modeling this data to enhance production and to extend the life of assets. The advantages include billions in savings from productivity improvements, reduced resource use, lowered emissions, improved asset reliability and safety, better decision making, and reduced costs. Today, we showcase two of our AI-based innovations that are helping our customers reduce the cost of doing business and accelerate their AI and digital transformation by adding brains to data. Our first product, Brains, provides operational intelligence from historian data. For years, the industry has been collecting a treasure trove of data from historians, SCADA systems, and instruments, which can make operations efficient and less costly. Brains uses AI to discover plant behavior from historian data for building autonomy around issues like failure forecasting energy efficiency, and production optimization. Brains can profile the equipment from historian data, categorize assets in similar health states, learn trends, identify anomalies, and predict failure, leading to better asset lifecycle management. Brains uses AI to create soft sensors to provide modeled readings and predictions of plant operations by learning the behavior of the plant. They improve decisions around chemical dosage, operational efficiency of evaporators and boilers, downhole measurements, and test data assessments. These soft sensors can generate predictions every few minutes or hours. They eliminate the need to deploy costly instruments or perform costly manual analysis, thus saving hundreds and thousands of dollars. Brains also adds intelligence to alarm data. Brains uses AI to learn which alarms occur in particular sequences, and thus it learns plant behavior. It uses this learning to identify in real time if an alarm is due to a failure or due to noise originating from operational changes. It can help in eliminating noisy alarms and understand and predict plant startup sequences. Therefore, it can exponentially contribute to operator effectiveness. Finally, Brains can perform extensive analysis of work logs. It identifies and predicts common problems, failures, and issues, their root causes, and aids in better decision making for downtime and maintenance planning. Artisan, our second product, is an AI-enabled engineering digitalization solution. It thinks and acts like an engineer. It uses AI to quickly see, read, and understand drawings like piping and instrument diagrams, learn how things are connected, and create a digital twin of the plant. Complicated tasks like fugitive emission studies, which usually take 50 to 60 hours, can be done accurately and consistently in minutes, leading to 80 to 90% savings in time and money. As Artisan analyzes PNIDs, it can create and update various lists like equipment list, instrument list, load list, IO list, line list, etc. It can resolve naming issues and identify design mismatches, hence saving thousands of hours of effort. But Artisan can go beyond single PNIDs. It can connect PNIDs together, discover which subsystems are connected to each other, and thus learn plant design patterns and identify design variances and errors. Therefore, Artisan converts paper and drawings into data and intelligence. Artisan and Brains combine to bridge the gap between oil and gas operations and the world of data. They can help with swift and accurate predictions, recommend actions, save time, money, resources, and reduce environmental impact. Drishya's AI solutions are helping oil and gas customers ranging from EPCs, conventional and SAGD operators, and midstreamers. The Drishya team brings over 250 years of combined expertise in AI/ML, industrial analytics, and financial engineering. We bridge the engineering excellence of Calgary with the fast, frugal software ecosystem of Bangalore, and we are supported by all of these organizations. We look forward to helping your business attain greater efficiency and optimized performance with our innovative AI for clean energy solutions. We can be contacted via the web, email, LinkedIn, and Twitter. Thank you.
Hello, my name is Joseph Halati, and I'm the president of LuxModus. Thank you for stopping by our virtual booth. We are LuxModus, the energy industry's innovative, low-cost 3D mapping technology provider. LuxModus was born from the pipeline mapping industry and has evolved to be a leader in low-cost 3D mapping for all types of energy assets. Leveraging our easy-to-use collection platform, our partners and customers create data-rich 3D maps at a fraction of the time and cost of traditional survey and mapping techniques. Turned around in minutes versus days, our advanced LiDAR and imagery system creates 3D models of energy assets, whether they be pipelines, oil and gas sites, or facilities. At LuxModus, we work with our data collection partners, such as field data collection companies and survey companies, to ensure that our end customers have the data they need for their assets. Working closely with First Nations-owned companies to empower Indigenous people with world-leading technology is one of the aspects of our business that we are most proud of. But how do we do it? Well, over the past 3 years, LuxMotus has been working with owner-operators and other industry partners to develop a world-class automated mapping system. Based on autonomous vehicle mapping technology, our 3D mapping system, called LuxGear, leverages advanced laser scanning and ultra-high resolution imagery to create 3D models of your assets in near real time. Rapidly set up and deployed, field collectors simply drive around locations with our LuxGear platform to capture data. In most cases, users of our system do not even have to get out of the vehicle when collecting data. For most well sites and field facilities, collection teams are only on site for a matter of minutes. Collecting data so quickly and being on site for such a short amount of time also ensures that our field collection does not interfere with the regular day-to-day operations of pipeline construction or regular asset operations. Most of the time, field personnel do not even know that we are there collecting data. Data collected in the field is uploaded to our Lux Cloud platform, and within minutes it is processed and a 3D model is available for visualization and downloading. This same model, or 3D data, can be used in any geospatial or CAD system with no transformation or reprocessing, as our data is provided in industry standard formats. One of the greatest differences between LuxMotus and other mapping technologies is that we have taken the required hardware and software internal, so that you can avoid the cost of people, software, and computers to create your 3D data. We do all of that automatically for you. In addition to drastically lowering the cost of creating 3D maps, at LuxMotus, customers also only pay for the data sets that they end up using. This is a further cost reduction for our customers. Unlike the traditional time and materials survey and mapping methods, the LuxMotus approach allows you to collect the data, but actually only pay for the data you end up using. This is a great advantage to our customers and provides a tremendous amount of cost certainty to their projects. In addition to asset construction and operations and maintenance, our technology is particularly well suited for reclamation and abandonment projects. Users of our system can quickly go to the field and map several sites in one day and have that data available within hours. This enables office personnel and consultants to quickly review the data and use the data in various planning, engineering, and project execution work. One can see how low-cost rapid mapping with a quick turnaround can be useful for site assessment and pre- and post-project completion reporting on reclamation or abandonment projects. In times like this, we are all working from home more and collaborating less in person. We are also spending less time in the field. This makes the need for accurate, reliable, and current mapping more important than ever. LuxMotus's rapid mapping technology is empowering the energy industry with 3D data that is easily and readily viewable and interrogated. To learn more about how LuxMotus can empower you with 3D data, contact us at sales@luxmotus or visit our website at luxmotus.com. Thank you very much for your time.
Hi there, this is Don McClatchy with Computer Modeling Group, and this next session is going to delve into the massive enablement that reservoir engineers are achieving using a cloud compute environment. So the modern drivers for reservoir simulation really center around two main things. You're trying to maximize your production and recovery factor, your employee efficiency, your resource utilization, really your revenue and profit. At the same time, you're trying to minimize risk around uncertainties in geology, operational considerations, economic environments, and price volatility. Really, it's about maximizing your return on investment. So for an engineer to optimize means doing more with less. Over the short term, you're optimizing individual wells, the well design, the completion design, the frac design. Over the medium term, you're trying to optimize the way you're operating your fields, looking at pressure distribution, looking at water injection or polymer injection, looking at steam distribution, these types of things on a field-wide basis. And over the long term, you're trying to optimize the entire asset portfolio, determining which assets to keep and develop, which ones to hang on to, and which ones to divest yourselves of. But traditionally, there's been some challenges in handling the amount of simulation work needed to do all of these different tasks. Highly variable workloads mean one day an engineer might do 2 or 3 simulations, and the next day he or she might do 200 or 300. Model level of detail ranges from small 2D models to massive full field several hundred grid block models, with a range of complexity depending on the type of process or in fact EOR process that's being investigated. So clearly there's a need for simulation, but with limited hardware and software in a traditional office, it's been a challenge. Now that we have the cloud compute environment, though, this has changed. There's no more queuing up jobs one after the other, waiting for them to be done. You can run them all at the same time. The system's instantly scalable and flexible, and thanks to the resources available from the major cloud providers, there's massive multi-core capability, thousands of compute cores at your fingertips instantaneously. And each one of the compute nodes are optimized specifically for reservoir simulation. And you can see an example in this plot on the right. As the number of cores are increased tackling a job, the speed to get the job done increases significantly, and the actual cost per job comes down using more hardware. So here's some other good examples. Traditionally, many models were run on single 4 or 8 core desktop computers or maybe a shared compute cluster. Now that we're in a cloud environment, your resources start at 8 cores, up to 32 on a single node. And if you get into a multi-node environment, you're looking at as high as 2,000 cores tackling a single model. Speed up's not linear, but as you can see, the results are drastic. This first example here, 55 well pairs of 6 million grid blocks. On a 36 core machine, it was 61 hours. In the cloud with 500 plus cores, you're talking 13.5 hours. 100 million grid blocks in this third example goes from 463 hours on a single machine, move it into the cloud with 1,000 cores, and you're down to 170 hours. It's a significant improvement for the engineer. And when we talk about these optimization workflows, we're talking about optimizing things like net present value, well spacing, geologic realizations, history matching, frac sizing, all these different things. They can be optimized if you run enough iterations to come to the ideal solution. And you can see here in this plot where each dot represents one simulation job run, there's a normal workload that consists of anywhere from 5 to 50 jobs a day, but there's also optimization projects, which can be 500 or 1,000 jobs in a day. And this is what cloud compute allows you to do in a very short time frame. So whether you're doing optimization of an unconventional resource, looking at fracs, well spacing, types of EOR processes, or you're involved in heavy oil, SAGD, trying to optimize steam injection. You can see in this example, after several hundred iterations of running a model, they're able to reduce steam oil ratio by 24%, oil production's up by 42%, or even just optimizing your completion based on local geology. Cloud compute is an enabler. Operational decisions can be made on a shorter time frame. Cost reduction is greatly enhanced and uncertainty is greatly reduced. So this has been a massive enablement for reservoir engineers. Thank you.